international management major with minors in Spanish and religion. I was on the women's hockey team all 4 years, so that took up a big portion of my life. When I think of Gustavus, I think of optimistic possibilities and people that can and are willing to actually strive for them. I would say that joining GWIL was probably one of the best decisions I made while I was at Gustavus. Through a lot of the different workshops and just meeting a lot of different people, and you get to know what your leadership style is like and what it's not like. And both of those things are really good to find out. And a lot of that, especially as a woman, you don't necessarily always think about yourself as a leader in a workplace sense or on a team or anything, and especially if you haven't been exposed to the working world yet. What makes GWIL so unique is that it feeds itself, in that the people that join will eventually be giving back to the newcomers all the time, and the newcomers are contributing to this big GWIL organization and making our alumni group even more impactful in the world and making us stand out amongst the MIAC, amongst Minnesota, and amongst the world. I see GWIL having an impact in the sense that it connects a lot of different students together. So it's not just one major by any means, but it's connecting like-minded people. So people that they have a purpose in life, or they want to find out what their purpose is in life and apply it in a servant leadership way.
I think it's a good idea to do this because we think like all of our actions are very little and it doesn't affect the world in a larger context.
On the surface, it's about the stuff stuff we buy, the waste that's produced by that, what happens when we throw it away. But I've come to the conclusion that it's really on a deeper level, it's about community.
We're part of a much greater community. This is a global community we're doing, and like our actions affect this.
We're really trying to reduce the waste that we do produce. So something we've been pursuing is composting on campus. Currently we have compost bins in the campus center, the main building, and we have a composter towards the back of our campus. So that is really trying to get items that would traditionally go to a landfill out of those areas and into the compost to produce soil that is used to produce food.
Every time we're putting something in a trash can, every time we're putting something in a recycle bin or the food waste composting container, it's a human transaction. There's somebody on the other side who has to take care of it. Or if we don't take care of it properly, there's somebody downstream who's suffering because of what we do.
Just stop and think, where does this go? Is this a compostable item? Is this a recyclable item? Or does it go to the landfill?
So when you're approaching the 3 bins, the compost, recycling, and trash, just be aware of what goes in there. Just give it some second thought, like, oh, this should go in there.
We're setting a big goal here. We want to divert 90% of our waste to something other than a landfill or incineration. We want to recycle it, we want to put it to beneficial use.
I think as individuals, we can create that small change, but we need to come together as a community to create that greater change.
The food waste that's produced on campus is taken to our composter. It's then turned into soil, and that soil goes into our Big Hill farm, where we also then produce things like lettuce and radishes, and that goes back into the cafeteria.
Students are the reason we have Big Hill Farm. They're the reason we have food waste composting. Our students build our community. They come, they bring themselves, they bring their efforts, and they leave us a better place.
Sustainability really is a gusty thing because it considers the community that you're a part of. So it considers the people that produce food, how you consume that food, and what you do with the waste after that. It really is about caring about all those people that contribute to that system.
And it's not either take care of the environment or take care of people, it's one and the same.
I'm trying to give the incoming students essential information so it can be passed on to the new wave of students, so we could create a long-term change.
How can I help someone else with this? How can I make someone else's life better? And a decision to recycle well, to make a good choice when you approach those containers, is a decision to make somebody else's life better. It's a way to do something right by your fellow community members.
Because Gusties don't just think about today, they think about tomorrow.
So many of the different fields in science, most people aren't exposed to in their day-to-day life. The more you can get out there and communicate to the young people coming up that are the future of science, the better. You never know what's going to grab one individual, and so that's vital to inspire the next generation.
The Nobel Conference brings together students, faculty, and members of the general public to explore revolutionary, transformative, and pressing scientific questions and the ethical issues that arise alongside of them. We bring leading researchers to Gustavus, including nearly 100 Nobel laureates. We're trying to explore the ideas of science using all of the liberal arts. So the arts, the humanities, the social sciences, all of them working together.
There are a lot of people who are not scientists who like to share in the adventure of discovery and to be able to share that joy with people who also get it, that there's something really exciting and cool going on. It just makes it just an enormous amount of fun.
There's sort of a festive atmosphere, which makes it part of a broader experience.
There aren't that many forums for us to have the discourse at that level with that sort of range of expertise, yet still focused on one sort of overarching topic.
One of the wonderful things about the Nobel Conference is it does give people the opportunity to ask people questions in an informal way. And you never know what statement somebody makes or what interaction that happens will make a change in somebody's life.
It's always very, very encouraging to see other colleagues of yours who are at the top of their game, and it makes you want to lift your game.
As you can feel the audience, and you can really feel when you've helped people to know something that they never knew before. It's really a feeling of discovery that you share.
What drives you? What do you long to be? A leader, a healer, an educator, an innovator, an explorer? We believe that whatever you dream, you can be. You can make a difference, make friends, make connections, make change, make the best life you can. Make your life count. Gustavus Adolphus College.
Fly fishing is visual. It's all about what the fly does on the water. The fish have no idea how it got there. You might have the ugliest cast in the world. There's something pretty special about watching a trout rise. Just sitting there. You can just sit in the bank and watch a trout. My life has kind of continued the same way as my life at Gustavus. You know, I played sports. I was in the symphony, ended up as a political science major. It gave me the opportunity to do kind of all sorts of stuff. One of the coolest things about Gustavus is I went to Ecuador, went to the Galapagos, went to the rainforest. That gave me quite a travel bug. Apparently had a real effect on my life because I've continued to do that. Outfitting or doing conservation work, there's got to be a benefit to the result. You got to do it, you got to have purpose. So in Mongolia, we're mapping the genetic populations of fish in these watersheds. What that data shows us is that each watershed's important. These fish have been isolated from one another for millions of years now. When I grew up, you catch a fish and just keep it. I probably wouldn't even think about whether that was legal or if I had the right number of hooks on my line or whatever. So Mongolia is very well regulated in terms of what legal fishing is. A lot of people just come out and fish, could be locals, could be foreigners or whatever, and are unaware. And so we tackled that. Catch and release fishing has grown in Mongolia like unbelievably. My name's Charlie Kahn, and I'm a Gustie. Make your life count.
Chicago, Illinois. She stared down a gang of drug dealers and chased them away from her beloved Bethel Lutheran Church. She is fearless. In her junior year at Gustavus, she studied German literature in Munich, joined a Christian student movement, and sneaked beyond the Berlin Wall into East Germany just to share her faith. That's Mary Nelson, and she is fearless. Mary was the driving force of Bethel New Life. She, and as she describes them, the incredible people I worked with, are responsible for the rebirth of Chicago's West Garfield Park, a dangerous inner-city neighborhood. They created low-income housing and living wage jobs. The neighborhood high school she started graduates 95% of their students, compared to 50% in the other area schools. The result was a healthy, sustainable community. It's where Mary calls home. It's where she lives, volunteers, and worships today. She is fearless. It is impossible to recount all the things she's done in her life that go above and beyond. But her goal is creating a sense of community for all people, regardless of race and sex, to get people to do things that are bigger than themselves, and to realize that there is no community without justice. She says it's a hope that comes through faith. Mary Nelson epitomizes Gustavus, and she is fearless.
For me, I knew coming into Gustavus that I wanted to do something in Scandinavian studies and Swedish, but also in the sciences. But I didn't necessarily know what direction I wanted to go with that. I actually had never really heard of doing research, or that was even an option in terms of a career coming into Gustavus. And during January term of my first year, I enrolled in biomolecular research. And during that time, we were able to spend every day in the lab. And I truly just fell in love with this idea of research. And really from there, I took every opportunity I could to explore research across the country and as well as in Sweden. And from there, it took me to Syracuse University for part of the summer, and back to Gustavus and to Karolinska and to the National Cancer Institute, and some time at the Mayo Clinic through the Mayo Innovation Scholars Program, and eventually to NIH for that year following graduation, and now here to Harvard Medical School. I really felt coming from Gustavus that I was well prepared going into medical school. And it's not only from the classes I took, but also from just being able to be engaged in the community and all of those activities and getting to talk to people from across campus and learn their stories. It really becomes a part of medicine as well. Every day in medical school, when we're interviewing patients, you have to be able to then summarize and present that information. So there's a lot of communication that I don't think people always appreciate. They just think that it's science. I think it ties in so many aspects that people don't realize that you gain during the liberal arts. So it's that respect for how someone's socioeconomic status ties in with their health conditions, and really just being able to think about those problems all at the same time and try to bring the whole story together. Truly everything that you work on in the sciences is somehow connected to the greater picture. I think people make their life count in different ways, and it was sort of through my experiences in Sweden and on campus and at the Mayo Clinic that it all started to come together, this idea of being a physician scientist. And really where I see my career going is hopefully being able to combine those worlds and sort of be in that middle ground, working in research that's relevant to the patients, and hopefully the patients that I see will help to inform my research questions that I'm pursuing as well. You get to think about what is known, but also what isn't known yet, and to try to better understand that in the context of health and disease is just an amazing opportunity.
So many of the different fields in science, most people aren't exposed to in their day-to-day life. The more you can get out there and communicate to the young people coming up that are the future of science, the better. You never know what's going to grab one individual, and so that's vital to inspire the next generation.
The Nobel Conference brings together students, faculty, and members of the general public to explore revolutionary, transformative, and pressing scientific questions and the ethical issues.
Good morning. My name is Mara Klein, and I'm the Director of Fine Arts Programs at Gustavus. We are so glad you could join us for the second day of important dialogue on climate change. To begin this morning's session, we will open with a musical prelude from the Gustavus Symphony Orchestra under the direction of Dr. Ruth Lynn.
Good morning. Welcome back. So great to see you all back here. I hope you had an enjoyable and rewarding, intellectually rewarding afternoon and evening. There were a lot of things going on and a lot of very full workshops. I kept saying I'm glad the fire marshal isn't wandering the halls right now to see what was going on. Thanks again to the orchestra. What a great performance. And again, a reminder, back when I was a student here, that I know how much work that they put in to make those ensembles come together so quickly. So let me see, I have a couple of additional thanks that I want to do this morning. I'm doing these in a rolling way. Marketing and communication, the marketing office here is a small shop with very big jobs, and they, boy, Friday afternoon it was like a beehive over there, and the amount of work that comes out of that office. Pretty much everything that you see that's working well is a result of Barb Larson-Taylor and the entire marketing team, so thanks to all of them. Also thanks to all the folks on physical plant who are putting down their ordinary jobs in order to serve as traffic directors and extra garbage picker-uppers and all of the sorts of things that happen when you bring 3,400 or 3,500 more people onto a campus. So thanks to all of you, and thanks to the folks on campus safety who are making sure that we are staying abreast of those exciting weather warnings we had last night. Thank you for no tornadoes. And doing all the other kinds of things to ensure that we proceed in our conference safely. Yes, let's have a hand for them. A reminder that you can use Poll Everywhere to ask your question of our morning speakers at any time while they are speaking. That poll will go live as soon as the first lecture this morning begins. A lot of questions have come in about what we're doing at Gustavus with respect to adaptation and mitigation. And I thought, who could I find who might be able to say something about that? How about the president? So I'd like to welcome President Bergman back to the stage to tell you a little bit about all the exciting things at Gustavus.
Thank you, Lisa, and thanks for your questions about environmental sustainability here at Gustavus. We formed the President's Council for Environmental Sustainability in 2017. I have started 2 councils at the institutional level, the Environmental Sustainability Council and a Council on Diversity, Equity, and Inclusion, because both of these areas require work across the institution. So that was step 1 for us formally to try to pull together all of the various initiatives on this campus that have been underway for many years related to the importance of environmental sustainability. Last spring, we formalized 2 key goals for the institution that are inherently measurable. The first one is to reduce our energy consumption by 25% over the next 5 years. If you look across educational institutions, this is one of the goals that most institutions, and in fact, for-profit institutions, corporations, et cetera, are setting, an energy reduction goal. And we've set that at 25% over the next 5 years. And then secondly, we are working our way towards being a zero-waste campus, and that will also be a multi-year process for us. We've defined that to mean that we have at least 90% of our waste going somewhere besides landfill or incinerators. Many of you might know that we all already have an industrial scale composter on this campus. We hope you're looking for ways that you can put any food waste or other compostables in compostable receptacles, compost receptacles, rather than in the trash. So thank you for your work on that. And we've been involved in recycling efforts for many years. One of our goals is to try to get collection places in every building across campus. And that, of course, involves the logistics of collection and transportation of waste to where it has to go next. The other thing that I would tell you that has been an ongoing work here at the college is energy efficient lighting, especially as we replace light bulbs. We're doing that, obviously, as many places are with, and hopefully you too in your homes, with energy efficient lighting. For all new construction and renovations, major renovations in our buildings, we are seeking LEED certification. I'm happy to let you know that Beck Hall, which many of you would have been in yesterday for a workshop, that is a LEED Platinum building. For renovations, it's a stretch to get to gold. For new construction, Platinum is indeed possible. Our renovation of Anderson Hall, which was originally the library on our campus, that is a LEED Gold, and we are working towards LEED certification for Nobel Hall of Science, which will be a combination of new construction and renovation. And finally, a word about clean energy. You might notice that we have solar panels, a variety of places on campus, including on the roof of Lund, where we are. For example, the solar panels on this building do a pretty good job of heating our pool. And we're currently assessing and looking forward to putting large solar array on this campus, hopefully to generate as much as a megawatt of energy for use by us and the community. So thanks for the questions, and you can find me if you have additional ones. Thanks again, back to Lisa.
Thanks, President Bergman. The website that lists all of this information is difficult to keep updated, but if you go onto the Gustavus website and noodle around a little bit, you can find the current iteration of what's going on at Gustavus. Some people also have been asking about the poster. There's a small description about that image on the back of our program. Sharon Stevenson has been a designer working with Gustavus. She's an independent designer for many years. And I invite you to see if you can decode the entire poster, because each one of those little tiny images is actually of a mitigation or adaptation technique. Sharon, when she designs a poster, really does her homework. Same is true for the next year's poster, actually. So with those announcements and whatnot in place, I think it's time to begin. So I would like to welcome to the stage Ursula Lindqvist, an associate professor in the Department of Scandinavian Studies, and also Peace, Justice, and Conflict Studies. Ursula will introduce our next speaker.
Good morning. Sheila Watt-Cloutier, or Sila, as she is known in her own Inuktitut language, is best known for reframing climate change as a human rights issue, and for casting a spotlight on how climate change was destroying the Inuit way of life. For this ongoing work, she was honored with the Sophie Prize, which recognizes major contributions to environmentally sustainable development in 2005. And the Right Livelihood Award, also called the Alternative Nobel Prize in 2015. A member of the Indigenous Inuit of Arctic Canada, she grew up speaking her native Inuktitut language, traveling by dog sled, and eating fresh, nutrient-rich country food harvested by the community's hunters and fishermen, a way of life that is facing increasing challenges in today's Arctic. In 1995, she was elected chair of the Canadian branch of the Inuit Circumpolar Council, or ICC, an international non-governmental organization that promotes the rights of Inuit people internationally and develops long-term policies to safeguard the Arctic environment. Today, the ICC represents 160,000 Inuit of Alaska, Canada, Greenland, and Russia. So her reach has been huge. In 2002, Wat Cloutier was elected international chair of the ICC, and in 2005, she presented a landmark petition to the Inter-American Commission on Human Rights on behalf of herself, 62 other named individuals, and all other affected Inuit populations of the American and Canadian Arctic. The petition argued that global warming impedes human rights by threatening an entire culture, the Inuit culture, and thus the Commission had an obligation to take corrective action on climate change. In her memoir, The Right to be Cold, published by the University of Minnesota Press in May, she argues that the fate of humanity as a whole rests on the fate of the Arctic. Please join me in welcoming Sila Wat Cloutier.
Ulakut. Ulakut meaning good morning in my language, the Inuktitut language. Ulakut. I want to first acknowledge and pay respect to the fact that I am speaking on Dakota lands, and also to thank President Bergman, Lisa, and everybody else who have been so helpful, and Ursula, and the three students, Dan and Jasmine and Brittany, for taking such good care of me in the last couple of days that I have been here. So it's wonderful to be here in front of all of you, and to all of the young people that are in the room, as well as the older people like myself. I grew up in Kudjuak, a little community, an outpost camp of the Hudson's Bay Company, and traveled only by dog team the first 10 years of my life. And I learned my second language, which is English, when I was 6 and started school. And those are my humble beginnings before I was sent off to school at a very early age of 10 without my family and parents. And so we lived in a very small community where we all helped one another to survive and thrive in a very sustainable way. And so what I want to share with you today is about our communities and who we are and how we've been impacted by the global world. Because, you know, the world has come to know the Arctic for its wildlife more than its people. And often it's because there's large companies sometimes that use the Arctic wildlife to market their products. You know, one that you've seen, I'm sure, many times, the polar bear and the seal frolicking around in the ice drinking their pop, which is an unlikely partnership because one is lunch. So many of these misguided movements, you know, in terms of romanticizing the Arctic, and the misguided animal rights movements have really put the protection of wildlife before understanding and respecting the impacts of those movements on its people. And so I try my best to teach the world that we are a very remarkable people who live at the top of the world. And so Inuit culture is based on the ice, the snow, and the cold, and its very foundation, in fact, depends on the weather and the climate being cold, freezing cold. And so all living things, including the animals and the Inuit hunting culture, really do thrive on that cold. And therefore, when the climate changes and it warms, it creates a great imbalance in the cycles of nature, which allows for all living things to be healthy in our world, that cold. So the ice and snow and the cold in the Arctic for us is all about transportation and mobility, and in the pursuit of healthy organic country food that we rely on for our health. And so therefore, when those kinds of conditions become precarious, due to the climatic changes, it becomes an issue of safety and security, first and foremost. And then our right to culture, our right to educate our children on the land and the ice, and our right to safety, our right to health, all become impacted and minimized. And sometimes we really do need to be reminded, or if you haven't heard this, we were once a people that were really highly independent. We had our own education systems, our own justice, health systems based on Indigenous knowledge and wisdom. And we prepared our young people for the challenges and opportunities of life in a very holistic way. And then things started to happen very quickly. The changes happened quickly. We weren't able to have that full control over our lives, and changes and the stressors began to impact our way of our well-being on so many levels. Because I believe the root of the challenges that we're facing now in the North are the results of those historical traumas, from dependencies that are both from the past and ongoing. Dependencies, for example, to substances. You hear about that everywhere in the media. To institutions, to processes, which now erode our sense of identity, our sense of self-worth, and lessen our ability to really think for and act for ourselves. And so these in turn have translated are translated into the monumental health and social challenges that are faced by all of us in our communities today. And they're often misunderstood as our inability to adapt to the modern world. But in reality, that couldn't be further from the truth. We're probably one of the most adaptable people in the world, considering the environment that we live in. And so Canadian history, and much of history, is not well known by many of my own fellow Canadians, in fact, and have not served us very well on so many fronts. The social, health, and judicial challenges we face today, as I say, are not from yesterday, and there is certainly a context to them. And the historical traumas that many people have not heard about, the forced relocations, children that were sent away at a very young age to be educated by strangers. I was one of them at the age of 10. Sexual abuse by those in authority, the collapse of the sustainable sealing market by emotionally driven animal rights activists, the dog slaughters that nobody has heard about, the residential schools, to name a few, are some of the major contributing factors into the social and health struggles that we face today. And so we do have to understand and put those into context and realize that the substance abuse, the health problems, and the suicides are not our natural state of our people. That's not who we are. They are rather a result of the historical traumas, the rapid changes, and the creation of institutional dependencies. But through it all, we've had our land, we've had our predictable environment, and our climate, and the wisdom of our elders and our hunters, which helped us to adapt to every situation. However, today things are not so predictable. And I do see the strong connection between health and social well-being of our communities and our environment, and maintaining our Arctic environment are more than just an environmental concern. It is an issue of our very right and ability to exist as Indigenous people. But precisely that right is now being challenged and minimized by the new unpredictability of our climate. I was once asked why I spend so much time on environmental issues when there's so many social and health problems in our communities. And my immediate response was, I don't see a disconnect between any of these issues. They are all interconnected. So if hunting continues to decline due to the climatic changes, it means that there's an increase, in fact, in our already too heavily reliance on expensive imported goods and foods. Where I live, and where I lived in Nunavut before for 20 years, and now in Nunavik, in my birthplace, things can be 2 times, if not 3 times, the cost of food, as, for example, in Montreal. And we already know that the switch away from our diet of country food has led to a very dramatic increase in diabetes, in childhood obesity, heart disease amongst our people, and as well, this reliance on expensive southern imports only deepens our reliance on government support in our communities, which really is the opposite of building thriving local economies that heavily incorporate elements of our traditional culture. And so more and more of the much needed life skills of our youth is lost. In fact, the life and character skills of our youth that is taught on the land are not very well understood. That ice is our university. That's what that ice is for us. A hunting culture, for example, if you're waiting for the snow to fall, the ice to form, the winds to die, the animals to surface, you're being taught patience. This is about you that's learning the character building and the life skills. You're learning perseverance, to persevere, to tenacity, to be courageous, to be persistent, how not to be impulsive. One of the things that we have learned in our studies to wonder why the high suicide rates is that impulsivity is one of the things that is something that is contributing to the suicides. It's not to say that you're not in a dark place when you're contemplating taking your life. We are known to have the highest suicide rates in North America, and so we have looked deeply at these issues. And so how not to be impulsive. If you learned on the land, through the land and nature, you are more apt to be able to not be impulsive in the modern day world. And you're learning how to be bold under pressure, how to withstand stressful situations, how to be focused and meticulous, and how to become a natural conservationist. And ultimately, you are learning how to develop sound judgment and wisdom. These are the skills that we want to continue to teach our children because they are very transferable to the modern world, and they are taught very traditionally in that cold weather, ice and snow. And it is, in fact, a necessity to be able to, in this rapid times of change in our world and trauma, that we need to have those skills be entrenched in our young people today. And these are the same skills that this young generation in this very room will need to become the change agents and the championers of our environment and our planet as we move forward in this together. And so remember, it is the stressors of the first wave of these tumultuous changes which we are trying to cope with, which are often not well understood. And so we have been grappling with many other issues, not just in terms of environment, but with the depletion of the ozone layer, which causes health challenges where our hunters have developed cataracts and skin conditions from the higher levels of UV radiation in many numbers. And we've had to deal with toxins from far away, the persistent organic pollutants in the 1980s when we discovered that the nursing milk of our mothers and the blood cord was showing to have toxins in our bodies and in the nursing milk of our mothers, that we were being poisoned from afar. And during the UN global negotiations, which I took a very strong lead in, we worked hard to shift this seemingly just a chemical and environmental story to one of human health. It was not an easy task, believe me. And knowing full well the contaminants issue was a difficult fight in putting the human face on the global map when I was still chair of the Inuit Circumpolar Council. And after a long preparation in December 2005, and with partnerships, in fact, with Americans, with the Center for International Environmental Law in Washington, D.C., and with Earth Justice in San Francisco, where my legal teams, we launched and we prepared and launched a legal petition to the Inter-American Commission on Human Rights. And I've always said it was a way of reaching out to Americans, because we were targeting at the time the Bush administration. We thought then that was challenging. I won't go there. I won't go there. And so we felt that we were not striking out, but we were reaching out to the Canadian civil society to hear what it is, because they were already ahead of their government at the time and wanting to help, which is why I had American legal teams with me working very hard on this. But I, along with 62 fellow Inuit signatories from Canada and Alaska, launched the pioneering work on linking climate change to human rights. And although in the end the Commission chose not to go forward with the petition for various reasons, which I won't get into today, but there's more detail in the book, The Right to Be Cold, there was a historical hearing to educate them on the legal impacts between climate change and human rights. And the outgrowths of the petition, I believe, have made way for others to be courageous. And I believe that we did change the discourse on the issue of it not just being an economic issue or a political issue or a scientific issue, but one of the human issue, human dimension and human rights. And so I think the outgrowths did help in that way. And there were other people that were able to then move forward. And to this day, there's still movement to go in the direction of human rights justice, eco-justice. In the rumble-tumble of national and international politics, we heard a little bit about that yesterday with the work that our scientists do. The language of economics and technology will always call for further delay and great certainty. And moreover, just focusing on the economics and the politics of the issue tends to silo or separate these issues from one another, as opposed to recognizing these strong connections between rights, environment, health, economies, and society. And so framing our stories, I believe, in terms of the connections between fundamental human rights, including the right to health, and environmental change, refocuses the debate on humanity and not just efficiency. I think we must remember that the doctrine of collective human rights unites our Indigenous world to diverse cultures, peoples, countries all around the world. And I think this important understanding of our collective connection as a shared humanity can spur decision makers to act in a way that no dry technical report ever can. And so ultimately, addressing environmental degradation of Indigenous lands, including climate change in the language of human rights, and building human rights protections into our global climate agreements are more than just strategic choices. They are ethical imperatives that demand the world retake a principled path and courageously reconnect to solve these monumental challenges that we're faced with. So now here we are, the Arctic is an area of utmost importance in the minds of global policymakers, economic decision makers, and researchers, but this interest needs to be better informed by awareness of what is happening to the largely Indigenous and subsistence-oriented communities that provide that human face to the Arctic. Many of our communities are small, smaller than this room, definitely. My community is about 2,800 people. And they don't necessarily have great political power or influence at the national and international levels, but they are the heart and soul of the Arctic. It's very difficult to put ourselves on that map. And I was sharing with the students yesterday afternoon a disappointing email I received where I was asked by the New York Times to do an op-ed piece, an opinion piece, editorial. And they came to me, and I worked very hard on getting that in because they said they wanted to have it out this week during the summit in New York, and only to hear yesterday that the editorial board decided not to choose my editorial to go into that piece this week. And so we just have to keep plugging away and keep trying and trying to get those voices heard from the Arctic and from Indigenous peoples who have ways in which we want to contribute. We don't want just to be the victims to what is happening in our world. So in Inuit culture, as I say, every challenging moment was an opportunity for teaching our children how to become those proficient providers. But again, as I say, and I said earlier, by developing their skills in a very holistic manner. And it's because technical skills of how to harvest that animal to bring it home to your family is one thing. But the characters, and that's how the world works. But the character skills are about how you work. And that is important. As young people, this holistic approach to learning is the hallmark of Inuit culture. I have a mosquito going around me here. Maybe followed me down from the Arctic. We have lots of them. This wisdom which is often sourced from the ice and snow and the cold, is equally now at stake in being lost as the ice itself. So it's not just about the ice and the polar bears, and I want to say that very strongly here. It is about our children, our families, our communities. Our environment and climate were predictable and very rich in lessons, allowing our ingenious culture through traditional knowledge to be passed down generation to generation. One has to remember, we are the inventors of the kayak, which is that boat that has been engineered and replicated throughout the world. We engineered that. We are the people who can build a home of snow, warm enough and be joyful like this man you see in the cold. That's who we are. There's ingenuity at play here. We can read conditions like nobody's business, and we can not only just survive, but thrive in this kind of cold. However, again, as I say, things are no longer predictable, and this traditional knowledge can no longer often be counted upon. Everything is changing, and changing rapidly. Globalization has hit the Arctic and its people, impacting our health, our cultural way of life, our environment, and our climate. And as that ice melts, the wisdom that has taught us over the millennia now threatens to disappear along with that ice. Everything is connected through our common atmosphere, not to mention our common spirit and our humanity. What affects another affects us all. And as the Arctic melts, other places such as the small island developing states are sinking, as well as many other places. I heard about the highway here on my way here, where there's some water rising up onto your highway at certain periods of the year. It's happening everywhere now. The Arctic is that cooling system. It is the air conditioner, if you will. As it melts, other places are being impacted, whether it be the droughts, the floods, the tornadoes, or the intense hurricanes. From farmers in Australia to the fishermen in the Gulf of Mexico to the homeowners of New Orleans and Oklahoma, the devastation escalates, and we are all connected. The world I knew and the world my grandsons would inherit is changing very rapidly. I have 2 grandsons, one is 22, one is 6. Climate change in the Arctic is not just an environmental issue with unwelcomed economic consequences. It is a matter of health, again I say, livelihood, food, individual and cultural survival. It is a human health issue affecting our families. The Arctic is not wilderness or a frontier waiting to once again be exploited. It is our home. It is our homeland. And all of these challenges that we're facing are not necessarily of our doing. We have benefited the least from industry, and yet we are the most disproportionately negatively impacted by the impacts of globalization. How ironic and sad that a people who have lived sustainably for millennia and far from the sources of these pollutants and greenhouse gases would bear the brunt of their damaging effects. For too long, we have asked the world, stop bringing harm to a way of life that is important to us. And the world has responded often by saying, it is too expensive for us to stop bringing harm to your way of life. And we, the Inuit, have paid the price for the unsustainable choices most of the world continues to want to maintain. And we Inuit are becoming the collateral damage of the result of irresponsible political actions, or should I say inactions. Everyone benefits from a frozen Arctic, and that everything is connected, and that we can no longer separate the importance and the value of the Arctic from the sustainable growth of economies around the world. I believe it's through the power of human rights-based approach that we can move this discussion out of the realm of a dry economic and technical debate that too often overtakes the discussion on so many levels. A human rights approach takes the path of principle, showing us that fundamental change is not just sound policy, but an ethical imperative. And I've seen this approach, the power of this approach at work in my global work as we drew out for the first time the links between Arctic climate change and our environment, cultural and human rights. And I saw how the world enthusiastically connected and welcomed our work. Why is that? Because I believe that people can relate to this issue when you bring it down to the human dimension. And so defending the Inuit right to be cold, another plug, got to do this, you know, you're a large crowd. And defending the Inuit right to be cold is really about connectivity. That's what it's about. And we're all very connected by this fundamental human right. It is about a healthy environment for all of us. And I have always said, if you protect the Arctic, you save the planet. That's the connection there. So that right, a right that requires the world to focus on and care in defending at all levels, whether they be regional, national, or international. And so when I did start to write the book and felt I had a responsibility to write that book and share it with the world and share it with my people first and foremost, I have been honored, very honored, and I have been very humbled by the fact that I have been hugely decorated for the work that I have done over the last 20 years, and I really am humbled and honored by that. But most people have not really fully understood my story, and so to take a line from the great Maya Angelou, who said, "Everyone knows my glory, but they don't know my story," I felt it was important to share. And so, as I say, we lived a very close-knit family, where everything mattered and everything was connected, and that was kind of magic in my childhood. And so that's why I bring to you those kinds of storytelling that connect to the larger pictures and connect to the issues that we're dealing with and so challenged with. And so it's to show you the human face to all of these issues, because for us, hunting is not a sport. Along with the technical skills, as I say, we are really teaching our children to be able to combat what is coming at us and what has been coming at us and what is now here and arrived with the challenges, because we're already dealing with those kinds of situations with climate change, and it's already a very vulnerable state that we're living in. I'm not suggesting that it's all sad, sadness and gloom. It's not. We have some remarkable youth that are standing up. We have filmmakers and performing artists, singers and songwriters that are out there that are really starting to make the movement stronger in terms of addressing the issues and taking back some of that control that we so need to take. And so for that, I've learned through the many talks, though, even with all of that, that very few people know about the historical traumas, and putting them into context is an important piece, not only for our youth, because I felt that our youth didn't know enough about what happened and why do we struggle so much. And if I could help to alleviate even a little bit of that burden that that generation carry in understanding the context and not taking things so personally, as hard as that is, I wanted to be able to contribute in that way with that understanding. Because we had the forced relocations of the families in the high Arctic in the name of sovereignty, the collapse of the sealskin market where they stripped the dignity of our hunters. Children were separated, as I say, and I was one of them. So the cultural suppression and oppression has diminished our identity, and addictions and violence are symptoms of those traumas that have been endured. In fact, the first suicide in my community was when I was 18. So it's a new phenomenon. And here we are, still reeling from those first waves of changes and trauma, and finally coming to recognize the root of the breakdown of our society, only to realize another wave of tumultuous change is upon us. Because when climatic changes start to impact the Arctic ice, making it precarious, it brings on even more stressors in an already stressed situation. The ice is a big part of our identity. It is our highways. It is our life force. It is something we knew to be as permanent as your rivers and your mountains. No one has, and one has to remember that the ice, again, as I said earlier, is about transportation and mobility, and when that becomes precarious, it immediately becomes an issue of safety and security. My grandson, when he was a young man, hunting with his father, is the picture here. So the climatic changes have only added more stress and anxiety to a community with a historical context of trauma. We see outpouring of support and generosity when things are happening now, certainly in my country, and we see it in yours through the news, with the outpouring of generosity and support by first responders and neighbors and others. When there's floods, when there's fires, all of those things that happen. But imagine the equivalent level of emergency every single day without end, where you feel that loss of what is happening all around you. Imagine no drinking water, not for a week or two, but for decades. Imagine being poisoned from afar in the 80s when our Inuit women had to think twice about nursing their babies. Imagine women in your community going missing with no explanation for decades. The constant worry of your children who are high risk for self-destruction due to the intergenerational traumas and the structural racism of our institutions, which make you feel less than what you are meant to be. What if a constant state of emergency became the new norm? What kind of psychological impact might that have on your people in your community? A history of this violence of our communities mirrors now the violence we are inflicting upon our planet. If there's anything that you take away today, I want you to understand that human trauma and planet trauma are one of the same. I understand that the economy is volatile, but growing the economy in the same unsustainable way causes irreparable damage to the atmosphere, and it's forcing the planet to react with violent storms and other erratic events. This is not unlike the child who has suffered trauma. Without care, a space to heal, and effective coping mechanisms, self-destructive behavior is inevitable. What we are seeing in our communities and in our atmosphere are not abnormal behaviors. What we are seeing are perfectly normal reactions to extremely abnormal circumstances. And I say again, human trauma and planet trauma are one of the same. So here we are. I don't think we can think our way out of this crisis. I think we've tried lots of politicking, economic solutions, technology. A lot of it hasn't worked. I think we need to reassure society that change will not punish economy, but rather provide an opportunity to flourish in the future, creating a better world. And I think we talk a lot about reconciliation with Indigenous peoples in Canada. If we truly want to reconcile as citizens of the world, we have to feel our way through this crisis. We have to reconnect with everything and reconnect with one another, with nature, and with the Indigenous peoples who so want to contribute to the solutions. I think if we solve the problems that we face in the Indigenous communities, we will solve the climate crisis. I think we will solve the economic crisis if we can do this right. I was, as I gear towards finishing, I was in Australia a couple of years ago after my book was out. 3 authors from Canada were chosen to go down to book festivals. And there I had a chance to meet Tim Flannery, one of the world's greatest climatologists from Australia, but we were in New Zealand at the time. And we were on a panel, and audience member at the end asked him, what is it that is lacking in this world of ours when we know the science is in and we know it's collaborated by those on the ground who are most impacted by it? What is it that is preventing us? What is it that we don't have that seems to be lacking in taking action and moving forward with this? And his response was similar to what Dr. Ghosh was talking about yesterday. And his response was imagination. Imagining that we could do this differently. Imagining that we could make a new world with new ideas, innovative ways. And so imagine we must. as the younger generation that is here, to imagine. And it's not just about imagining and hope with empty words, but with action, to imagine that we can have a world that can be sustainable and healthy, not just for the indigenous peoples who are most impacted, not just for the Arctic, but for all of us. And so I want to end by saying something on leadership that I was asked when I was teaching as a visiting scholar at Bowdoin College in Maine back in 2009. I was away from home for that year, and but we were having a women's conference, Inuit women's conference in Iqaluit, where I was living for 20 years, in Nunavut, in the higher Arctic than where I live now in my birthplace. And they said, we know you're away, but we really want your voice to come into this conference that we're holding for Inuit women in Iqaluit, where I've lived, and my home was still there. And they said, but you can be taped while you're down there on video, and then we'll show the video in the room. And they said, but we have a specific question for you that you can say whatever you want, but we have a specific question that we'd like you to answer on leadership. And so I asked, we went around and we found the right videographer and so on. And here I was amongst the big trees on campus at Bowdoin College, signaling this message out to treeless Nunavut. So it was quite an experience. But the question was, what does leadership mean to me? What does leadership mean to you, they asked. And so this is what I said. Leadership, to me, means to never lose sight of the fact that the issues at hand are much bigger than oneself. Leadership is about working from a principled and ethical place within oneself, and it is to model authentically, genuinely for others, a sense of calm, a sense of clarity, and a sense of focus. Leadership is to always check inward, to ensure one is leading from a position of strength, not fear or victimhood, so one does not project one's own limitations onto those you are modeling possibilities for. So I end with that, and I thank you for having me here. Nekolmi. Thank you.
Thank you so much, Silawat Cloutier. As we shift gears for our next presentation, there will be a poll up here. Oh, I just say the words and it happens. So please go ahead and fill out that poll while we are waiting for our next presenter. It's my pleasure to introduce my colleague in the Department of Physics, Continuing Assistant Professor of Physics, Darsa Donnellan. She'll introduce our next speaker.
Dr. Gabriele Hegerl is a distinguished climatologist and professor of climate system sciences in the School of Geosciences at Edinburgh University. She has a high international standing for her work in climatology, climate variability, climate extremes, and climate change over the past millennium. She has brought about continuing innovative scientific contributions that enable the detection and attribution of anthropogenic climate change, and her work has helped to clarify the causes of global climate change, and as a result, enable significant progress in international climate policy. Dr. Hegerl serves on a number of national and international collaborations. She was the contributing lead author for an important chapter on understanding and distributing climate change for the Intergovernmental Panel on Climate Change, IPCC, Fourth Assessment Report in 2009, and lead author on the Fifth Assessment Report. In 2016, she was awarded the Hans Zegers Prize for her groundbreaking research in climatology, and in 2017, she was elected a Fellow of the Royal Society. While accomplishing all of this, Dr. Hegerl has advocated for the role of women in science and has found it important to encourage and support a diverse set of colleagues. She has been vocal about the need to raise consciousness to the importance in balancing family and work, and that an unorthodox work hours do not mean a lack of commitment. Please join me in welcoming Dr. Gabriele Hegerl.
Good morning. Good morning. Before Darsa sits down, Darsa, stand up again. Darsa is wearing the data. Actually, I'm going to talk about this. One of my colleagues has visualized climate change so it changes from the top to the bottom, getting warmer. So it's a great honor to be here and talk about to what extent do we understand climate change and how can we project it forwards. I hope to share my fascination with understanding why climate changes and why it has changed in the past, why it's changing now, and how these amazing planet's systems work together. So, and that's a seal on the east coast of Scotland where I live in the moment. And the subtitle of my talk would be Climate Change is not a belief system. So it's not something you believe or don't. It is scientific evidence with its uncertainties, but it's a science and not a belief. So before I talk about the observed record that we just saw so nicely on Darsa's dress, I would like to introduce you how it's made. So you have these, when we try to measure if the planet has changed its large-scale global mean temperature, we use instrumental data that we have collected over a long time. So we have some idea how climate has changed back to the 1850s, and we are going back even further now in many projects. And we also have paleoclimate evidence that Richard Ali has talked about earlier. And so on the, do I do this? No. On the right and bottom slide, you see a typical measurement device for surface temperature. So it's a little white box that avoids the thermometer inside being heated too much by the sun and being kind of constantly shaded. So that covers. That's the way land surface data have been taken for quite a while now, from over the 19th century onwards. And we have, over lots of places on the planet, we have these data. People have measured temperature and have been fascinated by measuring temperature over a long time. And over ocean, the sailing boats and then later the steamers have been taking the temperature of the sea surface. And they have been doing this in a variety of devices. So you see a collection of wooden buckets at the top, which basically you hold them overboard and then pull them back up again and stick a thermometer in. And people have had a lot of interesting physics and fun with trying to correct for the small bias you get by just waiting a little bit before you stick your thermometer in. So the wooden bucket will cool a little bit less than the canvas bucket. So there have been some interesting attempts to correct for long-term changes in how the data worked. And so over every point on the planet, so if you look at your global map here, people have collected the data in little boxes and aggregated and averaged. So they have looked at how this particular station that has this white box around it deviates in every given year from the average over a long time period. So like 1960 to 1990, for example, is this year an unusually warm or cold year? And then they aggregate it over these little boxes and then plot and wind up with a series of how every single year was different from the year before then, and fit a slope line. And that's what you see on this map. So the first thing you see is that the map has lots of white places where there is no long-term trend, where we don't have enough data to know. And you will notice that a lot of them are in the Arctic, which means we can't really actually see the particularly fast changes in the Arctic as well as we would like to. If we go back 100 years, we are doing better right now. There's also no data in the Antarctic. They started collecting in 1950 or so you have to go back a little bit less far. There's the interior of Africa, parts of the Pacific where we also are not quite sure. But if you look at the globe overall, it's reasonably well covered, and colors that are red indicate that it's a place that has been warming over the last 100 years, and blues indicate it has been cooling, and purple indicates it has been warming very fast. Excuse me. And so you can see that pretty much every place on the planet has been warming, other than this blob to the south of Greenland, which is a really fascinating area where we have a lot of variations in the ocean surface temperature that could be linked to the large scale movement of the ocean. We also have a few blobs in eastern North America, but otherwise everything is kind of warming. But if we look at how the warming has happened over time, you can see, so we have here, this is a bit of a busy diagram, and I was experimenting with getting rid of so ignore the kind of squirrely lines at the bottom and just look at the time series that is starting in 1850 and then to 1900 and 2000, and it goes to 2018, and different places, different research institutions have looked at what do the data tell us, have aggregated them in different ways, have extrapolated them further or less. So for example, the ones that are light blue, NASA GISTEM, extrapolate more into the Arctic and use more Arctic data than other data sets. But you see that overall all these data sets agree on that it has warmed over time, but it hasn't warmed homogeneously. It has warmed relatively homogeneously over the last 60 or 50 or so years, but we had another step of warming from 1900 to 1930, which fascinated me early on when I was a young postdoc trying to figure out, could we detect climate change? And I found we detected it at the end of the 1940s, and I thought that's a bit weird. So, and then in between we have this period where it didn't warm that much in the 1950s and 60s, and we have spent a lot of time debating the lack of warming in this little red blob here, this so-called hiatus of warming. If anybody heard the discussion that global warming has stopped, the whole discussion was about this tiny little wiggle in the global temperature record when it stopped going up quite so quickly and took a little break and then continued going up very rapidly afterwards. For a climate scientist, it was incredibly frustrating to hear the debate about stopped global warming if you look back on the entire time series and say, well, what do you mean? It's varying and it's warming. So, and then of course the longer term slowdown of warming in the 1950s and 60s that is probably related to pollution aerosols. So now we would like to know, why does it do these kind of strange step behaviors? Why did it stop warming temporarily recently but has resumed? Why did it not warm so much in the 1950s? And to understand an observed record is almost impossible without some kind of model, at least a model in your mind of what shapes this record, what influences what happens. And excuse me. And so people have for a long time made very simple records, just simple balances based on very basic physics. If I add more energy into the planetary system, we will have the planet has to warm. And people have also made more complex models. But the first thing we want to do before we even model it is understand what could have influenced climate to make these varying steps and hops and trends. And so, of course, the first one that is in our mind and that we have talked about in this conference extensively is the increase in carbon dioxide in the atmosphere that we have caused largely by burning fossil fuels, and that's it's one of the most famous records on the planet is the measurement of carbon dioxide in the atmosphere in Mauna Loa, and you can see little wiggles and a steady trend upwards. But the increase in carbon dioxide is not the only effect humans have had on the planet. You can see on the satellite picture, you can see the haze over parts of China that is associated with burning fossil fuels and with pollution. And this kind of haze, and I think most of you will have seen this kind of haze when you, for example, when you fly and land and dive into a brownish, whitish cloud surrounding a city. So this kind of haze is not only bad for health, but it also reflects incoming sunlight. So it slightly cools it. It's regions that are sitting under a haze like this don't get quite as warm. And that is what we think caused the reduced rate of warming in the 1950s and 60s when pollution was particularly strong in the West. In the moment, the pollution aerosols are still increasing very strongly in Asia. When we think about what other factors can influence climate, we want to understand, when you want to understand what really influenced our records, we want to also look at other factors, and a really interesting factor that will come back this afternoon, I think, in presentations indirectly, is volcanic eruptions, which are very fascinating. And when a volcano erupts strongly and explosively enough that that mass and aerosols get transported into the stratosphere, they cause a layer in the atmosphere that you can actually see in this really fascinating picture there's a picture from the space shuttle, and you can see that's the Earth at sunset from the side, taken from space, and you can see the top of thunderclouds in the deep tropics, but you can also see 3, 4, 5 layers that look dark here, and are similar in structure to the layers you just saw above from China. So these are kind of reflective layers that have been ejected into the atmosphere by the eruption of Mount Pinatubo in that case. So the space shuttle picture is taken in August, and the volcano erupted in June. And over that time period, the planet was covered in a slightly reflective haze that caused a temporary cooling. The haze or the aerosols go away in a few months, and the cooling lasts a few years. And when this happens, you have a global scale cooling. You can see it in long-term records. You also have a global scale decrease in rainfall, because rainfall is so dependent, evaporation is so dependent on the sunlight evaporating the water from the oceans. The response in rainfall is actually quite large. It responds more to things like volcanic eruptions than it responds to greenhouse gases. And so you tend to get the large rivers of the planet following volcanic eruptions have slightly decreased in flow. Dry regions get a little bit wetter. And one of the most dramatic responses to volcanic eruptions in the last few hundred years was the eruption of Mount Tambora in 1815, which caused the 1816 year without a summer that was widely written about at the time. It snowed in summer in parts of America. There was the summer in Europe was miserably cold and wet. Harvests failed, and it was one of the last times that the Western world was suffering famine. And some people even argue that the novel Frankenstein was written in response to this kind of gloomy world outside that was so cold and wet. I don't know. I don't have a strong view if it's true or not, but it was definitely a kind of a gloomy summer. Interestingly, we now also find that the combination of the eruption before in 1809 together with this really strong eruption caused a long-term cooling event that led to the glacier advance in the Alps in the 19th century. So there were around 1850, the glaciers reached maximum extent in large parts of Europe, and people were making processions and pilgrimages to get the glacier to stop going over their hayfields and destroying their villages. And the glaciers obliged and turned back, which was probably an emerging recovery from this volcanic cooling and already also a slowly emerging greenhouse warming. So we start to understand these early records, which I find really fascinating. And we'll hear about, in the afternoon, we'll hear a bit about solar geoengineering, which basically is the idea of cooling the planet by putting something like a permanent volcanic eruption into the stratosphere. When we talk about what changed climate, we need to talk about the sun. All the energy we have comes from the sun, and any change in the sun can, of course, dramatically change climate. We know that the sun is a varying planet, and it's not a planet, it's a star. It's a strongly dynamic star that has very interesting physics going on within it, and that is still not fully understood. Interestingly, the sun undergoes an 11-year cycle. So at the bottom, these kind of 3 bumps are the last 3 measured numbers of sunspots on the sun. So the diagram on the left shows you the sun at a minimum and on the right at the maximum of the sunspot numbers, and you can see that the sun has spots, and it's linked to this convection on the sun. The sun is more active when it makes spots. Even though it has dark spots, overall it's also slightly brighter. The net effect of that on a square meter on the surface of the planet is 0.25 watts, so it's not a lot at all, but it is not, so it's very hard to measure, and it's very hard physics to figure out such a small change in the luminosity of the sun, but it's definitely varying. And one of the big mysteries is how much did the sun change beyond that 11-year time scale? Did it get brighter or darker over time, and how much is it linked to past changes in climate? One of the periods that are particularly good candidates to understand this is the 17th century, when people, after the discovery of the telescope, started observing the sun and noticed that the sunspots were coming and going, and then they stopped coming and going. There were almost no sunspots in the 17th century. So people were really interested in what could this be, and we know from that the sun was probably less active at that time. When you look at the very, very end of the record in 2010, we also had a kind of a very slow recovery from the solar minimum that got the solar physicists all excited and were wondering if we are going into another grand minimum, but it didn't happen. It's been back oscillating. And there are some theories that if the sun is in a minimum, also the weather could change a little bit. We could have a tendency for more cold winters, not because of the direct effect of the sun, but of the effect on the weather patterns. That is not, so the weather patterns are highly variable, and that is actually exactly the type of weather pattern that we got in this during the solar minimum. You see, the UK was entirely snow-covered, taken by satellite. It was also quite cold in other places, and that. This is just one example of how the weather varies on all timescales. You all know that the weather varies and that one winter isn't like the last. And we understand that some winters or some months, the atmosphere is over the northern hemisphere has a stronger westerly movement expressed in this diagram, but it's bigger blue arrows. So it moves, the winds are stronger, they go further up in the stratosphere, the polar vortex is colder, and Scotland gets miserable wet and windy weather, and North America gets less snowstorms going into the Great Plains and the prairies, whereas if the wind is a bit weaker, you get more cold air outbreaks, you get this kind of snowy weather, you get Dallas snow, for example, 17 times more likely when you're in this kind of not so strong flow regime. We also, all of you have probably heard about El Nino. That's another example of how the planet just varies its weather, and how we cannot expect the climate warming in response, for example, to greenhouse gases to be a solid line upwards, but every year is different. Years with El Ninos are warmer than years without, and years that have a negative El Nino kind of pattern are colder. So, this is my one slightly crazy physics slide, but it's so I want to introduce you to the idea that you can actually build a computer model of the planet, which in some sense is preposterous because you can never reflect all its complexity and beauty and all the interactions that occur, so it will always be a simplification. But the general idea is that you look at a box and then you apply fairly, this box could be a box filled with air, it could be floating in front of me, and you apply very simple physical laws like if air flows into this box, there's more air inside the box. If air flows out of it, there's less air inside of the box afterwards. The only way the mass of air in the box can change is if it's either flown in or out. It can't just disappear. So if you write, you do the same thing for momentum and energy. So the energy in that box can't really increase spontaneously. It has to come from somewhere. And if you write these down, you get massively complicated mathematical equations that you can solve on a computer. And surprisingly, I'm going to show you on the next slide, that actually then behaves like the planet's weather systems, if you do it right. So you then cover the planet in lots and lots of boxes, and you can see how and you need a lot of boxes to represent it well. You think a bit about the processes that happen. You think about how clouds form, how the hot ground radiates out or heats off into space, how the sunlight comes in and heats the ground, so you have to do a bit more than just make the airflow. You add an ocean. You think about how the ocean moves by the same laws, how the salt changes its density. And then you can also simulate an ocean. And the bottom is on the bottom right, you see two simulations run in Southampton of the Atlantic Ocean. You can see in one case the Atlantic looks very coarse. Florida looks interesting, very stick-like. In the other one, you have a bit better, more boxes and a better representation. And then your model ocean spontaneously behaves a lot like a real ocean and forms a Gulf Stream, forms a hard boundary between the warm waters in the south and the cold waters in the north. So you can actually, even though it is preposterous, you can model the climate. And when the weather forecasts we look at on a daily basis are based on very similar models and use, and often the same models, increasingly the same models. And this is just an example of that it can work. So this is a high-resolution model I've snitched from a colleague, and it shows you clouds in gray and water vapor in dark blue hitting North America. I think you can maybe recognize North America is kind of on the a bit to the right, and you can see storms hitting towards Minnesota and coming through. It's a winter picture, and it would be, I think you would be hard-pressed to figure out if this is actually a satellite observation or your model. So you can model the planet. That's the conclusion from this short section. And now what can we do with it? What I want you to show is you could use this model now, or these sets of models, to understand why climate changed when it changed and what contributed how much. And I have a very simple illustration of how to do this. There's a lot of very complex methods out to figure out what contributed how much to a climate change in a certain period. But I show you a very simple illustration based on the IPCC report. Things you can do to determine what was important for a change is to leave a factor out that you think might have been important and see, can you still reproduce this change in your model or not? Or you can do more complex things than that, but let's do that for now. So we take the same data as here, we just plot them a bit differently. We average them over 10 years because that makes it a bit easier and less noisy. So this is the same graph. You can see 1910 to 1950 warming, flat period warming. And then you take the climate models and tell them the sun has changed a bit, volcanoes have erupted, and weather varies, but nothing else changes. And you run them through the 20th century, and the blue shadings tell you what the models do. So they warm it slightly over the early 20th century. So we have, and we now understand really quite well why this happened. We have a small warming due to a hiatus in volcanic eruptions and due to a small increase in the sun at that time period. But then when the big volcanoes of the 20th century erupt, Mount Agung, Mount El Chichon, and Mount Pinatubo, you see these little dips in the blue lines downwards. The blue line is such a wide shade because it's the 5 to 95% range of where climate models run at different modeling centers with different weather patterns at different times, what they do in response to this. And you can see overall, even without any statistics at all, that there's no way you can reproduce the warming at the end of the 20th century just with the sun and with volcanoes. If you add the greenhouse gases and the aerosols in contrast, you do a pretty decent job for global mean temperature. So to reproduce global mean temperature, you need the greenhouse gases. And even if you allow the factors to vary in its strength, or if you say the sun could be so much stronger than you think it is, and the change could be so much bigger, even if you allow the change to be bigger, you still can't explain it with the sun because you would just see the 11-year cycle and not so much of an increase. And then you can play this game, and this is a very busy diagram, and you can play this game over lots of different places. So if we just heard this fascinating talk by Sila about the Arctic ice and the Arctic. So at the very top of the diagram, you see a panel in white that has a decrease, and that's the sea ice area. So the black line is the data for the sea ice area. The pink shade is what the models do if you have greenhouse gases. They reduce the Arctic sea ice. The blue line is what they do if you don't. They don't reduce the Arctic sea ice. In contrast, in the Antarctic, there's also sea ice in the bottom left. And the Antarctic, the models don't really want to change the sea ice yet. It's too early to see a change. If anything, there's a slight increase, which has now stopped, I think, to my understanding, but there is no really. The pink and the blue lines totally overlap. You can't distinguish in a model the effect of greenhouse gases in that place yet. In North America, the temperature, right over North America, we have a box that shows the temperature over North America is clearly warmer than it would have been without the greenhouse gases. So we are fairly confident that the greenhouse gases are the big player in understanding the 20th century warming. You could now say climate has varied all over time, and it's really interesting to try to understand why it has varied and how much it has varied. And I was just listening to Sila's talk. I recognized that my picture at the bottom left of an ancient cathedral in Greenland that was built by the Vikings was actually a case of early colonialism and not just a tragic demise of an attempt to set up habitation in Greenland. So for those of you who have read about this, it's still an interesting story. So the Vikings landed in Greenland in the first millennium and stayed there for quite a while. So the last recorded thing that happened in Greenland was a wedding in 1408, and then they vanished, they just disappeared. The climate had become colder at that time. The Inuit moved further south, and adjusted just fine, but the Vikings did not adjust. And it's a really interesting cultural story why they didn't adjust, why they, it's not as simple as that they were unable to cope with the Arctic environment, but they had totally different approaches to hunting. They hunted communally. Their adaptations worked for 600 years, but didn't work after. So they vanished. And they are a sign that, or a visual evidence that climate has changed, for example, in Greenland, from a slightly less cold, it was always cold there, but slightly less cold, medieval optimum period up to, or not optimum period, up to the Little Ice Age when it was unbelievably cold, and the Vikings vanished. And we had pictures such as that on the right-hand side, showing these really cold winters we had in Central Europe at that time as well. And so I was always fascinated trying to understand why did these changes occur, but we can now understand quite well why they did. So if you are into busy line graphs, the gray shadings, the many, many gray shades are attempts to figure out from tree rings and documentary records and ice cores what happened from 1400 to 2000 onwards. So every green line is one person's reconstruction scaled with another person's favorite calibration method to the instrumental data, and shows what could have happened. They all agree that it was really cold around 1815 when the big volcano erupted. They all dipped down quite deeply. That's one of the coldest periods in that timeline, but you can also see that they dip around 1600. And then the colored lines are what happens if I take my model and just run, for example, only the effect of volcanoes in that time period. We know when the volcanoes erupted because we have historical records, and the volcanoes dropped some material on the ice cores in the poles. So you can look at ice cores that Richard Ali showed us many pictures of, and see if there was evidence for a volcanic eruption at some given point in time. And so the brown lines, actually, I would argue that the brown line trails the gray line reasonably well, and the volcanoes were a big player in causing cold periods in parts of the last millennium. A player that the first speaker of the conference has mentioned is greenhouse gases. The red line, if you just squeeze your eyes a bit, you might think that the red line is a little bit lower, 1600 to 1700. Greenhouse gases were a bit lower in that time period. We don't understand why. It could very well have been the deforestation of the Americas following the extinction of the native population by the colonizers. So we could have even then had a small greenhouse effect with contributing to the cooling in the Little Ice Age. So we begin to understand why climate has changed over the last millennium, and we can understand many of the episodes that happened and find that volcanoes and CO2 are bigger players than the sun. We can also see if the hypothesis that the sun could have been a huge factor varying in a very large term, we can evaluate that hypothesis and find that it does not match the data. When we think about climate change now and climate change in the future, the biggest concern we have is extreme events. This is a picture of Katrina heading for New Orleans. We know that tropical cyclones or hurricanes are really hard to predict how they exactly respond to climate change, to global warming. We understand, though, that if you have warmer sea surface temperatures under the exact same hurricane that has already formed, then you will make it stronger. If you have rising seas, and you have a storm surge, then there's just a bit more water to come inwards. If you have a moister, warmer atmosphere, there's more moisture available to cause heavy rain, to rain down and cause flooding. This at the bottom left is the cyclone in Mozambique. In the last year, we had the wildfires in California. Fire is incredibly complex, but there is a tendency in areas where we think the data are somewhat homogeneous, like parts of Canada, that if you have a warmer year, you have more fires, more area burnt. So while it is really complicated to say why it's burning right now in this place, overall it burns a bit more when it's hotter. And on the right-hand side, I apologize for this photo because I think it's so sad. It's the But I really want to show it because it shows us the limits for the adaptation of animals and humans. So these are the flying foxes in Australia. They die when temperatures exceed a certain threshold. Their little bodies cannot cope with that, and they just fall out of the trees and dies. And that happened in a pretty big time in one of the recent heat waves. So they cannot adapt to heat that their bodies cannot cope with. And I think we humans shouldn't forget that we are also animals, and we will be in the same boat if it gets too hot. And some places, under the very strong warming scenarios, might get so hot that people are in danger outside. A period when it was super hot was the Dust Bowl in the 1930s. That is also a warning period for me. What happened, so we had record-setting heat waves, and we still haven't beaten them. And what happened was that there was a strong drought. There was changed land use, so people plowed up the Great Prairies and started growing wheat. The wheat brought in really good money and was selling really well, so more got plowed up. And then the drought got the farmers in trouble, who had to plow even more to try to break even. And so there was a huge, very fast change in how the prairies were used. And then the drought killed the crops, and bare soil was exposed. The soil was blown. The vegetation died, and this is implicated in the record heat. In our model, when we actually just remove the grass and replace it by bare soil, we can get very extreme heat. So this is a bit of a warning, because if the effects of climate change affect vegetation, we can have interesting feedbacks that we really don't want. I think I'm already kind of pushing my time here a bit. If we don't reduce greenhouse gases, we will have 4-ish degrees warming by the end of the 21st century. This is uncharted territory. It's uncharted heat waves and very dangerous. In my personal view, if we try to address climate change, that's a diagram from the report that came out that Diana talked a little bit about, the 1.5 degree report, and it's a very busy diagram. It just shows you how the observed temperature record continues dependent on how we address climate change, and various attempts to limit global warming to 1.5 or 2 degrees are shown. And for example, if we reduce methane emissions that are linked to meat consumption, it's a bit easier to meet the target. If we reduce emissions faster, we don't overshoot quite so much. What we have to do, and that's why I'm showing you this diagram, what I'm really concerned about is the bottom left of this slide. This shows the emissions in CO2 over time. To 2100, it shows you the line where we are right now. It shows how they have been increasing and increasing and increasing. And the gray and the blue line shows you what we have to do to keep warming under 1.5 or 1.5 degrees. And you can see a really dramatic change in emission patterns. So we have to very quickly change our emissions from continuously up to down and net zero by 2050. And I think this is really hard. And I'm a bit scared if we can actually do this. We have to do it in a way that doesn't crash the economy, because nothing goes right if the economy is in a bad state. Believe me, as a German, I have read a lot of history in Germany, and I think the very bad economic situation in the 1930s certainly contributed to the rise of extremism with all its really horrible consequences. So we don't want to push the economy over the brink, and the Working Group 3 has estimated that we can do this turnaround. We can even benefit from it in human health and stuff if we do it right and if we do it reasonably soon. We have to make some hard decisions. Doing this step change is much easier if we have some nuclear power, if we capture the emissions from some coal-fired power plants while we transition. We don't seem to, but those are both hard topics. There is some discussion to what extent we should employ geoengineering. We'll hear about this afternoon. That will be an interesting debate. I'm personally not so sure, but so we will have a great debate. I'm looking forward to that. Because I'm concerned about the rainfall effects of volcanic eruptions and geoengineering. But what we can do at this point is just really recognize that this is serious and that we need a global solution. So we need the countries of the world to agree on a plan. Otherwise, the people who push forward quicker might get economically punished, although they might also have an advantage by pioneering new technologies. And one thing that I really want you to recognize is that many developing countries have contributed really little, but are the ones that are hit first. So the Arctic is very sensitive due to the sea ice, but also a lot of the tropics. In a lot of the tropics, the change by climate change is much more unusual compared to the normal weather fluctuations than it is in our latitude. So the people in the tropics experience aspects of climate change stronger, and they have contributed less. And so that sets them on the move, which bridges back to the first talk. So yeah, I think that's as far as I wanted to go, yeah.
Please go ahead and submit your questions, and I ask the other panelists to join us here, and we'll be joined this morning also by our final panelist, David Keith. I think we're going to begin. So if everyone could take their seats. LED lights. Thanks. Thank you. All right. Anna?
So if you need them, I have a question for Gabrielle and I've got one for Sheila, but you can select. Thank you.
If you can take your seats.
Thank you so much.
Go ahead.
Thank you.
Is Anna live?
I'm not. Oh,
There we go. There you go.
There I am.
I've used a reference in my paper.
Thank you, Doctors Watt-Cloutier and Hegerl, for these talks. And thank you for joining us, Dr. Keith. Dr. Keith is a professor of applied physics and public policy at Harvard and joins us today. A question first for Sila. You have said several times that knowledge and awareness of climate change and its impacts are often siloed. What suggestions do you have for our individuals here who might be working in specific fields or occupations about how to connect what they are doing with the work of others?
I think the biggest problems that we're facing is that we do tend to silo. Our systems everywhere are based on siloing issues. Universities do the same. Politics are the same. And separating issues is not the way to understand the whole in that way. And so I would say learn from those who are still living in that holistic way. If you're interested in working on issues of climate change on the Arctic, for example, learn from the people on the ground. And learn, because, you know, when we were going through the work of the Arctic Climate Impact Assessment, where even scientists were a little bit cautious or leery about working with hunters and elders on the ground, thinking, maybe we, you know, I don't know if we need to learn more. Do we have more to learn from these people? But when they got to the ground and into the communities to work on these issues, they were quite surprised, pleasantly so, that they learned a lot more than they thought they knew from the people on the ground. You know, we may not be accredited scientists, but we certainly are scientists in our own right, with the fact that we know so well the systems around us, the nature around us. And that's what I meant by earlier by saying that we can contribute to the dialogue in powerful ways, and that scientists can learn from us as well. And so it's to learn together in partnership with those that are on the ground, because Indigenous knowledge is very powerful. It's very real. It's not anecdotal. It's really learning from the ground, and it's knowing how systems work around us. Otherwise, we would not have survived a week in the kind of environments that we live in, much less survive and thrive in those environments. So it's to learn from the people on the ground and work in partnership with.
Thank you.
Yeah.
Let me ask a question of Dr. Hegerl and then open it up to the panelists for questions or comments you have. So modelers have these sophisticated climate models now that can do so well at predicting both the past and future climate. Can modelers now retire? Are you done with your work? What are the leading edges of research? What are the big questions out there that modelers are working on?
So we would like to predict a bit. So there is this gap in our. So we can predict the weather because we start with exactly where we are and run forward. We can predict climate by not attempting to predict the weather, but just say the mean state, the mean climate will change. But we can actually. There's this gap in between what happens next week and what happens in 20 years, where we have a combination of knowledge from where we stand and where we're going, and what the factors are that influence climate. So I think we will get a bit better at knowing if the next winter, for example, is going to be one of the wet, windy ones or one of the ones with lots of snowstorms. But understanding how climate change will impact us, how it will affect extreme events, is still, we have to do a lot. We're still not confident how hurricanes will change, and I think there is a lot of movement on that area, and the people working in it are getting more confident that the strongest ones are getting stronger. The models don't do the heat waves quite right, even something as simple as a heat wave. We worry that climate change disrupts the major weather patterns, and that is something that our models are terrible at right now. So we really want to, they do the weather patterns where they are, but they don't very well change them. So we see in the data that they have changed a bit over time, and the models don't want to change them as much. So that's a huge frontier. So if you have, for example, in Wisconsin, I'm an idiot, in Minnesota, if you have, your snowstorms will depend on if you have more westerly wind or not so much westerly wind, and if climate change messes with that, that is something that really affects how climate change affects you. So we need to do much more to understand that better. I wanted to connect to Sila's indigenous knowledge. We use in our data in the moment knowledge, old diaries from monks and stuff, and I think it would be really fascinating if we could add the knowledge from the Arctic that comes from the long term, from the memory that your people have. So I hope that this is an area that develops well.
Mike, could I about predictability, because very often we hear talk, or climate change is making the climate less predictable, the weather is less predictable. I mean, Sheila made that observation as well. And yet, on the other hand, scientists and climate modelers are aiming for greater predictability, more skill, either in short-term weather or in decadal climates. So I just wonder how do you sort of tie those two perspectives up? Is climate and weather becoming less predictable, or are scientists being able to make the weather and the climate more predictable?
So maybe if both things happen,
and I wonder whether it's predictability or variability. Sometimes people use variability when actually they talk about predictability when actually they mean variability.
Yes, exactly. That's exactly the issue is, and it's one of these uncertain things that we really don't know enough about, is to what extent, for example, the retreat of the ice in the Arctic changes our weather patterns. That is something that we debate about furiously. Some people argue strongly that they will make the weather more variable and that they will lead to more winter storms, less westerly circulation and more kind of meandering and more colder outbreaks. And other people argue that the evidence in the observations is not so clear, and we don't understand it enough. So I'm personally sitting firmly on the fence on this one, but it's definitely a possibility. But you're right, it's variability, not predictability.
So climate can become more variable, but nevertheless we can still
we can still try to predict it better, but it's going to be a challenge. We can do maybe 1 year ahead. We can say there is some climate centers that can now say we get the next winter we are going to get somewhat more westerly, straightforward, wet and windy winter, or we get a tendency for a cold and a very cold and sunny winter. But that's just on the cusp, and it just goes for 1 year, and maybe if you're super lucky too. But
Dr. Liverman.
Yes, I have a comment and a question for Sila. I found your talk very moving. And firstly, it reminded me that when I talked about people moving out of poverty over the last 25 years, I should have given that more historical context, because many of those people were forced into poverty by colonialism and dispossession and trauma. So in some ways, we're bringing them back into a better life. But my question is about the risk of the recolonization of the Arctic because of the power interests in the opening up of the ice and trade routes, the opening up of mining opportunities as the ice melts. And I'm wondering how one can respond to now a new set of, well, not always new, but a re-interest in the Arctic as a place for resource exploitation and trade.
Are you looking at me?
Yeah.
Okay. You look like you're looking over here.
No, I can't.
You know, we talk about these issues a lot, and our leaders are certainly in the game of, you know, working with our governments and working with others, and we can see what's coming down the road. We have been signaling this for the last 20 years or so. You know, the Northwest Passage that's going to open up to benefit the global markets once again, because it always comes back down to that. I mean, the history of Inuit goes way back. I didn't even mention that in my talk today, but I do briefly touch upon it in the book, where we were hunters first and foremost, providing for our children and our families in the 40s or even the 30s, when the global market for fur came into play, and we became trappers to meet global markets. We were not trappers per se. We would trap for our own clothing. But then we started to feed the global markets, and the same thing happened with whales and so on and so forth. And so there's been that whole history with the Arctic, and how do we grapple with the world coming onto us so quickly and us having to play these roles. So we have been signaling that, and we've been saying caution to the wind, because, you know, the Northwest Passage is considered, we say it's ours, it's Canadian. Inuit Canadian have been up there for forever, hunting, fishing, living there. Of course, America says, no, it's international water. So all of those things are happening. And we also know that with the melt of the ice, the accessibility to the resources, the rich resources that lie beneath that ice, is something that we have now an influx of mining companies, exploration companies, oil and gas exploration that's going up there in more numbers than we've ever seen because of that. So we know that there are things coming down the road. But, you know, the issue here is for us as a people is, number one, what are the benefits to something like this? You know, I guess you can kind of see it like a cancer. If it's coming in, let's try to make it as benign as possible. And how do we do that? How do we get the people on board that are going to be, you know, given the jobs and the training? And is it going to be long-lasting and sustainable? And is it going to leave us as least amount of footprint as possible? Are those things possible? We ask about that because we're not sure. But that seems to be the only carrot that's being dangled in front of us right now. And of course, when people are poor and have no jobs, they're going to go for that carrot that's being dangled in front of them. And so what we've been thinking about and doing, and that's really new in terms of what's happened recently, and yes, maybe it's a campaign promise because we're up for elections in a couple of weeks, but what's happening here is that we have been talking about there are surely other ways in which the Arctic can rise and be innovative and be respectful of the land. Because believe me, when the hunters and the people who go and work for those mining companies who have held the land sacred, it's innate, it's in our genetic coding, it's who we are, it's in our DNA, to feel that connection to the land and keep it sacred. So imagine what the men come back home at the end of the day when they have dug up the very ground that they have held sacred for so long. It just doesn't seem to work, and the culture of mining is also extremely not a good place. And so we have been thinking a lot, and I remember when I was working on the issues of the Royal Commission, way back when Canada had the Royal Commission for Indigenous Peoples, met a professor, in fact, here in the US, Richard Kalt from Harvard University, who'd been studying reservations, Indian reservations here, First Nations reservations, and wondered, what was working, even if they had resources around them. What was working, what was not, what made it work, And so to make a long story short, and very short about what he said, because you can Google that and look it up, Joseph Kalt, not Richard Kalt. And one of them was, if the reservations, the Indian tribes had a governance system that was indigenous, that was number one, that made it quite successful. The other was that if it was a culture match initiative, then it worked very well. And we've been thinking about these things for a long time. And recently, what we're doing now, and if you Google this, because everything's about Google today, you can look it up and know that it's true. There was an announcement made a couple of months ago. Well, not all, everything's true. I'm not suggesting that. But if you Google and look up the negotiations that were done recently with a Baffin Island in Nunavut, who negotiated with the federal government of Canada on conservation economies, meaning hunters who know what they're doing, who know the land, who don't necessarily have to be trained for years to protect the very land and be paid for it. And so there was that recent agreement that was made in our country, and I feel that's the way that we can bring back that sense of dignity and pride in doing something that you know by protecting what you love. And that's conservation economies. And that's what we're working towards now. And that's a great example that has just been recently negotiated with the government of Canada, in Canada itself. So I don't know if that directly answers some of your questions, but why wouldn't it be that way? Why wouldn't the people that are most negatively impacted by that now come in with that kind of wisdom and be protecting the land and be paid for it? You know? Guardians.
Other questions or comments from presenters? Professor Keith?
Sure. I want to take the provocative position that from the point of view of climate policy, climate scientists could mostly retire. Now, of course, there's an enormous amount of really exciting work to do on near-term prediction. Just as Gabby said, there's lots more exciting science to do. It's amazing. But in terms of the really big picture things we need to know to make the decisions about cutting emissions, I think it's remarkable how little the science has changed. So I've been working climate science for 30 years, and there's new papers, new excitement. There's stuff that we can do now I would not have guessed, or in fact I guessed that we could not ever do. But I think it's important not to lose sight in all the new science of the big picture that we really know about the large-scale impacts, and that we do not know in a precise way exactly how much the climate will change here or there. And it's tempting to think, wouldn't it be great if we knew all that? But it's not actually obvious we'd be politically better off if we did. It's often easier to make a deal in a situation where we know that generally everybody will be worse off, but we don't know exactly who's the winners and who's the losers, than if you actually did know that. And think about that as Rawls's original position, for those of you who thought about political philosophy. And I think that it really is important to say that, as much as, of course, I'm not actually saying the climate science world should just retire, that with respect to the big decisions we need to make about climate policy, about how we fight politically to cut emissions, I think their job is mostly done.
I know Dr. Ghosh has a question. Dr. Liverman, were you going to respond to what Dr. Keith just said? Or
I'll do it really briefly, which is, there's one question I really want to know the answer to, which has to do with adaptation, and I don't know if it would have been the one I asked Gabby, which is, if we're going to continue to increase temperature, supposing we go to 3.5, and then we do policy acts fast enough and we bring emissions down, one of the questions that's been keeping me up at night is how long does that temperature stay high before it comes down? And also, will the ice ever refreeze, and will the sea level drop down? And so that, I don't know if there's enough papers on that, what I call the sort of overshoot scenario
yeah.
and surviving it. I don't know if you have a comment on that, because that would be the disagreement I would have with David, is I haven't seen you tell us that yet.
Yeah, I didn't talk about the overshoot scenarios, but that is one aspect where we are still doing new things. But I agree with Keith that to make a decision if we need to do something about climate change or not, we know enough. It's still helpful if we can understand more what's coming for adaptation, and it will be important to know that. And it will also be important to know how far we will overshoot and how long it takes to get it down, and where the tipping points are, where you can't get it back. Like if we know that if we melt the Greenland ice sheet, we would have to make it a lot colder to get it back, because then when you expose dark land, the whole area would become much warmer. But that's an extreme case, and it's something that I don't even want to contemplate. But there could be smaller scale issues like that buried somewhere.
Right, so just to add a little bit, the long-term commitment becomes real, and it becomes really important. If we bring the temperature back down fast enough, the usual modeling is that Greenland's ice will survive. If we wait too long, it won't, because it gets harder and harder to grow it back as it gets thinner and thinner. The frozen ground that we thaw will probably refreeze. The sea ice will probably grow back without too much hysteresis, too much delay. It's sort of, you make it colder and the ocean will freeze again. West Antarctica's ice, if we dump it, will be a very long time coming back. And so there are pieces of this that are essentially irreversible. They're not. West Antarctica's ice grew. It will grow back, but not on human timescales. So.
Okay. Thank you.
Dr. Ghosh.
Oh, well, I think I speak for everyone here when I say that, Sheila, your talk was so incredibly moving, and in so many ways really just went to the heart of everything that is so important about the current crisis. But in relation to the geopolitics of climate change, one thing I think we need to notice is that even if they were not looking at the Arctic as a source of resources, there is still a very important geopolitical incentive for China and Russia to open up the polar route, simply because it allows them to escape the Anglo-American hold on the Atlantic and the Indian Ocean. So that's one of the reasons why they're pushing so hard over there. The second thing I wanted to say is that, I was so moved by this, what you said. We can't think our way out of this crisis. We have to feel our way out of this crisis. Can we really even begin to address the significance of that in a system of knowledge where thinking and feeling are completely opposed, where the fundamental sort of basis of this system of knowledge is one where, the idea of objectivity is conceived of as the suppression of feeling, the exclusion of feeling. So when we look at this crisis, the one thing we do know is that we will never know enough. I mean, that is exactly what has been demonstrated, really, by, 200 years of science, if you like, that we will never know enough. And that, in fact, there is no way around, as you say, feeling, to understand, what it is that we want, in the sense of emotions, in the sense of an aspiration. What do you think? Do you think we could ever get there?
I don't think I'd be sitting here if I didn't think we could. It's a long process, long travels to go away and have these kinds of settings, but I have enough hope in the audiences that I speak to because of that connection and that resonance of truth, that I get that feedback. I get sustained by that connection. And I don't think it's me speaking from the head that makes that connection. I think it's the heart-to-heart issues that I speak to as our common humanity, our human spirit, our common spirit. So I think we will very slowly get there, but I think, again, I go back to the younger generation that are not mired in the politics, that are thinking differently and feeling differently about these issues. And that's where the hope is. I mean, you look at Greta Thunberg and the movement that she's created, By the way, it's announced, as it came in through my email today, she has won the Right Livelihood Award in Sweden, one of the 3. And so there's a resonance there that continues to happen. And so I think so. I think it is going to be, because we live in a world where we have turned a blind eye to so many issues that are impacting those that are marginalized, and those are the most challenged in the world. And so I think it is that disconnect with one another, disconnect to all kinds of issues, that we are dealing with this issue in a very heady way, in a very political way, without really humanizing these issues. And so my hope is always supported by the actual connections that are made around the world in the talks that I give. And that's what drives me to keep doing what I do, because I think there is that sense of hope. We are in a world that I think really just others one another way too much. And we have a hard time understanding with compassion when we say, this is what's happening in our communities. You know, we don't get that. We go into negotiations in the global fund, and we heard that from our own scientists, how difficult it is to be negotiating these kinds of treaties. And I've been to several of these COP meetings, and there's really sometimes no heartbeat to it. And so, you know, it's to try to bring that feeling into those arenas. That's where the change will really happen, in terms of understanding one another rather than othering each other. And bring all these issues from the head to the heart, where real change happens. That's where real change happens. And so for me, that is the hope. And I speak to these issues from that place, and it is my hope that it is from that place that we can move forward from feeling these issues about climate change, of not just it being a scientific or a political issue, but one that really involves all of us from that place.
Absolutely.
You know?
We are getting lots of questions from the audience asking, what can we do? More articulate than that, but it comes down to that. What can we do? Dr. Keith?
Tell your politicians you want it fixed. That is the fundamental thing. I've spent much of my career working on the energy system side of this, and there are lots of tools by which we could cut emissions in developed societies quite quickly while maintaining a high standard of life. It will cost money, and that's why it's politically hard, and some people are going to lose. But for this to happen, the thing that we need is for enough people in our society to make this essentially their #1 issue. This is not something that will get done on some side deal in Washington. Having a nice agreement at the Conference of the Parties does not make action happen. This is something that costs a couple % of GDP in every big country. This is big money. And to make decisions like that, you need governments with mandates where that is their core thing, and where they can come into office making decisions that will move the economy at the level of % GDP. And to do that, they need some good fraction of voters who put it as their #1 issue. Doesn't matter what party, but what matters is that people know they will not get your vote unless they are going to make rational, fast action to cut emissions. That is the overwhelming thing. And there is a lot of talk about all these personal, you can look up lists on the internet of all these personal things you can do to somehow change your consumption. Maybe, but maybe those things just distract us from the central aspect, which is making the hard political choices. If you look at the huge environmental successes we've had, not just in the richest democracies, but really in much of the world now, improving air quality, toxics like heavy metals, global ozone, organochlorines like DDT, in all those cases, it was fundamentally a political fight with regulation driving technological change. In none of them did behavioral change play a significant role.
Dr. Alley.
Just to add very briefly, doing nothing about this is a political decision too, and more people will lose.
This is just about voting.
Yes.
I'll say what I said yesterday in the student group that we were in, and Diana, of course, started that by saying, I guess, precisely what David is saying about, you know, vote for the right politicians that are really going to make a difference. And I said, you know, I extended that to say, you yourselves, the younger generation, must move into those leadership roles. When you finish school, whenever the time is right for you, your generation is not mired in politics and all of the rest of it like my generation is. And if you can start from that place of heart, open-mindedness, open-heartedness, understanding these connections of our common humanity, then go for those leadership roles yourselves. And that will be the way in which you can change the world. Absolutely.
Dr. Heggerl.
I agree with all that is said. I think we can still, as individuals, if we make some of those choices, we also have an influence as consumers. It's not the same as an influence a politician has, but it does count. And I think it made a difference with the Montreal Protocol that also people were kind of moving against using the CFCs in their spray cans. And we've seen I think this is a bit more in Europe right now than in North America. They have, for those who have seen the Blue Planet documentary on the plastics, there has been a huge movement towards people just don't feel like they don't need to have a paper cup with a plastic lid anymore as much as they used to. And I think the consumers can influence what happens by making those choices, or putting a solar roof on your house and helps distribution of solar power and also helps your personal footprint. I think I'm going to get myself an electric car next time, even though I'm slightly concerned about the rare earths or so, but I think it will still be a good thing to do. So making individual choices that reflect your values and that reflect what you think is important does influence politics as well, I think, even if on a small scale.
Dr. Liverman.
So we all seem to have great faith in democracy when we're telling people to vote, but you know, there are billions of people in the world where they really don't feel like they have a vote. And even in this country, we have to hope that the power of citizen votes overcomes the power of money influencing politicians. So whilst voting is good and we really do need to vote, we need to think that we're not the only emitter, and there are parts of the world where it's not the vote that works. It might be social protest, it might be putting yourself in danger, trying to force your government to act. We've had so many environmental activists killed in different parts of the world for trying to protect the planet and their livelihoods, and in that case, the democracy didn't really work for them.
Mm-hmm. Well said. I should have said be politically active. Voting alone is not all of it. Fight, whether it's by protests or direct action or what have you.
Mm-hmm. But I would add that the personal actions really do matter. Very few people want to be on the bleeding edge. Everybody wants to be on the leading edge. And when you figure out the next company that does the green thing, when you figure out the better way to make things work for individuals, when you invent, when you build the business, and you make it possible for this transition to be easier, you move it forward. Mm-hmm. And so there really is a role for you as an individual doing what you do, as well as the collective actions of talking and voting.
Mm-hmm. Thank you.
Anyone else on the panel want to speak to that who hasn't?
Yeah, I mean, I'd add another perspective. Given that many of the decisions that we face in dealing with such a difficult question like climate change are ones that we're going to disagree over, to me, the most important thing to find our way through that is the nature and the quality of the political institutions that we have, whether in liberal democracies, whether in Chinese centralized authoritarian nations or others. And so something that everybody can do is to find ways of investing and increasing the trust that you and your neighbors, citizens, colleagues might place in the institutions that you have at different scales, whether it's local, whether it's national, whether it's international, in the institutional arrangements that we have for finding ways of deciding what to do when we disagree about what to do.
Yeah.
Because if we just pretend that we're all on the same side, then we're living in a fantasy world. And we need to find mechanisms to find these processes through these political institutions that will enable us to navigate through. And so for me, actually, yesterday we had news in the UK that was very uplifting in the sense that our political institutions worked. In the sense that...
You should explain what happened. Not everybody follows the British news.
In the sense that the executive was held to account by the judiciary. So whether it's paying more attention to national institutions, whether it's finding new mechanisms like citizens' assemblies or citizen juries, I think a lot of these questions actually, for me, come down to that type of a question.
And I should explain, because not all of you follow British politics, that basically the Prime Minister tried to close down Parliament to prevent the sort of Remain anti-Brexit, and the judiciary said that he couldn't do that. And
by 11-0.
Yeah, 11-0. And he had to fly back from his moment in the limelight at the climate summit and go back to work because Parliament's opened again.
A question from the audience. We are presented with two moral claims, that of a climate emergency that demands a technical response and a human rights claim by peoples most affected. If an effective solution disproportionately affects one group of people, how do our panelists think we should resolve the conflict?
And just to observe, this is picking up something that you said the other day, Professor Lieberman, when you said, there will be impacts on people. And Anna asked you the question, and then you followed up today with the observation that John Rawls would tell us we're best off if none of us knows who's going to be most harmed by a solution.
Well, I'll give my one version, which is the effort to create central pools of climate finance, which can help those who are particularly affected by climate change or don't have the funds for adaptation or don't have the funds for mitigation. So there have been estimates made of the amount of money that would be needed to help or incentivize people and also to help people adapt. And it has been part of international agreements. Unfortunately, it's a pathetic amount of money given the scope of the problem. So that is one remedy. The other is the lawsuits, such as the ones that youth are filing, because that's another way to get some sort of reparation or repair. So those would be two that maybe might balance winners or losers, but perhaps others have other ideas.
I mean, this is a very, very difficult question. I think it has to be done in very close collaboration, cooperation, listening to and acting on the demands of those who are most hurt, right? We cannot just do an economic optimization and then throw some money at people who were the losers. I think that this has to be a discussion that starts with the people who are losers and moves out from there.
I think when we filed the human rights petition to the Inter-American Commission on Human Rights, we were very cautious as Inuit not to make it a lawsuit because we didn't want to see it as money, that we were just after money. It was on moral ground that we really wanted. It was a way of reaching out, as I was saying. It was an act of generosity from the Inuit hunters to teach the world about what we were going through and the traditional knowledge of it. It was reaching out, not striking out. But in a sense, it was a way to get America to start to look at these issues from that perspective. So, I mean, going through the justice systems, of course, you need to have. We couldn't move forward once the Inter-American Commission denied us the true hearing about it, because we just didn't have the resources and the money to even move it forward beyond that. But again, it's a tough one. It's a really tough one for us who are already in those places where we just don't have a big pool of resources to use to defend our rights in that way, human rights in that way. But there are others now who are starting to pick up. The youth are starting to pick up. I just received another email this morning talking about the youth that are wanting to join is it the Juliana lawsuit, and I think that's the movement that's going to go. So good for them if they can find the resources and the arm power and all of that around them to move that forward, then that's going to be helpful for the cause.
We have one of those youth here.
Shout out to Nathan. One of the youth who is part of the Juliana lawsuit is a Gustie, so congratulations. Yeah.
Congratulations.
Let me go back to Sela's talk. You talked about learning from the land, and for many of us in this room, we don't know what that means or how we could try to do that here in our lives. Do you have any suggestions for us?
Well, first of all, not everybody has to become a hunter. You don't have to. But there are ways in which you can, and you already are doing it, I'm sure, in your lives. The younger generation, you're out in nature, you're kayaking, you're doing things that allows you to be in touch with your environment, your climate. And so there's already all of those things that are happening around you that perhaps you're just not even aware that are testing you every day. But nature is one of the best teachers in my experience, in my opinion. But you're also, if you're an athlete, you're testing yourself every day. You're becoming stronger by, the obstacles that you're facing in your lives every day, whether you're a sportsman or a fisherman, or you're out there doing nature walks and hikes and testing yourself in that way. And so for us, the character building skills that I talk about really is about that testing of yourself and elevating yourself to another level of awareness and consciousness about yourself. And unfortunately, what happened with us is we went from that to institutional schooling that often separates the character building. It often separates anyone with character in the classroom. And so for us, it's really been a challenge to try to gain that back and bring it back even into the institutional schooling. But you can do that wherever you are. It's to be able to test yourself out in nature and let nature teach you what it's like to grow up and have those kinds of building of your tenacity and your commitment and to be bold under pressure. And you can do that through sports as well. I mean, in Canada, we're very big on hockey. And so there are some good pluses to learning about yourself through the athletics as well. So there's many ways that you can do that as a youth. And not just necessarily in the hunting culture, but I speak from that because for us, that's our hunting. Our hunting grounds are our teaching grounds. They are our universities for our young children. And we've already lost so much throughout the process that by losing now the unpredictability of the climate and the conditions of the ice is making it very difficult for traditional knowledge now to be real, where our elders have now started to say, this is what I've taught you and this is what I'm teaching you, I have been taught for millennia or for decades from my own childhood. And they say there's a disclaimer now. However, because of climate change, it is not always going to be that way. You have to be even more vigilant and cautious about what you're doing out there on that ice.
So the challenges continue in that
Speaking
way.
of not always being that way, a question for Dr. Heggerl. What will really happen if we don't do anything about the climate right now? Where will we be in 50 years, say the models?
50 years. So the scenario, we call them scenarios, the hypothesis that we run through the model would be the high one, so that had 4 degrees further warming at the end of the century. So 4 degrees doesn't sound so bad, does it? But the last ice age was about 5 degrees colder than
It sounds
on
worse
average.
in Fahrenheit.
It's
Right.
oh, I need to go
convert
for
it into
Fahrenheit, yes, and I still right. And I had translated some of my slide numbers into Fahrenheit and then deleted them, not to have too much text. so 7-ish or so. Fahrenheit, 7-ish, and the last ice age is under 10 Fahrenheit, different from today. So it is a huge difference, and there are some changes that I'm particularly concerned about, which, for example, have been some papers that the Indian subcontinent might experience heat waves where it's dangerous for humans to be outside in parts of India, which is, so it's no longer it's just going to be hotter and you're going to be a bit more uncomfortable, but it's dangerous. And that is, I think, something that we should really keep in mind, that we are still animals that inhabit this planet just like the other animals, and we have our limitations, and we can't adjust to everything, and some things will, this is for me a very dangerous gamble to go there.
Just I'd add one thing to that, maybe to the question as well. So, you know, Gabby and climate scientists and climate models can help us think about what the climate might be like in 30, 40, 50 years' time. But the world in 30, 40, 50 years' time is going to be very, very different for a whole load of other reasons. And this is what I call climate reductionism. The danger is that we elevate climate as the only or the sole driver of the future. Whereas there are many, many other things driven by technologies, some of which will be good, some of which will be bad, some which will produce benefits, and others will produce new risks and hazards. So think about what else is changing. Go back 40 years. Go back to 1980, for those of you who were around in 1980. And just think about how different your life is now compared to how it was 40 years ago. And then think 40 years ahead. Accelerate that level of change in terms of new technologies, whether it's around communication technologies, biomedical technologies, nanomaterials, artificial intelligence, robotics, and recognize that all this is changing in a world in which climate, too, is changing. And then you have a better sense of how the future might unfold. But just focusing on climate, just because we got clever people like Gabby to help us to predict climate, does not mean we should forget about everything else that is also changing, that might indeed be much less predictable than the climate.
I totally agree, and we have one issue that is also changing rapidly is biodiversity, for example. So we can't think of climate change as the only issue we are facing, but I think climate change is making a lot of other issues we are facing worse, and I can't see many that it would make better. So it's it complicates lots of things, and biodiversity loss, for example, definitely gets complicated by climate change, and it's going to be made harder to save our diversity with a climate that changes on top of everything else.
Thank you very much, presenters and discussants. We'll break for lunch now.
I wanted to give you a copy of my notes.
Yes, please. Thank you.
I think we did well by our audience this time.
Okay.
It was good to have everyone here, that really none of these people has all that much to say about what we can do that they don't know, you know.
Just be aware of what goes in there. Just give it some second thought, like, oh, this should go in there.
We're setting a big goal here. We want to divert 90% of our waste to something other than a landfill or incineration. We want to recycle it. We want to put it to beneficial use.
I think as individuals, we can create that small change, but we need to come together as a community to create that greater change.
The food waste that's produced on campus is taken to our composter. It's then turned into soil, and that soil goes into our Big Hill Farm, where we also then produce things like lettuce and radishes, and that goes back into the cafeteria.
Students are the reason we have Big Hill Farm. They're the reason we have food waste composting. Our students build our community. They come, they bring themselves, they bring their efforts, and they leave us a better place.
Sustainability really is a Gusty thing because it considers the community that you're a part of. So it considers the people that produce food, how you consume that food, and what you do with the waste after that. It really is about caring about all those people that contribute to that system.
And it's not either take care of the environment or take care of people. It's one and the same.
I'm trying to give the incoming students essential information so it can be passed on to the new wave of students, so we can create a long-term change.
How can I help someone else with this? How can I make someone else's life better? And a decision to recycle well, to make a good choice when you approach those containers, is a decision to make somebody else's life better. It's a way to do something right by your fellow community members.
Because Gusties don't just think about today, they think about tomorrow.
So many of the different fields in science, most people aren't exposed to in their day-to-day life. The more you can get out there and communicate to the young people coming up that are the future of science, the better. You never know what's going to grab one individual, and so that's vital to inspire the next generation.
The Nobel Conference brings together students, faculty, and members of the general public to explore revolutionary, transformative, and pressing scientific questions and the ethical issues that arise alongside of them. We bring leading researchers to Gustavus, including nearly 100 Nobel laureates. We're trying to explore the ideas of science using all of the liberal arts, so the arts, the humanities, the social sciences, all of them working together.
There are a lot of people who are not scientists who like to share in the adventure of discovery, and to be able to share that joy with people who also get it, that there's something really exciting and cool going on. It just makes it just an enormous amount of fun.
There's sort of a festive atmosphere, which makes it part of a broader experience.
There aren't that many forums for us to have the discourse at that level with that sort of range of expertise, yet still focused on one sort of overarching topic.
One of the wonderful things about the Nobel Conference is it does give people the opportunity to ask people questions in an informal way. And you never know what statement somebody makes or what interaction that happens will make a change in somebody's life.
It's always very, very encouraging to see other colleagues of yours who are at the top of their game, and it makes you want to lift your game.
As you can feel the audience, and you can really feel when you've helped people to know something that they never knew before. It's really a feeling of discovery that you share.
What drives you? What do you long to be? A leader, a healer, an educator, an innovator, an explorer? We believe that whatever you dream, you can be. You can make a difference, make friends, make connections, make change, make the best life you can. Make your life count. Gustavus Adolphus College.
Fly fishing is visual. It's all about what the fly does on the water. The fish have no idea how it got there. You might have the ugliest cast in the world. There's something pretty special about watching a trout rise. Just sitting there. You can just sit in the bank and watch a trout. My life has kind of continued the same way as my life at Gustavus. You know, I played sports. I was in the symphony, ended up as a political science major. It gave me the opportunity to do kind of all sorts of stuff. One of the coolest things about Gustavus is I went to Ecuador, went to the Galapagos, went to the rainforest. That gave me quite a travel bug. Apparently had a real effect on my life because I've continued to do that. Outfitting or doing conservation work, there's got to be a benefit to the result. You got to do it, you got to have purpose. So in Mongolia, we're mapping the genetic populations of fish in these watersheds. What that data shows us is that each watershed's important. These fish have been isolated from one another for millions of years now. When I grew up, you catch a fish and just keep it. I probably wouldn't even think about whether that was legal or if I had the right number of hooks on my line or whatever. So Mongolia is very well regulated in terms of what legal fishing is. a lot of people just come out and fish, could be locals, could be foreigners or whatever, and are unaware. And so we tackled that. Catch and release fishing has grown in Mongolia like unbelievably. My name's Charlie Kahn and I'm a Gustie. Make your life count.
Chicago, Illinois. She stared down a gang of drug dealers and chased them away from her beloved Bethel Lutheran Church. She is fearless. In her junior year at Gustavus, she studied German literature in Munich, joined a Christian student movement, and sneaked beyond the Berlin Wall into East Germany just to share her faith. That's Mary Nelson, and she is fearless. Mary was the driving force of Bethel New Life. She, and as she describes them, the incredible people I worked with, are responsible for the rebirth of Chicago's West Garfield Park, a dangerous inner-city neighborhood. They created low-income housing and living wage jobs. The neighborhood high school she started graduates 95% of their students, compared to 50% in the other area schools. The result was a healthy, sustainable community. It's where Mary calls home. It's where she lives, volunteers, and worships today. She is fearless. It is impossible to recount all the things she's done in her life that go above and beyond. But her goal is creating a sense of community for all people, regardless of race and sex, to get people to do things that are bigger than themselves, and to realize that there is no community without justice. She says, it's a hope that comes through faith. Mary Nelson epitomizes Gustavus, and she is fearless.
For me, I knew coming into Gustavus that I wanted to do something in Scandinavian studies and Swedish, but also in the sciences. But I didn't necessarily know what direction I wanted to go with that. I actually had never really heard of doing research or that that was even an option in terms of a career coming into Gustavus. And during January term of my first year, I enrolled in biomolecular research. And during that time, we were able to spend every day in the lab. And I truly just fell in love with this idea of research. And really from there, I took every opportunity I could to explore research across the country and as well as in Sweden. And from there it took me to Syracuse University for part of the summer and back to Gustavus and to Karolinska and to the National Cancer Institute and some time at the Mayo Clinic through the Mayo Innovation Scholars Program and eventually to NIH for that year following graduation and now here to Harvard Medical School. I really felt coming from Gustavus that I was well prepared going into medical school. And it's not only from the classes I took, but also from just being able to be engaged in the community and all of those activities and getting to talk to people from across campus and learn their stories. It really becomes a part of medicine as well. Every day in medical school when we're interviewing patients, you have to be able to then summarize and present that information. So there's a lot of communication that I don't think people always appreciate. They just think that it's science. I think it ties in so many aspects that people don't realize that you gain during the liberal arts. So it's that respect for how someone's socioeconomic status ties in with their health conditions and really just being able to think about those problems all at the same time and try to bring the whole story together. Truly everything that you work on in the sciences is somehow connected to the greater picture. I think people make their life count in different ways, and it was sort of through my experiences in Sweden and on campus and at the Mayo Clinic that it all started to come together, this idea of being a physician scientist. And really where I see my career going is hopefully being able to combine those worlds and sort of be in that middle ground, working in research that's relevant to the patients, and hopefully the patients that I see will help to inform my research questions that I'm pursuing as well. You get to think about what is known, but also what isn't known yet, and to try to better understand that in the context of health and disease is just an amazing opportunity.
So many of the different fields in science, most people aren't exposed to in their day-to-day life. The more you can get out there and communicate to the young people coming up that are the future of science, the better. You never know what's going to grab one individual, and so that's vital to inspire the next generation.
The Nobel Conference brings together students, faculty, and members of the general public to explore revolutionary, transformative, and pressing scientific questions and the ethical issues that arise alongside of them. We bring leading researchers to Gustavus, including nearly 100 Nobel laureates. We're trying to explore the ideas of science using all of the liberal arts, so the arts, the humanities, the social sciences, all of them working together.
There are a lot of people who are not scientists who like to share in the adventure of discovery and to be able to share that joy with people who also get it, that there's something really exciting and cool going on. It just makes it just an enormous amount of fun.
There's sort of a festive atmosphere, which makes it part of a broader experience.
There aren't that many forums for us to have the discourse at that level with that sort of range of expertise, yet still focused on one sort of overarching topic.
One of the wonderful things about the Nobel Conference is it does give people the opportunity to ask people questions in an informal way. And you never know what statement somebody makes or what interaction that happens will make a change in somebody's life.
It's always very, very encouraging to see other colleagues of yours who are at the top of their game, and it makes you want to lift your game.
As you can feel the audience, and you can really feel when You've helped people to know something that they never knew before. It's really a feeling of discovery that you share.
What drives you? What do you long to be? A leader, a healer, an educator, an innovator, an explorer? We believe that whatever you dream, you can be. You can make a difference, make friends, make connections, make change, make the best life you can. Make your life count. Gustavus Adolphus College.
I think it's a good idea to do this because we think like all of our actions are very little and it doesn't affect the world in a larger context.
On the surface, it's about the stuff, the stuff we buy, the waste that's produced by that, what happens when we throw it away. But I've come to the conclusion that it's really on a deeper level, it's about community.
We're part of a much greater community. This is a global community we're doing, and like our actions affect this.
We're really trying to reduce the waste that we do produce. So something we've been pursuing is composting on campus. Currently we have compost bins in the campus center, the main building, and we have a composter towards the back of our campus. So that is really trying to get items that would traditionally go to a landfill out of those areas and into the compost to produce soil that is used to produce food.
Every time we're putting something in a trash can, every time we're putting something in a recycle bin or the food waste composting container, it's a human transaction. There's somebody on the other side who has to take care of it. Or if we don't take care of it properly, there's somebody downstream who's suffering because of what we do.
Just stop and think, where does this go? Is this a compostable item? Is this a recyclable item? Or does it go to the landfill?
So when you're approaching the 3 bins, the compost, recycling, and trash, just be aware of what goes in there. Just give it some second thought, like, oh, this should go in there.
We're setting a big goal here. We want to divert 90% of our waste to something other than a landfill or incineration. We want to recycle it, we want to put it to beneficial use.
I think as individuals, we can create that small change, but we need to come together as a community to create that greater change.
The food waste that's produced on campus is taken to our composter. It's then turned into soil, and that soil goes into our Big Hill Farm, where we also then produce things like lettuce and radishes, and that goes back into the cafeteria.
Students are the reason we have Big Hill Farm. They're the reason we have food waste composting. Our students build our community. They come, they bring themselves, they bring their efforts, and they leave us a better place.
Sustainability really is a Gusty thing because it considers the community that you're a part of. So it considers the people that produce food, how you consume that food, and what you do with the waste after that. Really is about caring about all those people that contribute to that system.
And it's not either take care of the environment or take care of people, it's one and the same.
I'm trying to give the incoming students essential information so it can be passed on to the new wave of students, so we can create a long-term change.
How can I help someone else with this? How can I make someone else's life better? And a decision to recycle well, to make a good choice when you approach those containers, is a decision to make somebody else's life better. It's a way to do something right by your fellow community members.
Because Gusties don't just think about today, they think about tomorrow.
I came into Gustavus and I was going to be a pharmacist. And so I was going to go to Gustavus for 2 years, and then I was going to transfer and get my pharmacy degree. I was so confident coming in. And I took organic chemistry, and I was a deer in the headlights. I came into a January term where I took a math and finance class, and I loved it. It made complete sense to me. I understood what was going on, and I could see how it could be impactful. And it was about this time that I called Dad and I said, I don't think I'm going to be a pharmacist. There wasn't enough money for me to continue to stay at Gustavus. Ultimately, an anonymous donor basically helped make the difference in my tuition for my last 2 years at Gustavus, and that was why I was able to graduate from Gustavus. Somebody cared enough to help somebody they didn't even know and made an investment. And they didn't know exactly what it was that was going to kind of create the impact, but I'd like to believe that, you know, that has very much influenced the way I think about how to pay it forward. I'm very enthusiastic about women's leadership in this generation and going forward because there's a big need for it. There's a lot more demand than supply. I think GWEL, Gustavus Women in Leadership, is a wonderful organization, and that's why I'm so enthusiastic about participating in it, really, with talented students and other talented alumni. It's a very cool concept. So really it's been both kind of a financial and a personal commitment to the program. It really is exciting for me to have women share their, whatever they define success, what does that look like to you? To be able to share that with young women and empower this next generation of women in a very, very material way. So, and it's fun, and it's a great group of women, and it's a wonderful organization. It's hard not to get enthusiastic about it.
One of the things that's important to me is to make sure that I'm living out my life according to my ideals in a consistent and coherent manner, whether that's the way that I interact with my family and my friends, whether it's the way that I interact with students and my colleagues, and then also the contributions that I'm making in the larger world. I think a life lived with purpose really has to do with connecting all the different parts of your life in accordance with your values. So one of the things that I try to do is stay on top of what's on the news and what kinds of things are happening in the world, both far away and also close to home. And then I try and bring that into the classroom as much as I'm able to show students that anything you're learning within the classroom can have some kind of connection to what's going on in the rest of the world. By allowing them to take advantage of many opportunities to take their passions and their knowledge and put them into action, not only during their time at Gustavus, but also after they've graduated, so that they can continue making contributions into the world for many years. These days, we're facing a lot of different challenges and a lot of huge changes in society and the way that societies work. And a liberal arts education provides students with the knowledge and, more importantly, the tools, the kind of intellectual habits of mind that allows students to look at an issue and then take a really 360-degree kind of approach to whatever problem it is that you're trying to solve. I think a liberal arts education also equips students to talk to one another. And I think we can all agree that communication between and across different groups of people is really, really important for the ability to work together and to find some common understanding. One of the things I've really loved about Gustavus is that it not only provides students an opportunity to grow in all of these different intellectual and social and cultural areas, it's that it also provides faculty an opportunity to do that as well, because I recognized it as a place that had a lot of amazing people that I could learn from and work with. And I saw Gustavus as a place where I could actually make some kind of impact. Gustavus Adolphus College. Make your life count.
So many of the different fields in science, most people aren't exposed to in their day-to-day life. The more you can get out there and communicate to the young people coming up that are the future of science, the better. You never know what's going to grab one individual, and so that's vital to inspire the next generation.
The Nobel Conference brings together students, faculty, and members of the general public to explore revolutionary, transformative, and pressing scientific questions and the ethical issues that arise alongside of them. We bring leading researchers to Gustavus, including nearly 100 Nobel laureates. We're trying to explore the ideas of science using all of the liberal arts, so the arts, the humanities, the social sciences, all of them working together.
There are a lot of people who are not scientists who like to share in the adventure of discovery and to be able to share that joy with people who also get it, that there's something really exciting and cool going on. It just makes it just an enormous amount of fun.
There's sort of a festive atmosphere, which makes it part of a broader experience.
There aren't that many forums for us to have the discourse at that level with that sort of range of expertise, yet still focused on one sort of overarching topic.
One of the wonderful things about the Nobel Conference is it does give people the opportunity to ask people questions in an informal way. And you never know what statement somebody makes or what interaction that happens will make a change in somebody's life.
It's always very, very encouraging to see other colleagues of yours who are at the top of their game, and it makes you want to lift your game.
As you can feel the audience, and you can really feel when you've helped people to know something that they never knew before. It's really a feeling of discovery that you share.
I think it's a good idea to do this because we think like all of our actions are very little and it doesn't affect the world in a larger context.
On the surface, it's about the stuff, the stuff we buy, the waste that's produced by that, what happens when we throw it away. But I've come to the conclusion that it's really on a deeper level, it's about community.
We're part of a much greater community. This is a global community we're doing, and like our actions affect this.
We're really trying to reduce the waste that we do produce. So something we've been pursuing is composting on campus. Currently we have compost bins in the campus center, the main building, and we have a composter towards the back of our campus. So that is really trying to get items that would traditionally go to a landfill out of those areas and into the compost to produce soil that is used to produce food.
Every time we're putting something in a trash can, every time we're putting something in a recycle bin or the food waste composting container, it's a human transaction. There's somebody on the other side who has to take care of it. Or if we don't take care of it properly, there's somebody downstream who's suffering because of what we do.
Just stop and think, where does this go? Is this a compostable item? Is this a recyclable item? Or does it go to the landfill?
So when you're approaching the 3 bins, the compost, recycling, and trash, just be aware of what goes in there. Just give it some second thought, like, oh, this should go in there.
We're setting a big goal here. We want to divert 90% of our waste to something other than a landfill or incineration. We want to recycle it, we want to put it to beneficial use.
I think as individuals, we can create that small change, but we need to come together as a community to create that greater change.
The food waste that's produced on campus is taken to our composter. It's then turned into soil, and that soil goes into our Big Hill farm, where we also then produce things like lettuce and radishes, and that goes back into the cafeteria.
Students are the reason we have Big Hill Farm. They're the reason we have food waste composting. Our students build our community. They come, they bring themselves, they bring their efforts, and they leave us a better place.
Sustainability really is a gusty thing because it considers the community that you're a part of. So it considers the people that produce food, how you consume that food, and what you do with the waste after that. It really is about caring about all those people that contribute to that system.
And it's not either take care of the environment or take care of people, it's one and the same.
I'm trying to give the incoming students essential information so it can be passed on to the new wave of students, so we can create a long-term change.
How can I help someone else with this? How can I make someone else's life better? And a decision to recycle well, to make a good choice when you approach those containers, is a decision to make somebody else's life better. It's a way to do something right by your fellow community members.
Because Gusties don't just think about today, they think about tomorrow.
Service has been an important part of my life since the very beginning. That's really why we're here on Earth, right? Is to help each other out and help out future generations. And I feel like the way I can best do that is through medicine. At Gustavus, that was another draw, is the service aspect, and that we can give back to the community. I feel valued when I talk to professors at Gustavus. They really are genuine in their interest in what I'm doing and in my interests and how I want to pursue medicine in the future, and they're willing to go above and beyond what I would expect from a professor to help me out with scholarships or fellowship opportunities or research experiences for the summer. And I see that with me as well as with other students. And if I were at a larger school, I don't think those one-on-one interactions would be as possible or even as meaningful. Gustavus does a really good job in allowing the students to develop their own experiments and conduct their own research, which is essential in preparing us for the real world. But having new facilities, state-of-the-art technology to work with would make the experience even better. Part of my interest in medicine means working with patients and getting clinical practice, and something that Gustavus has done that has really provided me with that opportunity is allowing me to volunteer at Mayo Clinic in the emergency department. And that's something that you don't see with a lot of other institutions. It's hard to find a way to work with such a prestigious institution such as the Mayo Clinic, and having professionals at Gustavus that have that connection made for the students is essential and something that I really value, that has helped me excel in my understanding of medicine. I know I will remember the Nobel Conference, having the opportunity to host the Damasio's as well as the Candels. Like, meeting a Nobel laureate, that's something that I never would have dreamed of doing, even as a professional. Having the opportunity as an undergraduate student is beyond crazy. Incredible opportunities came from that hosting. I got to go to California and work at the Brain and Creativity Institute, which is the lab that Dr. Damasio runs. I had the opportunity to write a literature review and work with MRI machines and EEGs. So all of those experiences were fascinating and directly correlated to my hosting the Nobel Conference. Something that surprised me about Gustavus is how many connections I would end up making here. I definitely, before attending college, thought that this was the middle ground. I would be here for 4 years and be out and doing medical school or my career. But the connections that I've made here, I know are going to be lifelong and will actually help me even more in the work that I end up doing in the future.
What drives you? What do you long to be? A leader, a healer, an educator, an innovator, an explorer? We believe that whatever you dream, you can be. You can make a difference, make friends, make connections, make change, make the best life you can. Make your life count. Gustavus Adolphus College.
Making my life count, I think, is somehow finding a way to give voice to the voiceless through art and education, and figuring a way that my voice can add to that conversation is something that I'm striving for. There's so much good that I think is inherent with what it means to just go about our daily lives and go about our daily business. And we fixate, unfortunately, on the negative. And in that way, we need art and we need moments of levity and education to sort of like wrap our heads around this insane kind of world, because we're just trying to make it up as we go along. Gustavus provides a lot of platforms for figuring out who and what I might need to be, want to be, what I could become. And I joined a social justice theater group, and I was on a football team, and I was in a choir, and I was learning about histories and learning about what stories I represent and what stories I've been made to represent. And in the Gusty way of like being a Gusty and that sort of transcending all reality. Once I left Gustavus, I had to really do that again, and trying to explain that. So I just sort of tried to become something that was of excellence and that was of creativity and striving. Maria Tierney gave me the option. She opened up the door. I had, again, a liberal arts education. My general requirements were things like poetry and anthropology, religion. So I had to take some sort of art credit, and it was between drawing and dance. And I couldn't draw, so I decided to take a dance class. Fundamentals of Modern, got in touch with my body, and as an athlete, I was already, thinking I was in touch with my body. So then I took the next course, and at one point, I don't even know, just happenstance, I think she was just like off the cuff. She's like, you should think about doing this. And I was like, I should think about doing what? And she was like, dance. And at that time, I had no idea that dance could even be a career, could be a profession. And so again, in that naive sensibility, I was like, all right, declared a major. And that's what happened. Maria Tierney just gave me the option where I didn't have it before. I'm Brian J. Evans, and I'm a Gustie. Gustavus Adolphus College. Make your life count.
So many of the different fields in science, most people aren't exposed to in their day-to-day life. The more you can get out there and communicate to the young people coming up that are the future of science, the better. You never know what's going to grab one individual, and so that's vital to inspire the next generation.
The Nobel Conference brings together students, faculty, and members of the general public to explore revolutionary, transformative, and pressing scientific questions and the ethical issues that arise alongside of them. We bring leading researchers to Gustavus, including nearly 100 Nobel laureates. We're trying to explore the ideas of science using all of the liberal arts, so the arts, the humanities, the social sciences, all of them working together.
There are a lot of people who are not scientists who like to share in the adventure of discovery, and to be able to share that joy with people who also get it, that there's something really exciting and cool going on. It just makes it just an enormous amount of fun.
There's sort of a festive atmosphere, which makes it part of a broader experience.
There aren't that many forums for us to have the discourse at that level with that sort of range of expertise, yet still focused on one sort of overarching topic.
One of the wonderful things about the Nobel Conference is it does give people the opportunity to ask people questions in an informal way. And you never know what statement somebody makes or what interaction that happens will make a change in somebody's life.
It's always very, very encouraging to see other colleagues of yours who are at the top of their game, and it makes you want to lift your game.
As you can feel the audience, and you can really feel when you've helped people to know something that they never knew before. It's really a feeling of discovery that you share.
The quote that I identify with most when it comes to change is how Georgia O'Keeffe said, "I've been terrified every single day of my life, but it never stopped me from doing everything that I wanted to do." Change is really tricky because it, in the moment, is really exhausting and pushes you to places that you don't feel like you have the capacity for sometimes because you've never faced those situations. I never thought that I would ever move away from the Twin Cities because my life in Minnesota, it was such a sweet, lovely life. When I was a senior, I co-chaired the Gustavus Women in Leadership Conference, and we had an amazing keynote speaker who was an alum, and she and I really connected, and 2 weeks before graduation, she called me and said, "Hey, would you like to come work for me at Deloitte?" During the interview process, I enjoyed every single person that I met, and they were all so enthusiastic and driven, and most of them were women, and I was so impressed by that, and I just felt like this was the right decision for me, and it was totally a gut instinct. And I was so excited, honestly, to work for Auguste that I immediately said yes, and I now live in Chicago. I just felt like this really aligned with my values and the things that were important to me, and a lot of those values were things that became apparent to me during my time at Gustavus. GWIL was transformational for me in learning about what mattered to me in a work environment. So I realized that I wanted to be surrounded by women leaders. I wanted to be in an environment where women were allowed to thrive and be successful and had opportunities for growth. By joining the Gustavus Women in Leadership organization, I had the opportunity to use my strengths and my skills and also build my skills that now I can use in my work environment today, but also get exposure to really exceptional, smart, driven women leaders. Anybody can navigate change if they're true to their authentic self. And if they make decisions not based out of fear, if they make decisions that align with what's important and align with their values, and ultimately I feel like I end up living a lot more intentionally. Growing pains are so real, but they are so worth it. An abundance of blessings and good things can come out of change. I don't regret moving to Chicago. I don't regret incorporating all of this terrifying change into my life, because I think it's made me braver and it's made me kinder and more compassionate. I've learned a lot about myself in the process that I just don't think that I could have learned had I played it safe. I'm just so empowered now. I'm so ready to I'm ready for the next thing because I did this.
I think it's a good idea to do this because we think like all of our actions are very little and it doesn't affect the world in a larger context.
On the surface, it's about the stuff, the stuff we buy, the waste that's produced by that, what happens when we throw it away. But I've come to the conclusion that it's really on a deeper level, it's about community.
We're part of a much greater community. This is a global community we're doing, and like our actions affect this.
We're really trying to reduce the waste that we do produce. So something we've been pursuing is composting on campus. Currently we have compost bins in the campus center, the main building, and we have a composter towards the back of our campus. So that is really trying to get items that would traditionally go to a landfill out of those areas and into the compost to produce soil that is used to produce food.
every time we're putting something in a trash can, every time we're putting something in a recycle bin or the food waste composting container, it's a human transaction. There's somebody on the other side who has to take care of it. Or if we don't take care of it properly, there's somebody downstream who's suffering because of what we do.
Just stop and think, where does this go? Is this a compostable item? Is this a recyclable item? Or does it go to the landfill?
So when you're approaching the 3 bins, the compost, recycling, and trash, just be aware of what goes in there. Just give it some second thought, like, oh, this should go in there.
We're setting a big goal here. We want to divert 90% of our waste to something other than a landfill or incineration. We want to recycle it. We want to put it to beneficial use.
I think as individuals, we can create that small change, but we need to come together as a community to create that greater change.
The food waste that's produced on campus is taken to our composter. It's then turned into soil, and that soil goes into our Big Hill Farm, where we also then produce things like lettuce and radishes, and that goes back into the cafeteria.
Students are the reason we have Big Hill Farm. They're the reason we have food waste composting. Our students build our community. They come, they bring themselves, they bring their efforts, and they leave us a better place.
Sustainability really is a Gusty thing because it considers the community that you're a part of. So it considers the people that produce food, how you consume that food, and what you do with the waste after that. It really is about caring about all those people that contribute to that system.
And it's not either take care of the environment or take care of people, it's one and the same.
I'm trying to give the incoming students essential information so it can be passed on to the new wave of students, so we could create a long-term change.
How can I help someone else with this? How can I make someone else's life better? And a decision to recycle well, to make a good choice when you approach those containers, is a decision to make somebody else's life better. It's a way to do something right by your fellow community members.
Because Gusties don't just think about today, they think about tomorrow.
Good afternoon. My name is Mara Klein, and I am the Director of Fine Arts Programs at Gustavus. Thank you for joining us for the final afternoon of presentations and discussions on climate change today. To begin this afternoon's session, we will open with a musical prelude from the Gustavus Jazz Ensemble under the direction of Dr. Dave Stamps.
Right down the center, right down the center. 1, 2, 1, 2, 3, 4.
Good afternoon and welcome back to our final session. Thank you again to our jazz musicians, the last ensemble we heard from, and I want to just again thank all those musicians and conductors for they really did some woodshedding on those parts to be able to be here today. And I want to thank all of you who have joined us this year virtually and in the flesh. We're so happy that you did. And we hope to see you all back here next year. Don't forget you can buy your tickets already. And I would like to invite my colleague, Chuck Niederreiter, Professor of Physics and Environmental Studies, and might I add, the former director of the Nobel Conference. He watches every move I make, to introduce our next speaker to us.
Doesn't Lisa do a great job? I think she's wonderful. It is my pleasure this afternoon to introduce Dr. David Keith, Professor of Applied Physics at the Harvard School of Engineering and Applied Sciences and Professor of Public Policy at the Harvard Kennedy School. He is also co-founder, or the founder of Carbon Engineering, a company developing technology to capture CO2 from ambient air to make carbon-neutral hydrocarbon fuels. Dr. Keith earned his PhD in experimental physics from MIT, but chose a different trajectory for his career, moving into geoengineering as a postdoctoral fellow in Carnegie Mellon's Department of Engineering and Public Policy. He has been a professor at Harvard and the University of Calgary. In 2009, he founded Carbon Engineering, a Canadian-based clean energy company leading the commercialization of direct air capture technology that captures carbon dioxide directly from the atmosphere. Based in Cambridge, Professor Keith spends about a third of his time in Canmore, Alberta. Professor Keith has a long list of accolades and prizes, including the Diamond Jubilee Medal awarded by Queen Elizabeth II in 2013. He was named one of Time Magazine's Heroes of the Environment and was named Environmental Scientist of the Year by the Canadian Geographical Society. Dr. Keith serves on a number of organizations and boards that study energy and the environment, particularly carbon sequestration and geoengineering. He was the lead author of the IPCC Special Report and chair of the IPCC's Group on Regulation, Legal Issues, and Public Perception on Carbon Storage. In his book, A Case for Climate Engineering, Professor Keith argues that after decades during which very little progress has been made in reducing carbon emissions, we must put climate engineering on the table and consider it responsibly. Please help me welcome Professor Keith to address how might solar engineering fit into a sound climate policy. Professor Keith.
Thank you. Thank you very much. It's really a thrill to be here. Thank you to the organizers, and I apologize for not meeting yesterday. I'm starting to teach a freshman seminar at Harvard, and I just love it. It's the most thrilling thing I've done in a long time, and it only meets once a week, and once it ended up being Tuesday morning, I felt like I couldn't miss it. But this has been really fantastic to be part of this. So the big question that I'm supposed to tackle is, how does solar geoengineering fit into sensible climate policy? And the answer is, of course, that I don't know. And the answer is also for sure that it depends at least as much on all the other elements of climate policy and the politics that shape them as it does on anything specific about solar geoengineering. So I want to start by kind of warning you that while I'll talk about solar geoengineering for sure, I'm going to really talk a little bit about the politics first, and then try and cover both solar geoengineering and a little bit of energy system stuff and carbon removal, and then end up again talking about the politics, because I think they're really central to the way this might play out. Maybe it's worth thinking about the sort of structure of the different things different levers, if you like, that humans can pull. And again, that already has an image of like humans pulling one lever, whereas in fact there's billions of humans, and other humans will be affected who aren't born yet, and things that aren't humans who will also be affected, and in my view have some kind of rights, and we should care about them. But if you think at the sort of very highest level, the collective outcomes of the way we change the physical system, I think you can think about it as, first of all, what we do to decarbonize the energy system, to find ways to produce the energy that we need with no carbon emissions. And there's been none of the talks that you've heard or will hear centrally focuses on that. I'd be really happy to answer more questions about it, because it's, to be clear, the central actual political fight we're going to be having over the next decades. I mean, it's exactly what we do. What are the rules? How much solar versus how much nuclear versus how do we do long distance transmission? How do you think about batteries? How do you decarbonize this versus that? All that is the really meat of the issue. How do you think about that total cost? How does it compare to other costs we paid before for environmental protection? Those, to me, are the core of the way at least I think about the issue. Then, once we get emissions to zero, which I think is absolutely doable, but it's not anything that is just a matter of political will or can be done easily or simply can be done if we just like magically remove corruption, which we're not going to do anyway. But it's something that is inherently hard and slow to do, but very doable. Then it is also certainly possible to remove carbon dioxide from the air. I'll talk a little bit about that. But even though I'm actually thrilled to be involved in founding a company that's involved in that space, I'll say as a preview that I think there's an immense amount of overhype around carbon removal right now, and I'll give you a sense of why I think that's true. Then there's this possibility of solar geoengineering, of deliberately altering the Earth's reflectivity in some way to reduce some of the risks of accumulated greenhouse gases. And then finally, there's adaptation. There's local deliberate measures we take to reduce the impacts of climate change on humans or the natural environment. And those things together are a range of things that we might do. The problem doesn't get solved by any one of them, but the one that I think you cannot do without is emissions cuts. And I hope we'll inevitably spend some of the next session debating solar geoengineering. That's great, but I hope we spend a bunch of time really talking about how we decarbonize, because that's the central choice and action of this generation, I think. So you might ask what this picture is behind me. I decided just to avoid obvious cover slides and also to illustrate how personal this is for me and for everybody. It's personal for each of us in different ways. But for me, and by the way, whoever is organizing this, the speaker timer has not started, so I still have 45 minutes. And it would actually be helpful to have a speaker timer that was working. Now it's going. So this happens to be so I've pulled some pictures from places that I've traveled that have a big impact on the way I think about the natural environment and about climate. So I've been lucky enough to do a bunch of trips in the high Arctic. I had a neighbor growing up who traveled in the Fox Basin in the 1930s and knew lots of Inuit people around Igloolik, where I've also traveled. And then I've done some long kind of me and a couple friends pulling sledges ski trips. So this was the middle of a 3-week ski trip that I did about 8 or 10 years ago in North Baffin Island. And the pictures are just backgrounds. So I actually wanted to start by helping us think about the context of why the climate problem is so hard, by urging you to think about the fact that we made great progress, as I mentioned earlier today, on a bunch of other environmental topics, and we did it fast. And I want to just illustrate for you really quickly how fast we did it, and then hopefully you'll start puzzling about why climate has been different. So I've got 3 examples. I will not go through the text in details. I just want to kind of throw them up at you. So I think photochemical smog is the most amazing. This is the ozone in the lower air that comes from pollutants that causes our lungs to be damaged, causes the plastics in our cars to be damaged. And it's actually a total chemical surprise. It's like the opposite of what should happen in the textbook. You add some hydrocarbons to oxidants, and you end up with more oxidants, which is not what high school chemistry tells you should happen. And the gap between the kind of first theoretical understanding of what was going on in this smog in Los Angeles, this photochemical smog. And the first rules, hard law, not like a recommendation, not happy green companies working together, a rule, the positive crankcase ventilator, is like less than a decade. It's really stunning. And after that, things move really fast. You get the core California authority, which of course the Trump administration is now challenging, to regulate independently. And in many respects, I think it's fair to say California's regulation of automobile ended up leading the world's regulation of automobile almost step by step. It's a stunning story and very fast between science and policy action. Second one to bring up is DDT. It was also somewhat a surprise. DDT was actually an amazingly safe chemical in some ways. It had low toxicity and specificity in ways that we wanted, but it had this way that it accumulated in food chains. Actually, not DDT itself so much as but breakdown products like DDE. And again, the gap between the science that really began to understand what was going on and regulation was small. In this case, this is personal. My father was one of the scientists in the middle of this. As a kid, I was involved in collecting eggshells and peregrine falcon reproduction and so on. And the pace was amazingly quick. My dad was hired into Environment Canada as an early scientist to do toxic, and it was just a couple years before he talked his way really to near the top of the government to get them to just begin what became a complete ban on agricultural use of these chemicals. It was extraordinary. Stratospheric ozone, which is a global pollutant just like carbon dioxide. That is, it makes absolutely no difference where you release the chlorofluorocarbons. Again, pretty quick once we established the core understanding. And there's lots of structure of this agreement that was like what we thought might happen for climate, in the sense that this thing you see in '85, the Vienna Convention, was kind of like what the Framework Convention was meant to be. And then Kyoto was meant to be an analog to Montreal, except obviously it didn't come out that way. And I think it's really worth trying to understand why not. Because in thinking about why we've made so little progress on climate, and this is yet another New York Times story on climate. You're all bored with New York Times stories on climate, but this one's from 1953, and it reports like kind of amazing research from the Air Force Geophysical Lab with this guy, Gilbert Plass, who was able to make accurate calculations for really the first time of the radiative transfer in the atmosphere, which is one of the things you need to make quantitative estimates of how much it will warm. That's a long time ago. And at some level, the actions we're taking now are still, they're beyond symbolic, as I'll show you in a minute, but they're far short of the actions that we need to really deal with this problem. And I think it's worth really taking a little bit of time to think about what's different. And the obvious answer for why it's been so hard to make progress on climate is that there's money in politics, money from people who will lose under regulations, money from big fossil that has blocked action. And that is certainly true. I've been up to it, in front of that face to face. But that is not a sufficient explanation, because that was true for all the other cases in different ways. And I think it's worth thinking hard about what's different about this case. Partly it's that the benefits are far in the future, but that was mostly true of ozone. Partly it's the global nature. It's some combination of those things. It also may be changing political world. It's partly the costs of the emissions cuts are fundamentally higher. Hard to know, and worth discussing in questions. Now I want to just say a little bit more about where we are right now for climate. I've told you some stuff that sounds like bad news, but let me tell you something that's good news. And it's kind of refreshing, because it's a case where I was really wrong. I was quite skeptical about how cheap solar energy would be. I published some papers in the 10 years ago estimating that it would take decades to get solar power down to 30 cents a watt module cost, and now it's here now. This is just an example. It's one of the biggest solar plants in the world. It's over 2 gigawatts in North India and Rajasthan. I find that just stunning. I've been involved in energy and climate for a long time, and the sudden decrease in the cost of large-scale solar power is the single most important thing that I've seen over the whole time I've worked here. And I think it doesn't magically decarbonize the world. There are all sorts of reasons why it's actually hard to go from there to really deep decarbonization, but it is essential to deep decarbonization, and it was unexpected, and it is fantastic. So there's a single piece of really good news. It's that. It's the extraordinarily low costs and high capacity factors of big modern industrial solar PV. It is just amazing and really unexpected. And then let me tell you one last one that's slightly more depressing, I think. So this is, I think, one of the most important graphs that we should show in climate, but often don't enough. It's the flow of money. Because in the end, if you want to decarbonize the energy system, you want to replace the high-emitting capital stock with low-emitting capital stock. And that requires a flow of money. Obviously, you've got to politically argue about who's paying the money and who's making the decisions. That's what does it. But in the end, it's a flow of money into capital stock that actually decarbonizes the energy system. And this is Bloomberg New Energy Finance's estimate of those money flows. And you'll see that from 2005 to 2009 or something, they grew suddenly to, this is billions a quarter, but in billions a year, it's about 300 billion a year, which is getting to be interesting. But it's about 3 or 4 times lower than it would need to be globally if you were really going to be driving emissions down fast. And I think the really sad thing is it's plateaued. It's bouncing up and down, but basically since about the last decade, it's been kind of stuck at about 300 billion a year. That's a lot more than nothing. So I used to say that we were just taking symbolic actions on climate. That's not true anymore. We are doing real work. There really is a growth of wind and solar that is non-trivial, but it's far short of what we need to drive emissions down steeply. And the gap between the kind of ambition of IPCC reports and the industrial reality on the ground is huge. So let me now start, and I'll come back to this graph in different ways several times during this talk. Let me give you a sense of how the different instruments I talked about, leaving aside adaptation, because it doesn't fit in this structure, how they fit together over time. So first of all, these are deliberately done without numbers, because I want to get you to think just about the interrelationships of things. First of all, if we just emitted fossil fuels forever, the climate problem just keeps getting worse and worse. And that's because, as I'm sure you've already heard, climate risk is proportional to cumulative emissions, to the total amount we've emitted over all history before now. And in fact, it's pretty close to linearly proportional to that if you think about climate risks over the next century. So the consequence of that is when we bring emissions to zero, which we will do, and we'll have global celebrations on the day we do it, and I think it's reasonable to think about doing that soon after 2050. But when we do that, what we do is we basically stop the problem getting worse. We don't make it better, we stop it getting worse. And I think that's important. I think it's important actually in larger politics of it, and it's importantly different from some other problems that I talked about. So if you think about air pollution, which right now you could argue is still a more pressing direct human environmental consequence than climate change in total. We kill several million people a year globally from fine particulate air pollution. That particulate lasts in the atmosphere for just about a week. Whereas the climate impact of CO2, on political terms, think about it as being forever. It actually is quite a few different time scales, so you can't choose one exponential time scale, but on a time scale of 100 years, you should think about it as a one-way ratchet. You put CO2 in the atmosphere, and proportionally the climate risks and global average temperatures go up. That's a really crucial fact to know. And so as much as people keep talking about the idea that when we've solved the problem by cutting emissions, you gotta remember, that's an unusual definition of solved. So it's clearly possible, it is possible to remove carbon dioxide from the air by lots of different pathways. I'll give you some taste of a few of them. So one of them is this thing called direct air capture that this company I founded is one of the active players in. So it would be a combination of direct air capture and then injecting CO2 underground. You could do biomass, that is biofuels, burned in a power plant and put that CO2 underground, same effect. You could add alkalinity to the ocean. There's a bunch of things like that you can do. All of them have very little sort of total flow of actual money. All of them have very little real engineering going on compared to the scale of the energy system. And yet currently, this broad topic of carbon removal is very visible and getting a lot of hype in the climate world. And people seem to think it's a way to kind of get us out of our near-term requirement to cut emissions. And I think that's a trap. I think it's a classic example of moral hazard. And to say it clearly, I think the moral hazard now posed by carbon removal is in fact bigger than the moral hazard posed by solar geoengineering. The reason is solar geoengineering feels so fearsome that I think it doesn't in practice pose that kind of moral hazard. But carbon removal does. This is not, I'm not in any way criticizing the fact that it might be something humans want to do in the long run. I personally would vote to do it. But in the near term, in general, over the whole energy system, it is cheaper to avoid emitting than to emit a ton and recapture it. And that's going to be true for a long time. Maybe you don't quite get to zero. Maybe once you cut emissions below half or towards 2/3 from business as usual, then those final emissions can be very expensive, and it might then be that carbon removal is the cheapest thing to do for some of them. And to be clear, there are other technologies like direct air capture that can be used to make artificial fuels from sunlight, that actually isn't carbon removal at all. It's just another way to decarbonize the energy system. But a central thing about carbon removal is it is going to be slow. You have to deal with all the billions of tons of carbon that we put into the atmosphere. I think there's no way that it's a kind of magic get out of jail quick card. It's inherently slow moving. And I think most of the real large scale application of carbon removal happens mostly after we brought emissions, maybe not to zero, but down to a fraction of what they are now. And both politically and in terms of effort, the big effort is between us and getting to that point where we've made those big emissions reductions. After that, we can talk about how much carbon removal we're going to do. But the idea that carbon removal is a way to keep us under 1.5 degrees, I think is a kind of odd fantasy in a way that's come out of the structure of the way the IPCC 1.5 report and the previous report was handled. But I don't think it's really based on a kind of realistic understanding of how much hardware would get built, who would build it. People often think it's somehow easier than cutting emissions, but that's a false understanding, because the hard part about cutting emissions is the political battle about who pays, and that political battle about who pays will be just as real for carbon removal. To be clear, I'm totally happy to have some early plants. I'm thrilled that my company might get to build one. It'll help to, buy down the understanding in the long run, but I don't think we should look at it as a way to avoid emissions cuts. So that's carbon removal. In principle, solar geoengineering, this idea that we deliberately add something to the atmosphere or change the atmosphere in some way to reduce the energy imbalance of the Earth, could be used to flatten the top, to flatten the top certainly of global temperatures and maybe of climate risk, but that's what we can talk about afterwards. But now I want to move. This is the IPCC slides on carbon removal, which shows you these extraordinary sharp reductions that you need to meet 1.5, and underlying those in energy system models, you have an extraordinary large amount of carbon removal starting in the next decade. And I think when you think realistically about how that would actually happen, I think there's a way in which there's a kind of academic analysis that's not grounded on realistic understanding of the way hardware would actually get built. So let me make sure I'm in the right place. No. Now I want to stop for a second and talk carbon and really start talking more seriously about solar geoengineering. Sorry about that. So before I get into detail, I think I want to say the core idea is certainly the idea of deliberately altering something about the Earth's radiative balance to reduce some of the risks of accumulated carbon dioxide. I think the best statement you could make is that a combination of emissions cuts and solar geoengineering might have lower risk than emissions cuts alone. I don't think we know that it does, and I think it's clear in the way I said that you have to do the emissions cuts, but it's possible that a combination offers a lower risk pathway than just doing emissions cuts. I'll give you a sense of the kinds of technologies we're talking about. In this talk, I don't want to kind of go into detail in them, but I'll give you some rough sense. There's a big range of potential technologies. I think the things that are most certain to work, where work doesn't mean work to reduce risks in a way that's useful, we'll get there in a second, but work means at a minimum to change the global average radiative balance and change the global average temperature, are the ideas of adding aerosols to the stratosphere. I think there's now some real basis for confidence that that could be done in a way that was relatively uniform, in the sense that pole to equator distribution could be relatively uniform. And I think there's a good basis for understanding something about physically how to do it. So I think one important thing to say about it, which you can look at as much as it being a bug as a feature, is that it looks like it's very cheap to do. So just the raw technical ability to put aerosols in the stratosphere people have done this analysis several different ways, and it's clear that it's cheap enough that the cost is not likely to be a big part of the decision to use it in a kind of cost-benefit sense, in the sense that it's sort of hundreds or thousands of times cheaper in direct cost than other things we talk about doing. But that really says it's all a risk decision. There's risks of doing it and there's risks of not doing it. And in fact, one of the things that cheapness implies is at least theoretically the possibility of kind of unilateral action by small states. So basically the original ideas are mostly around stratospheric sulfates. These are just fine aerosols, droplets. You might say, why sulfuric acid? A fine droplet of water in the stratosphere scatters sunlight back to space basically just as well as a droplet of sulfuric acid, but the stratosphere is very dry, and a droplet of water would evaporate almost instantly. Whereas a droplet of concentrated sulfuric acid, the acid is basically there to keep the water from evaporating, is the way I think about it. And there's a bunch of other things you might use as stratospheric aerosols. My group has looked a little bit at calcium carbonate and a bunch of other alternatives. There's ideas for altering marine clouds or cirrus clouds, and there's ideas for doing this in space. Some of these ideas are old and they're getting some level of new look. I think an important thing to know is about timescale and about regionality. So the stratospheric methods basically inherently last for a couple years, and you can look at that as good or bad. That's an objective fact that they last for a couple years. So that means that sudden changes take a few years to be felt, and it means that you don't get a kind of instant impact of anything that any change you'd make. Marine clouds and cirrus have timescales of half a day, and that means that if you actually did build a system that was doing this at large scale with marine clouds or cirrus, it means that if that system suddenly stops, you have a huge impact right away. It means you have potentially some of the power to do weather control, which I think could be clearly weaponized in different ways. And space-based depends on which method. It can either be fast or slow. So I want to try and get at the kind of question I've been hinting at, and the core of what I want to say in a way, is the big question, one of the big questions about solar geoengineering is could it in a physical sense reduce climate risks? And for right now, I want to hold the kind of central political question and central concern about how it might end up increasing risks. But let me just say it and then leave it out there. I think one central reason why this topic has been really subject to a sort of taboo, why there's been so little research, has been a fear, I think an entirely reasonable fear, that some opponents of action on climate change, like big fossil fuels, will use it as an excuse to argue against action. They'll say, well, the possibility they will work means we don't really need to cut emissions, or it does work and therefore we don't need to cut emissions. None of those statements can actually be true, but I think that they will be used. And so I think the fear is that it provides potentially a kind of weapon in the political battle. And I think that's been one of the reasons why historically some of the big environmental groups have been very reluctant to see research on this. This is changing, actually changing quite quickly now. We can talk about it in the Q&A. But I think that's important to say. That's, I think I was the first to call out the moral hazard of this topic. It's not quite clear that moral hazard is exactly the right way to think about that. I see it as more a political threat, a political mitigation threat, but it's central to the politics. But now let me focus more just on the physical risks, or actually in the kind of language of the IPCC, the hazards, the natural hazards, which is a step before risks, the changes in the physical system. So can solar geoengineering reduce these climate risks or hazards? So there is no answer. The answer inherently depends on decisions about what solar geoengineering is, on decisions we make. There's no general objective answer to that because it's not like a thing out there in nature. This is an engineering idea on its way, maybe or maybe not, to becoming something that actually ends up getting deployed. And the choices, the social choices that are made along the way will inform that answer. So most importantly, it depends on the method used, that is marine clouds or cirrus or stratospheric aerosol, on the spatial distribution of materials and the resulting radiative forcing, as is it even around the world, or is it just in one hemisphere? Those are hugely different answers. So for example, there's been some papers showing horrifically terrible impacts of solar geoengineering that show that there would be terrifically horrible impacts if you did it only in one hemisphere. In fact, you hardly need to have a paper to do that. You can also show that if you did it at, say, 10% of total sunlight input, you could freeze the whole planet. There are all sorts of ways you could have horrific impacts. That's common for all sorts of potentially useful technologies, indeed maybe all of them in some ways. But what the impacts actually are depends crucially on what decisions are made. So on the method, on the spatial distribution, and maybe most of all on the magnitude. So are we using solar geoengineering? Does it get used to return the Earth to pre-industrial temperatures, to hold temperatures fixed, or to hold precipitation fixed? So for example, Gabby Hergel mentioned concerns about reduced precipitation, which are very reasonable concerns, but that's a choice. A very reasonable way, and the way that I think I might advocate to think about solar geoengineering would be to use it to hold precip rates or the hydrological cycle roughly constant, allowing temperature to increase slowly. There's a bunch of different ways to think about this, and those are design choices. They're not forced in. And nobody owns the definition of what solar geoengineering is. So you can divide this question further into, I think, two useful sub-questions. One is, sorry, I've got myself confused here for a second. So I'm going to propose a scenario which I think is at least less crazy than some, but I'm making no claim that it's an optimal scenario or, well, that's optimal, that it's in any way perfect. And the scenario is that you would deploy some method of solar geoengineering that had spatially uniform radiative forcing. Radiative forcing is the climate scientist measure of how hard we're pushing the climate system. Spatially uniform meaning uniform pole to equator, uniform east to west. Obviously, I'm not saying precisely uniform. There's a bunch of asterisks. We can argue about exactly how uniform it has to be. And moderate meaning that it's done not to return temperatures to pre-industrial, but it's done as a supplement to emissions mitigation to reduce, say, the rate of change of radiative forcing or reduce the peak radiative forcing. So with that scenario, then you still have two choices, or two kind of sub-questions. One sub-question is, if you could do that, how much would this scenario reduce important climate hazards? How equitably are the regions that see increased risks? And the tools for answering that are mostly climate models and historical analogs. And then the second set of questions are, is it feasible technically, and there's a whole separate set of questions about politically, is it feasible technically to engineer a radiative forcing like that? What are the side effects? What are the costs? How controllable is it? And that's a complicated multidisciplinary study that involves knowledge of stratospheric circulations, involves understanding some aircraft engineering, aerosols, a complicated multidisciplinary application of engineering and science we mostly already know to a new problem. So I'll tackle the question one first, and I'm going to argue that evidence is in fact quite strong that a scenario like that with even radiative forcing used to cut total change in radiative forcing roughly in half would reduce hazards significantly. So for example, it would reduce regional changes in water availability, not just the global average, but on a regional basis, it would tend to bring almost all regions back towards the pre-industrial with respect to water availability. It would reduce extreme precipitation in the same sense. It would reduce the intensity of tropical cyclones quite strongly. It would reduce extreme temperatures also in this kind of regional sense. Now I'll show you some of the basis for that. This is the one kind of complicated figure I want to show you, but first I want to tell you how we got to that figure. So this happens to be work that I did, but it turns out that it's kind of the same as work a bunch of other people did too, so I don't feel bad about showing my own stuff. This came out of a collaboration with the Geophysical Fluid Dynamics Lab at Princeton, where they have a model that is one of the highest resolution climate models around that turns out to do just a great job on tropical cyclones. And I was involved in the Fortran of climate models back in the early 90s, and at that point, the idea that they would just actually generate tropical cyclones out of the model physics correctly, and it's amazingly correct. This graph you see on the left-hand side shows you how well the distribution of cyclone intensity matches real observations. And it used to be we had to put in kind of like a hand little Fortran subprogram to pretend to be a tropical cyclone, but now it's just coming out of the model physics, which I think is something really profound about the way these models are beginning to capture more of the reality about the way the circulation in the atmosphere works. Lots of uncertainty still, as Gabby said very well, but I think it shows you there's something really, some real skill in what these models can predict. So this group had never tried working on solar geoengineering before. We encouraged them to work with this. We brought in a guy called Kerry Emanuel, who's a great expert on tropical cyclones, because there was some uncertainty about thinking through that part of it. We ran this very high-resolution model for the first time ever on solar geoengineering, and then we did a slightly more careful look than people have done before at the statistics of the results. So what we did is for each location in space, we would estimate whether in a statistically significant sense that region was moved, we said, moderated or exacerbated. We were careful not to say better or worse because it's actually not so clear, but where moderated means that its climate for that variable is moved closer to the pre-industrial by adding solar geoengineering, and exacerbated means farther from the pre-industrial by adding some solar geoengineering. In general, you assume exacerbated is bad. And also, a lot of previous studies had looked just at temperature and precip, but that's kind of can fool you because in a world that's hotter, you have both more precip and also more evaporation. And what lots of ecosystems and farmers want is water availability, which is actually precip minus evaporation. And so they care about that. And extreme precip is actually can be a climate hazard. So we looked at temperature, which is obvious. We looked at temperature extremes, which are very important for human impact. So the hottest hour of the year. We looked at PE is water availability, precip minus evaporation. We looked at extreme precip, the max 5-day, which is pretty important. And then we had different ways that we could bin them, but we decided to bin them in the standard way the IPCC does, binning meaning the areas we averaged. So we averaged them in these IPCC SREX regions, they're called. I'll show you them in a second. And then they're color-coded as follows. And the punchline is simply that there's no bright red symbol there. So in none of the regions are any of the variables statistically significantly moved to be exacerbated. So this may not be true in reality. But if there is a reason to take solar geoengineering seriously as something that might be able to produce a substantial reduction in human suffering and in environmental impacts, not this finding alone, but findings like this are it. And if there's a reason to question some of the assumptions about how unequal this would be, it's findings like this that are it. Because what this shows is that no region in this particular analysis is left worse off. This is with turn down the sun solar geoengineering, but we've already replicated this with a version with sulfur in the model. It's quite stunning. My guess is that it's too good to be true, but I can't find it. And I think the big challenge for this community, the community working on solar geoengineering, is to think really hard about all the ways we could be fooling ourselves. I think groupthink is our biggest enemy. It reduces sea level rise, that's pretty easy. It also reduces carbon concentrations slightly and ocean acidification. I'll tell you about that because it's surprising and opposite to what many people think. So this is kind of basic climate science. Carbon emissions drive more carbon in the atmosphere. More carbon in the atmosphere makes it warmer. Warmer means there's less carbon absorbed by the oceans and more released by, say, permafrost and other systems like that. And then there's a feedback. That's well understood, been understood for decades. But of course, a consequence of that is if you compare two worlds with the same human emissions of CO2, and one world has less of those feedbacks because it has some solar geoengineering, the world with less of those feedbacks has a little less carbon accumulated at the end of the century. So in a world where you do solar geoengineering and you keep emissions the same, which of course politically you might not, that's the big issue, you would actually have a little lower carbon concentrations end of century. Doesn't solve the fundamental fact that if you want to manage carbon concentrations, you have to bring emissions to zero, but it helps around the edges. And of course, global temperatures. So why should you have any faith in any of this? Lots of yada yada, multi-models, GeoMIP, whatever. But I think the strongest evidence is that the following. It's now been 19 years since the first good quality, first paper to apply a climate model to solar geoengineering. A paper that, actually the person who did it, Ken Caldera, his bias was to show that solar geoengineering didn't work. And the found, at least the first level of this paper 19 years ago, the opposite. And that's a lot of time, and people have looked hard at a lot of these risks. For a lot of the obvious risks that we care about now, for ozone or air pollution or these inequality risks, a whole bunch of them, there are now a fair literature, sort of 500 papers total. And I think the evidence that these technologies might actually enable a real reduction of risks is growing. And you can't actually point to papers which examine this kind of moderate and uniform, moderate meaning roughly halving the radiative forcing, and uniform case. You can't point to papers which do that and find really huge risks. And I think that's true. The fact that that's true, and true given the fact that many people in the community, I think, were looking for problems, which was the right thing to be doing, gives me some confidence there's something real there. I'm going to skip over the question of whether or not we can engineer radiative forcing. Happy to answer questions of that, but I'm going a little slow because I want to make sure I say the final closing better. Sorry, I'm a little still recovering from the flu and going slow. Just, I guess I'd summarize by saying we certainly cannot say with confidence that it's possible to produce a moderate distribution of aerosols in the stratosphere at, say, a watt or 2 per square meter with relatively low environmental impacts. But I think there's reasons to believe that that is not implausible. So these are some pictures from Igloolik in the mid 80s. And in closing, I want to say the big debate about solar geoengineering that we, I think, should be having, that effectively is beginning, is not about whether or not to do it, because that's not a decision our generation's making in reality. That decision will get made in decades. The real hard decision is, should there be a real research program? Right now there's been a sort of taboo where people have not wanted to think about it. And my argument is that we should really bring this thing out into the open. Sunlight is the best disinfectant. We should have an active, really international research program. We should have one that consciously funds some people to focus on finding what the problems are, to try and break down the groupthink, one that's much more diverse than the current research program, which is just tiny, one that amounts to being several percent of kind of global climate research and kind of embedded into the global climate research program. And the goal is to provide our kids with better basis to make decisions about these technologies. And it's important to say that if some of you think that that you have some reason why you're just sure that these technologies are really a terrible idea and shouldn't be done, that it's not your decision or mine. And we can't bind our children's hands. We can't pass a binding rule that forces them never, ever, 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 ever to look at this thing. In fact, I think about it this way. I think the probability that some nations, probably poorer nations, will be facing, say after a big heat wave, real decisions about implementing these technologies within the next, say, 3 decades is pretty high. And if we choose to have a research program, we can at least give them more information about what the consequences might be, about some ways to do it that are a little less risky or a little more risky, about how to monitor it, about how to measure it, about how to compensate. If we have no research program, which has sort of been the current default, that doesn't prevent them making a decision to do it, because the underlying ability to do it is essentially here now. If we have no research program, what it does is mean that people make decisions in ignorance. And my view is that we should get this thing out of the shadows and have a real research program so we can have a debate about how it fits into the larger choices we make about climate. Thank you.
Thank you to Marnie Dunning, who's been running the polls. She'll put up one right now while we change speakers. I want to make sure we maximize our time for our final discussion when we have a lot of work to do. So let us turn to our final presenter, and to introduce him, I invite my colleague Sam Kessler, Assistant Professor of Religion and the Bonnier Chair of Jewish Studies, to introduce him.
Hello everyone, you've almost made it. Day 2. It's very exciting. This has been wonderful. For Dr. Mike Hulme, Professor of Human Geography and Fellow of Pembroke College at the University of Cambridge, climate change is not only a phenomenon happening on the surface of the Earth, it is also a global cultural experience eliciting artistic, musical, novelistic, and spiritual responses alongside economic, political, and engineering ones. As he has written, quote, "Rather than framing climate as an interconnected global physical system or as a statistical artifact of weather measurements, climate needs to be understood equally as an idea that takes shape in cultures and can therefore be changed by cultures," end quote. In the past decade, Dr. Hulme has emerged as a clarion voice from the scientific world about the enduring importance of religion, literature, and art in creating a future for humanity in a world of radical environmental shifts. Dr. Hulme received his doctorate from the University of Wales, Swansea. From 2000 to 2007, he was the founding director of the Tyndall Center for Climate Research at the University of East Anglia, at the end of which he was recognized for his, quote, "significant contributions to the work of the United Nations Intergovernmental Panel on Climate Change," the IPCC, about which we have heard so much these past few days. And since 2017, he has been a professor at the University of Cambridge. Please welcome as our final speaker of Nobel 55, Dr. Mike Hulme.
Thank you very much, Sam, and thank you to you all for being here and sticking with us. I'm bringing up the tail this afternoon, and I'm looking forward to sharing my thoughts with you on climate change. Let me also just thank the 3 wonderful women who've organized this, as far as I'm concerned, in the way the interactions I've had with Barb, Anna, and Lisa. You've made everything run very smoothly for me, so thank you very much indeed, and also for my student hosts, Ted, Shauna, and Lisa, for taking care of me over these last 2 days. So in a book published last year called In the Year of Our Lord, 1943, Christian Humanism in an Age of Crisis, Alan Jacobs, the distinguished professor of humanities at Baylor University, Texas, reflected on a powerful current of thought centered on the war year of 1943, which sought to establish the basis for creating a new and better world from the ashes of what was then becoming clear would be an Allied victory. Through examining the work of 5 Christian intellectuals from that era, W.H. Auden, C.S. Lewis, T.H. Eliot, Simone Weil, and Jacques Maritain, Jacobs consolidated their argument that Western societies were neither culturally nor morally prepared for victory against fascism. These thinkers worried that a war won merely by technological superiority laid the ground for a post-war society to be governed by technocrats. This was not their vision of a better or more humane world. For them, it was more important to, quote, as Jacobs put it, train the emotional responses before training the rational ones. And following St. Augustine, to seek the ordo amoris, the order of love, as the more appropriate sensibility. So in this talk, I want to develop a similar argument in relation to how the contemporary world deals with not in this case the crisis of war, but the crisis of climate change. Mere climate solutionism, whether technical, economic, political, is not sufficient if it leaves our cultural, moral, and spiritual senses still buried or else unmoved. My argument in a nutshell is as follows. Climate change is not a problem like mercury pollution of rivers or asbestos in buildings. It's rather a symptom of the rapid expansion of human numbers, technologies, and material transformations that have occurred over the past 2 centuries. Just as humanity has irrevocably embedded itself in the physical workings of the planet and transformed the land and ocean, our own and other people's bodies, and those of non-human species, so too we're now transforming the climate. This new condition is partly what is meant by the notion of the Anthropocene. We should not therefore think of climate change as a problem that can be solved. We cannot reverse engineer our way back out of such deep entanglement. Suggesting what solving climate change would look like is just as hard as suggesting what solving the human genome would look like, or solving democracy, or solving the Anthropocene. Rather, we should use the realities of climate change to think and act more profoundly and carefully about what it is to be human, about the nature and quality of our relationships with the material world, and about the goals of our political life together. This implies to me that we resist thinking of climate change purely in scientific categories, the future only in terms of climate, and climate governance solely in terms of carbon metrics. Governing climate change through carbon metrics is a form of moral attenuation. Metrics are alluring because they simplify complex realities into objective numbers, and because they appear to short-circuit the need for difficult moral judgment. But they mask the contested politics and diverse values that lie behind different personal and collective preferences. Who wins, who loses, whose values count. To quote Habermas, we need an awareness of what is missing. Wise governance of climate emerges best when rooted in larger and thicker stories about human identity, purpose, duty, and responsibility. It is these alternative forms of moral reasoning that are better suited to the ethical challenges of climate change. So let me now expand this argument in the rest of my talk. The belief that climate change could be solved can be traced back to its emergence in public life in the 1970s and the 1980s as the latest in the line of environmental challenges facing the modern world. These challenges had grown in scale from the merely local to the regional and then to the global. Climate change was in a line which followed from Rachel Carson's intervention in the early 1960s about DDT and chemical pesticides in her book Silent Spring, and which then progressed through concerns about river and ocean pollution, smog, acid rain, the ozone hole, and eventually in the late 1980s to the fully developed awareness of the challenge of global climate change. David Keith has alluded to some of these earlier examples already. Although inheriting this problem-solution framing, what solving climate change actually meant has always been harder to establish. It's not as simple as eradicating DDT, installing sulfur scrubbers on power stations, or eradicating CFCs in industrial productions. The original universal formulation in the 1992 Framework Convention on Climate Change from the UN was to, quote, stop dangerous interference in the climate system by stabilizing atmospheric concentration of greenhouse gases. This rather vague ambition gradually transformed into ever more reductionist goals defined by precise numbers. Initially arresting global warming at 2 degrees above pre-industrial, now is seemingly at 1.5 degrees, now delivering net zero emissions by a certain date, Or, for example, in 350.org's goal from a decade ago, reverting concentrations of CO2 back to 350 parts per million in the atmosphere. I believe the modernist instinct for control revealed by these numbers, what James C. Scott calls seeing like a state, and Ulrich Beck referred to as reflexive modernization, is reading humanity's increasing interpenetration of the non-human world in the wrong way. Seeking merely to hit the numbers, whichever ones you choose, is not enough. It encourages the type of climate solutionism of which I'm critical, and it fuels what I've called climate reductionism and climate deadlineism. Closed timetables and preordained options constrain the diverse moral horizons that characterize and complicate the difficult politics of climate change. It is exactly what Jacobs' intellectuals from the early 1940s worried about, that mere technique and technology would crowd out wider explorations of moral meaning and purpose. Carbon metrics, after all, are only a proxy for global temperature, which is only a proxy for regional weather, which is only a proxy for human well-being, which in fact depends on innumerable other factors for its achievement and maintenance. Even the Sustainable Development Goals, on which I'll say a little more later, are only a proxy for full human flourishing. As my colleagues Amanda Macon and Alexander Russo have recently argued, quote, emblematic numbers and the production of political thresholds, targets, and truths will not settle out or settle down the political disputes over climate change. The reliance upon emblematic numbers may ignite a sense of urgency, but it may also fuel the suspicion of politicians, scientists, and climate change policy. So to think through this a little more, we need to take a quick survey of the meta-disciplines of human inquiry: the natural sciences, the engineering sciences, the social sciences, and the humanities. How climate change is understood, how a problem-solution frame becomes established, determines the ways in which different academic disciplines are mobilized and valorized in relation to it. This is both with regard to the forms of knowledge deemed to best describe what is happening to the physical world because of climate change, and to those knowledges believed to offer the most useful insights and suggestions as to what should be done. Thus, the sciences are mobilized to explain the physical world and to predict its future, on the assumption that ever better predictions of the climate future are a key to enable and design apt solutions in the present. Yet science is fundamentally inquisitive in nature, asking how does the world work? What effect does this intervention or that intervention have on the physical functions? At its heart, scientific inquiry is curiosity-driven, not solution-oriented. It certainly is not normative or didactic. But as this front page headline from the Guardian newspaper after the fourth assessment report of the IPCC reveals, many commentators still seem to think that science, at least undisputed science, if it's that, contains magical powers to unlock political deadlock. Then there are technology-oriented disciplines, various forms of engineering, for example, civil, mechanical, electronic, energy, biomedical, biochemical, genetic, and so on. These are mobilized to develop specific and tangible solutions to society's problems. These engineering disciplines lead to a proliferation of proposed solutions for climate change, ranging from, as we've just heard, direct air capture of CO2, solar climate engineering, nuclear fusion, GMOs, genetic modification of organisms, diet modification, human redesign. But we need to remember that technologies do not merely solve problems. They are also generative of new worlds in ways that are usually unpredicted and unpredictable. Technologies are world-changing in their own right, and frequently yield future further problems and challenges, which subsequent generations will then have to confront, as indeed with climate change itself, a result of the coal-fired steam engine or the internal combustion engine, which seemed pretty good ideas at the time. And then there are the social sciences, which are mobilized to inquire into the dynamics of social, behavioral, and political change that might offer themselves up as solutions to climate change. Thus, we have social technologies for altering cultural norms and behaviors, such as nudge theory, far-reaching economic interventions around taxes and fiscal policies, entirely new sub or transnational institutional configurations for governing the world, or else social theories for creating radically different political economies. So these meta-research domains and enterprises are of great value. I don't deny this for a minute. I work in a university, after all. But the problem with mobilizing these academic disciplines to seek out solutions to climate change is that as solutions, they will always fail. Climate change is a wicked problem, meaning a problem that has no definitive formulation and no imaginable solution. Wicked problems are insoluble in the sense that solutions to one aspect of the problem reveal or create other, even more complex problems, which in turn demand further solutions. In contrast, for example, as David has just alluded to, the ozone hole, stratospheric ozone depletion, was a relatively tame problem. Proposed solutions to climate change can only ever be partial. They set in train secondary, tertiary consequences, which will always exceed that which humans will be able to anticipate. So, for example, we have seen some of the perverse outcomes of various climate policies already. Amongst others, for example, promotions of biofuels, the Clean Development Mechanism, carbon taxes, nuclear energy, planting forests, solar PV feed-in tariffs, and so on. We live in a Kafkaesque world of bizarre, convoluted, and impersonal situations where individuals, as too do political authorities, find themselves in seemingly powerless to understand or to control what is happening. Just ask Mark Zuckerberg or the British government right now. But I haven't mentioned yet the humanities. Mobilizing the humanities disciplines would appear to offer something different. When knowledge from the humanities is applied to solving climate change, then the outcomes look and feel very different. The humanities have evolved over millennia as ways of reflecting on the material and imaginative human experience of the world. Together with the creative arts inspired by the mysteries of the human imagination, the humanities disciplines interrogate the meaning, purpose, and significance of human and non-human life. They are used to train and cultivate a range of human reflexes, emotions, sensibilities, and motives that construct worlds that make sense to us and that guide our actions within such worlds. Humanities disciplines are able to engage and explain the multitude of stories and myths that people create to help in this process of orientation. As my Cambridge colleague Sarah Dillon explains, quote, attention to the stories that circulate in different social groups, both the dominant and the marginalized, can reveal diverse, even conflicting, social values and norms, thereby providing a more complex picture of society's coherence or lack thereof, end of quote. So, for me, inspired by work in the humanities, in philosophy, ethics, eco-criticism, religious studies, anthropology, I've concluded that a well-ordered physical climate is deeply contingent upon a well-ordered social world. But of course, many people got there well before I did. Many traditional societies have long recognized this, and still do. Their material, social, spiritual, and ethical worlds are deeply interdependent. A state of existence we might describe as a moral ecology. Disturb any one element of these relational webs, and the other elements feel the disturbance. And we see this understanding around the world, this understanding of climate change in widely scattered cultures, in the Andes, the Himalaya, the Pacific Islands, in the Arctic, in the Congolese and the Amazonian forests. Such a reading of climate change makes clear that it is not merely some technical or engineering maneuver or intervention that is needed to redeem or restore the climate. It demands a reordering of everything, of all human, social, material, and spiritual relations. As the novelist Margaret Atwood has suggested, quote, "I think calling it climate change is rather limiting. I would call it everything change." But, and this is an important but, on the other hand, there are no authoritative, universal prescriptions of what form this reordering should take. From my earlier argument, we do know that climate science, and therefore the IPCC, is inadequate for this purpose. Science has no normative authority to instruct our moral behavior. And merely hitting the numbers, as I call it, through engineering solutions is blind to the collateral damage that is usually caused along the way. So if science and technology cannot redirect or cannot direct this reorientation, then what can? What are the wider resources beyond science, the motivational moral commitments that Habermas refers to as missing in secularist societies, that can enact and guide such change? In what follows, I suggest 5 ideologies, let me call them that for now, which are advocated by different actors to guide action in response to climate change. Everything change, in a sense. They differ from each other in various ways, as you'll see, sometimes profoundly. But they are similar in that each of them extends well beyond being rooted merely in the science of climate change or possessing a simple faith in technology. The first of these 5 ideologies, we might also call them myths, I group loosely under the label eco-modernism and the associated moniker of green growth. The argument here is that modernity can, so to speak, both have its cake and eat it. Yes, climate change is an outcome of rapid and penetrating technological expansion and economic and population growth, but it is through adjusting and redirecting these very great achievements of modernity towards more just and ecologically sensitive ends that climate change can be arrested. Thus, for example, the 2015 Eco-Modernist Manifesto claimed that humans need to use all their growing social, economic, and technological powers to make life better for people, stabilize the climate, and protect the natural world, end of quote. Or as Earl Ellis and others have argued, an eco-modernist stance would urge us to work hard to spare land for nature, the idea of land sparing. For them, climate change signals not the end of development, but the chance to develop better. This is the logic of green growth, as espoused in the Stern Review back in 2006 and in numerous reports since then. The proposed Green New Deal here in the US takes inspiration in part from this ideology. A second framework into which the problems of climate change might be placed is that of human rights. At its heart, this is rooted in the liberal and egalitarian instinct for the dignity and equality of all humans, given expression in the 1948 Universal Declaration on Human Rights. It has been inspirational, as indeed we've seen on the panel already, first in setting up in 2000 the Millennium Development Goals, which sought to make poverty history, and now since 2015, the Sustainable Development Goals. The SDGs comprise 17 goals and 169 associated indicators around which political action in the world is to be oriented. Included here is the goal of climate action, goal number 13, but climate action is here placed alongside 16 other goals which attend to the welfare needs and rights of all humanity. Clean water, zero hunger, affordable energy, gender equality, strong institutions, and so on. A third ideology or motivational discourse is what we might call ecological civilization. In essence, ecological civilization is seen as the final goal of social, cultural, and environmental reform within a given society. It argues that the changes to be wrought by climate change in the future can only be headed off through an entirely new form of civilization, one based centrally on ecological principles. Now, there are both techno and romantic versions of this ideology. For example, the techno version has been embedded since 2012 in the Chinese Communist Party's constitution. But the Chinese version is very different from the version of eco-civilization espoused by the deep ecologists and new cultural movements such as the Dark Mountain Project, which seek an unweaving of the core tenets of Western civilization. Nevertheless, these two versions are linked in their claims to make human civilization, to remake civilization rather, by foregrounding ecological limits as the principles for a sustainable society. My next example is an ideology for guiding political action in response to the challenges of climate change, which gives rise to, or is rooted in, a comprehensive and radical critique of capitalism. This was given clear expression in Naomi Klein's book, Climate versus Capitalism in 2014, but more recently has been articulated even more decisively by the social movement Extinction Rebellion. XR have a clear belief that the only adequate response to climate change is the overturning of the social order and the capitalist economic system. Though they may lack details of the post-capitalist social formation that they aspire to replace capitalism with, they are clear as to the real enemy of a stable and benign climate. It is capitalism, and its fetishizing of economic growth and the centralization of wealth and power that capitalism fuels. XR is rooted in the political extremism of anarchism, eco-socialism, and radical anti-capitalist environmentalism. It feeds off the powerful moral critiques of capitalism that date back a century and a half to Karl Marx. The civil resistance model espoused by XR is intended to achieve mass protest accompanied by law-breaking, leading eventually to the breakdown of democracy in the state. My fifth and final suggested ideology was given new focus in 2015 through the publication of Pope Francis's encyclical, Laudato Si, on care for our common home. Here, climate change stands in for is a synecdoche for a spiritual human emaciation, which is having adverse repercussions for the material world. Pope Francis is concerned first and foremost to offer a vision of human dignity, responsibility, and purpose, drawing upon the rich traditions of Catholic theology and ethics. Notably, the idea of virtue ethics, which is valorized above utilitarian and deontological modes of ethical reasoning. On care for our common home offers a powerful story. Concerns about technology, water, power, climate, slavery, biodiversity, human greed are woven together into an inspirational account of divine goodness and healthy human living. It escapes the confines of a narrowly drawn science and economics and shows the power, vitality, and inspiration of a Christian worldview. It also draws attention to the centrality in the Christian faith of the idea of transformation. Quote, "For this reason, the ecological crisis is also a summons to profound interior conversion, an ecological conversion, whereby the effects of their encounter with Jesus Christ become evident in their relationship with the world around them. Now, there are, of course, other ways we could group the different ideologies that shape and guide political action and social mobilization around the idea of climate change. We could certainly debate these. I'm not proposing that these 5 are by any sense definitive. For example, there are clear overlaps between eco-modernism and human rights, and between ecological civilization and post-capitalism. But my central point in the talk is this: all 5 ideologies require science and technology to be placed in a subservient role to these normative visions of how the world should be ordered, whether this ordering be around economic growth, human dignity, ecological integrity, eco-socialism, or spiritual renewal. Merely offering climate solutions is not the point. It is which solutions emerging from which visions that matters. Each of these ideologies may, and they do, mobilize science and technology in different ways, perhaps very different ways, to bolster their ambitions. But they illustrate why it's profoundly inadequate to suggest that tackling climate change is all about, quote, uniting behind the science or, quote, listening to scientists. There is no possibility that merely uniting behind the science will arrest climate change or deal with its consequences. Science on its own offers no moral vision, no ethical stance, no political architecture for the sort of world that people desire. So now as I end, let me return to my earlier contention about the inadequacy of carbon metrics for governing climate, and instead offer the value of thinking about climate change in terms of moral ecologies, and about Alan Jacobs' claim, drawn from the 1940s, about the need for cultural and moral resources to be unearthed and mobilized in a time of crisis. And let me offer just 3 very brief examples of narrative-based approaches to moral deliberation that offer something different to the moral calculus of carbon accounting. My first example is to return to Pope Francis's encyclical. Here, the encyclical places the scientific evidence for human agency over climate inside a much larger moral vision of the world. Rather than focus on metrics and the coercive regulatory logic of numbers, Pope Francis offers a cosmic account of human dignity and responsibility, within which duty, virtue, humility, and care feature prominently. This framework of moral reasoning offers an account of causation and also an orientation towards moral action in the world. A second example highlights the powerful force of metaphor in helping cultures find moral orientation. Metaphors are essential in how we relate to each other and to the non-human world. They offer a kind of imaginative creativity that humans need in order to think through the many-layered conundrums that climate change confronts us with. Metaphors gain their power and utility precisely because they rely on the ambiguity and uncertainty that carbon metrics seek to eradicate. Rather than act superficially, guided by the unyielded force of numbers, metaphors encourage us to think relationally about our place in the world and through time. Metaphors such as stewarding, healing, restoring, cultivating, repairing are each suggestive of different ways of relating to climate and to our ecological surroundings. They offer richer vocabularies to think not just about the sort of climate we bring into being, but the sort of role we see for people such as us. And my third example, from a different source, it focuses on the figure of the trickster, an archetypical mythical being found in many traditional cultures. Although not embodying a fixed moral orientation, the trickster seeks to disrupt and to transform taken for granted realities. This myth has value when thinking about climate and carbon governance, since it challenges the illusion of controllability that is promised by the carbon metrics on offer. The trickster introduces the virtues of humility, modesty, and irony into human storytelling, and suggests that the effect of human actions in the world will always exceed our ability to predict and our desire for control. So, in conclusion, governing climate change through carbon metrics for me, is another form of reductionism. It reduces the future to climate. Even more dangerously, it masks the contested politics and values diversity that lie behind different personal and collective choices. Who wins, who loses, whose values count. It's a form of moral attenuation. Metrics are alluring because they simplify complex realities into objective numbers. As Jerry Muller in his book, The Tyranny of Metrics, says, metrification may make a troubling situation more salient without making it more soluble. The circulation of ubiquitous carbon metrics operates as a facilitative and immanent mode of power. Morality by numbers also marginalizes other forms of moral reasoning, which cannot be reduced to calculation. But these latter offer richer narrative contexts that enable the wisdom of different choices to be deliberated, interpreted, and judged. Wise governance of climate, as indeed in the application of wisdom in everyday life, emerges best when rooted in larger and thicker stories about human purpose, identity, duty, and responsibility. Such stories are what traditional and religious knowledges can offer. Carbon metrics should only be used as a complement to experience and to wider modes of moral reasoning, not as a substitute. Thank you.
We have a lot to do. Marnie, would you put up one of the polls? And while people are assembling, Marnie, why don't we switch it over to the questions so people can enter questions now if they'd like.
Just got to meet.
I think we're live. Welcome. We have one final panel discussion period in which all of the questions that have come in will be answered. Okay, just kidding. They won't. There is so much that we have not done here, and we know that. And we're sorry about that, but we're doing our best. I want to say, though, I have much more faith in the power of humanity to do whatever it needs to do, because every single one of our presenters stayed within their time frame, which means we have the full time here. And I want to thank all of you for cramming a lot into a half an hour. It turns out a half an hour is not very much time. So we have a lot to talk about in this final session, and we'll focus primarily on our last two presenters, but feel free to ask more general summative questions as well.
Thank you, Drs. Keith and Hume, for your talks. Discussants, anyone would like to start with asking a question or making a comment? Dr. Liverman.
So I have a question for David. And it's hopefully straightforward. You talked about how somebody, perhaps even a smaller country, will want to try solar geoengineering. And so my question is, do you think we need an international convention on solar geoengineering, and what would it look like?
That's an easy one. The fact is, the world isn't in the mode of making new conventions at much of a rate now. That was something that we did do. If you look at the big international conventions we have, they're mostly a long way back. So there are a lot of ways to restrain things other than a convention. My happiest answer would be a strong version of the Framework Convention that builds this in with some commitment to some kind of clear voting regime and that blocks unilateralism. I'd love that. I think that's kind of implausible. But I think there are a bunch of ways in which we could get the kind of restraint that we'd like to see short of that, and that there are ways that coalitions of countries could assert both their inherent right to protect themselves this way in principle, but also say that they're going to have a moratorium, and then you can think about how that moratorium is constructed, and there's been a bunch of different ways you could think about doing that. So I think as much as a treaty might be nice, the fact is a lot of the big hard things we govern right now, we don't govern so much by treaties. We govern them not as well as I would like, but we govern them still moderately well through interactions of states, both weak and powerful. Think about the internet. So we govern the internet through partly this thing called ICANN and now its successor. And that was actually a US not-for-profit. It was a very strange entity. Now there's questions about how it migrates into the PTT regime, but none of that ended up with a new treaty, and yet the internet's a pretty important thing. So I think it's pretty hard to see we get a new treaty quickly, as much as I might like one.
Dr. Hegerl.
I really enjoyed both talks. I want to make a comment on the metricization or metricization. I personally very much welcome the carbon metrics, because I was really frustrated talking to some policymakers who seemed to for a while, there was an idea we do something about climate change, and we say we do something about climate change, and then the measures that were proposed were so tiny and would have made such a small impact that it was really frustrating to listen to, for example, energy-saving light bulbs or something. And so having the metrics helps us put a target up and say, actually, it takes this, it takes at least that to address it, and you have to compare your measure with this thing that we need to do to at least stall it. And so that is a reason I like the metrics, but I very much sympathize with David's idea that we need to go much further, and that this is in many ways a spiritual crisis of mankind, that our way of life is not compatible with this one planet we live on. And so I found it very stimulating. And
so, I mean, I understand exactly, how these metrics have developed and evolved, and the attraction of them for policy, for communication, for the ordinary individual. But my point is just to push back against the danger of letting these metrics swamp these other modes of what I call moral reasoning, as though the metrics themselves are actually what matters. There's something else behind the metrics that matters more. And actually this was pointed out way back in the climate change story by Anil Agarwal and Sunita Narain back in 1991 with their study, Global Warming in an Unequal World, and they for the first time drew out this distinction between survival emissions and luxury emissions, that physicists concerned about radiative forcing in the atmosphere, molecules of CO2 are molecules of CO2. They do exactly the same job in terms of radiation physics. But as Agarwal and Narain pointed out, molecules of CO2 do not carry the same moral valence. A molecule of CO2 that comes out of a tailpipe of an SUV in America has got very different moral standing to a molecule of CO2 that comes out of a peasant woman's cooker in the middle of India. And so metrics can obscure what actually really matters when it comes to questions about human justice, ethics, and moral reasoning. And that's what I'm not pretending that we don't need metrics, but they need to be placed within a bigger context, which I believe other forms of reasoning, traditional knowledges, religious knowledges, other forms of ethical, philosophical reasoning can provide us with.
Dr. Alley.
Yeah, I'd at least like to suggest that you try, rather than either or, yes and.
Yeah.
We need metrics. We need to get started soon. Cumulative CO2 matters. If you actually have to build a new moral understanding before we move, we are going to waste time. It is very clear that if we reached an economically optimal position, that there are very strong ethical and moral reasons to go further. But I really would like to see a yes and rather than an.
Well, that's why I said that they should be subservient, that they should not stand on their own. And I would put if we don't have any sense of why we're trying to achieve certain things, which has to come from these other ethical, moral orientations, then what are we trying to do with climate change? there has to be some larger narrative and purpose.
Save lives, save money.
Okay, but that is a form of ethical reasoning.
But the metrics.
Whose lives are we trying to save the most?
Of course.
Which is an ethical question.
So first of all, of course, science cannot produce an answer. We don't go from is to ought. Got it. So anybody who thinks there's some technocratic group of scientists where you can feed in all you know about climate and the economy and turn a crank and get the right answer, not happening. Of course. I think most people in this dialogue know this. Values matter in a central way, and the values that are getting young kids on the street doing stuff are crucial to this. So the values are informing the debate, but when we, driven by values and that drive politics and have our debate, when we actually want to do something, having metrics is, maybe there are better ways, but it's a way we actually get stuff done in our societies. You know, you think about air pollution, traffic accidents, infant mortality. we've driven all of those way down. And metrics played a big role. And that doesn't mean that the metrics just came from space, or that people lost sight of the moral value of children, or of not having auto accidents, or of having clean air. That doesn't mean that people arguing about those metrics didn't understand the profound injustices and ugliness of dirty air. I've been in those arguments. I've been in the arguments in the climate rooms. It doesn't mean we forgot all that. But to pretend that you can just have a conversation and not have metrics, which I know you're not quite saying, but it sounds a lot like that, is basically to say you're not going to make progress.
Dr. Liverman, and then Dr. Hume, if you'd like to respond.
So my reaction, Mike, to your talk was, well, first of all, I know I sound like I'm defending IPCC, and I'm actually, I'm an Earth commissioner, not an IPCC commissioner, but we included ethics in the report. There are now philosophers and humanists who step up to be authors of IPCC reports, and I think our biggest struggle in the 1.5 report, which has an extensive discussion of ethics and morals, was the question of universal versus varied. But when I saw you put up those 5 ideologies, it made me recognize that as an individual, I've got a bit of a panic going on right now, because I bounce back and forth between those. I mean, one day I'm anti-capitalist, the next day I'm an eco-modernist, and it's because maybe I'm, solution addicted, that I want the solutions and I'm bouncing back. And in a way, for me, all of those ideologies are offering something for us moving forward. So it was a little bit of an artificial contrast, because I think for many individuals, we're trying to hold many of those ideas at the same time.
But I think that in a sense proves my point, in that it is that level of discussion that the real action has to happen. And actually, not all of those positions that I outlined there are compatible. I mean, there are some deep incompatibilities, not least around economic growth. Mm-hmm. That there are many people motivated through moral and ethical, cosmological, whatever forms of reasoning, that actually growth, as modernity has constructed it, is fundamentally incompatible with a stable and benign climate. And there are other people who passionately will say that that is completely the wrong line to use to tackle climate change. So those are contrasting positions, and those arguments are not ones that science will resolve, is my point.
But do you not think that there's a technical possibility of growth that is not damaging to the climate?
Yeah, personally I do, because I probably err more on that side. But what I'm saying is that there are people of integrity and passion who do not believe that. And unless we recognize that and allow that to be at the center of the discussion, rather than hiding behind science or uniting behind science, then actually we're not going to get to the bottom of how we act in the world. And that's why I push back a little against some of the protesters who, and Greta Thunberg isn't the first person who's done this. Many, many people over the years have taken science as being as though this is the moral ground, or this is the ethical orientation that I need. And I need no more than that. We need more than that. And Greta's got that, but don't pretend that this is about uniting behind science.
Dr. Keith, and then I'd like to ask if Dr. Watt-Cloutier or Dr. Ghosh has something to say.
I certainly completely agree with you, and I think you've done a really good job saying it. And I think that some of my colleagues who've been too tempted to, go in front of Congress and say, the science says this and you must do X, have really made a deep mistake that I think is part of what has helped to build the attack on climate science. Because essentially it left the opposition no other easy political next move on the chessboard. That's instead of saying, here's the science, here's my values, here's what I think I should do, which is something more like the actual full argument, because you can't just say, here's the science, it's damn, I completely agree. By saying the science drives you directly to action, people who didn't want that action then end up trying to, in a kind of mostly foolish way, pick apart the science and weaken it, and and politicize it. So that part of what you're saying, I actually completely agree with. I think it's a really important point, and it hasn't been learned enough. We need to do a better job of separating these things.
Me?
Or if you wish.
Why don't you go first, Sri?
Do you want me to go first? Well, I think I appreciate both of the presentations, of course, and some of it is a little bit over my head, but that's just who I am. And but I do value, of course, the work of scientists. We've always, felt that there was a partnership that was being built, especially through the ACIA. In that sense. So I've always valued, and I've, there's been crisis over the years during that work where I had to fly and defend the scientists' work when it came to the politicians trying to squash down that assessment that was so important for us in the Arctic and the indigenous peoples of the North. But I must say that the balance has not always been there, so I truly appreciate your presentation in that sense of putting that balance there in terms of the attention and in terms of the focus that is often put on science alone, as the solution, or technologies alone. And that the voices of those, when you speak about, and on your presentation, talk about the storytelling and humanities, that really spoke to me. And that I appreciate very much. And I appreciate the dialogue that's happening here. I'm just going to observe it for a bit here. But for me, yeah, it's that balance, I think, that needs to be said. And then you've said it very well. Thank you. Yeah.
Dr. Ghosh, and then Dr. Liverman, if you wish.
Well, let me say, first of all, that I very much appreciated your presentation, Mike. I think you're absolutely right to try to, to contextualize the metrics, I think the metrics certainly are useful in the sense that they're the only thing that governments today listen to. So in that sense, or even activists seem to listen to, because these metrics have a position within Western culture which gives them a certain power, and now within global culture. So yes, they're certainly useful in that sense, but I think you're absolutely right to say that, we have to figure out, and exactly as you said, Gabriella, that we all recognize really that at the end of the day, something has gone wrong with the way we live, and there's no getting around that. We have to try and find some other way. And are we going to find that other way? Well, geoengineering, I think engineering should be renamed, the science of unintended consequences. When James Watt invented the steam engine, and actually the curious thing is that the transition from water to steam power didn't happen very easily because water was free, it was cheap, and it was just as efficient. There are spinning mills in Scotland that until the 1870s, they were using water to produce just as well as steam. Why did steam win out? Why steam won out? Because it made more money for capitalists, and it allowed greater social control. And that's been the case with every kind of engineering technology that we see. So, spraying sulfuric acid into space, well, what could go wrong?
Dr. Keith.
Really, but, what can one say? The trouble is that I think one has that terrible sinking feeling in one's heart that this is going to happen. Why? Because over the last 4 or 5 years, I can see the discourse that comes out of Yale, their climate communications unit, and from various other major universities, that there is this process going on of normalizing these interventions. And I think at a certain point, we're just going to be told, as Margaret Thatcher used to say, there is no alternative. So the disease will become, who will bear the consequences? I mean, at some point, it will be, the poor, as has been happening with these technological and engineering interventions for the last 200 years. There'll be, suddenly we'll see that the monsoons won't flow in the way that they used to. And we'll be told, oh, well, too bad, that went wrong, but now let's move on to another step, something better. So, I think really at the end of the day, when we come back to what Mike was saying, I think it all now rests on the young people, that they can stand up in the same way that, generations of Chartists and Wobblies and Vietnam protesters, etc., stood up and say, no, we need a change of course. We need to change our ways of life, just as we all acknowledge that we need to.
I know Dr. Ali, unless Dr. Keith would like to go first.
Right.
Dr. Keith or Dr. Ali? I know both.
No, it's a completely laughable thing. I agree.
Right. Do you want to?
I will, yeah. So two things. First of all, I think in this conversation, we're moving towards a misrepresentation of science, including social science. Because for me, a lot of the research that we've done on climate change, it's not about saying, we found this, you do that. It's about offering people choices. That's why we do so much work on scenarios. That's why we write reports called America's Climate Choices. It's saying, if our understanding is if you make this choice, this may be the geophysical and humanitarian outcome. If you make this choice, it will be this. And I think most scientists are viewing it that way, that what we're trying to do is offer choices and not advocate for a particular choice, allow values, whether it be in a democracy or within an individual, to then select the choice. And the second thing I want to say is, I think I want to stop dumping this all on youth. I'm really glad you're active. But, you know what? I'm still alive and I should be doing something. I shouldn't rely on you. We should be doing it together. Yeah.
Dr. Ali, did you want to say something?
Yeah, so if I could come back, and this all sort of fits together, but it's a question for David. So, and let me do the whole thing before you get mad. I have never met the person who wants to live with high CO2 under a stratospherically clouded sky. But if we make fatal heat, I have never met the person who would say, let them die under a clear sky. And so this is knowledge that we desperately want, and it's knowledge that we desperately don't want to use. And it all comes back to moral hazard. And you introduced this, right? You have thought about this probably more deeply than anyone else. But can you expand a little more on how going forward we gain this knowledge while handling the argument of moral hazard, which is really what we're all worried about, that somehow by gaining the knowledge that will save lives if we need it, that we will guarantee that we need it. And that's all of the arguments I've ever heard on this are either often left field or else they deal with the moral hazard of this somehow. And you have thought more deeply about this than anyone else has.
It's a great question. Thank you. I draw mostly on analogies when I think about it. Analogies to other situations where these moral hazards or behavioral rebounds or something have been at play, thinking about what people said and how the outcome played out. So I mentioned traffic accidents before. There's been about a factor of 5 roughly decline in mortality, in number of people killed per kilometer you drive in the US, say, over my lifetime. And that's been a big range of different things. So it did involve stuff that was pretty much pure tech fix, like airbags. And in fact, people opposed the introduction of airbags in print and with some seriousness because it would be a technological fix and just encourage people to drive faster. But in practice, what's happened is a whole network of things, some that are primarily technical, like airbags, but some that are really social, like graduated licenses. Young people know what I'm talking about, that you don't just get a license, but you get a license of different categories as you go. Like many of us learning to be much more cautious about driving with alcohol, like changing roadways. And these things all fit together. Was there some rebound? Was there some classic moral hazard inside? I am sure there was. That is, if you, when I drive a car now, I am more casual than I would have been driving a 1970s car, because I know I'm much more likely to walk away from a crash safely than I would have in a 70s car. So there's some risk compensation that goes on in my head, and I think it's real and natural. And I think that's true of almost any one of these systems, that the interaction between behavior and these risk compensation behaviors and these larger social behaviors are there always. But I don't think that is a reason, but in many of these cases, we've still actually really made huge improvements in the underlying outcomes. That's true in all sorts of health interventions as well. So the idea of some kind of moral hazard rebound, the idea that when you make something a little bit safer in some way, then people want more of it, it's everywhere. And I think it will be part of the way this plays out. But the hazard, of course, is there no matter what. The hazard's there, you can't get out of it. And I think it's hard for me to see in the near term how that hazard of solar geoengineering really would strengthen the forces that are trying to block action. Because remember, it's not simply that Exxon will say it, that's got to buy them more political traction. And that means that the forces that are fighting on the other side have to loosen up. And I don't see that in the near term. I don't see that happening in a huge tipping point, but that's fundamentally a political judgment, I guess. But it's a deep question. I'd say look at the other examples. And one last comment is think carefully about the ethics of saying that people can't be trusted with life-saving information. You know, there were people who opposed making the AIDS triple cocktail available in Africa because they assumed Africans would misuse it. I can keep drawing these examples up. I think the bottom line is when there are things that can really save lives, our job in the technical community fundamentally is to tell what we know. It's not our job to make the decisions.
Dr. Heggerel.
One thing, though, that is different from between life-saving technology and geoengineering or solar geoengineering is that you can't address ocean acidification, so some life will not be helped at all. And I worry what this is going to do to the oceans, and that if we think if this were the only thing we deploy, then it would be just as catastrophic, I think.
Yes. If we stop emissions cuts, just keep emitting forever, and all we do is solar geoengineering, it's just as catastrophic or more catastrophic, no question. But again, if you think of the real world of complicated problems where there are many different factors at work, rarely is there a single problem, single solution, there are lots of these interplays. And it's not true that when we introduce one thing, people forget all about the other things they're going to do. So the answer is that ocean acidification is driven almost entirely by CO2 emissions, which we must drive down. But let me actually introduce a little empirical evidence. So I don't think this is that convincing, but it's worth getting some evidence on the table. So if you expose people, including North Germans, it turns out, to take them in two groups, expose them both to some information about climate risks, give them some money. At the end, you're going to ask them if they want to give that money back to pay for carbon reductions. And you take one group of people and tell them about solar geoengineering, and another group you do not. Which group do you think spends more of the money, gives more of the money back to cut CO2 emissions? It's the group that was told about solar geoengineering. That's now a consistent result over about 30 experiments. With fuzz, the one I quoted was from Christine Merck, and it's a very cleverly constructed one. Some of them are not so well constructed. But at this point, it's just beginning to be something that you might almost consider a robust result. That in fact, when you tell the public more about solar geoengineering, they are more motivated to cut emissions. Now, there are a lot of reasons that might be true, and that doesn't prove that that's what will happen politically, but it suggests that the very high confidence that that will be the result might be overconfidence.
So on the subject of telling the public about what solar geoengineering is, there have been several people in the audience who have said, could you just do like 2 sentences for those of us who really don't understand it at all? Could you do 2 sentences on what solar geoengineering is?
The idea that, say, by putting aerosols, little droplets in the stratosphere about 20 kilometers over our heads, we'd reflect away a little bit of sunlight and reduce some of the climate changes from accumulated carbon dioxide.
Okay. Thank you.
Could I just ask, when they give the money back, it's for mitigation, emission reductions. They're not giving it back for geoengineering.
Oh no, it's
okay.
yeah. And there's a bunch of different versions of these things, but it does appear that when people learn about solar geoengineering, they're actually kind of more incented to do something to cut emissions. It may not be robust, it may not last, but that is actually what evidence we have so far. And also, very surprisingly, in the last 6 months, completely opposite of what I expected, some of the US right-wing climate denial organizations have begun to weigh in on solar geoengineering, and stunningly, they weighed in against it, whereas some of the big environmental groups have weighed in for it. It's very interesting to think about what are the political dynamics driving that, but I think part of it is that it's actually, part of it may be that the climate denialists still really believe they can win the argument that there's just no problem there anyway. But the other part of it may be this kind of incompatibility, that you can't both say humans can't really change the climate and, oh yeah, there's this easy way to change the climate. It just makes no sense.
Before I turn to audience questions, Dr. Hume, do you have anything you'd like to say?
Yeah, just a couple of things. One just quick response to Diana's point about the role of science or social science. Absolutely, that's exactly what science and social science are brilliant at being able to interrogate the world, inquire into the world to see what would happen if we did this, and to make that knowledge and that insight available. But that isn't how very often the insights of climate change are presented in public discourse. How many times have you heard the science tells us we need to?
That's the media says that.
Whoever it is, what I'm pushing back on here is to understand. Winston Churchill in the Second World War, he wanted his scientific advisors during World War II to be on tap, but not on top. The question is here, we want science and social science and engineering and all these technologies to be available for us, but actually it is we as humans, as societies, as cultures, as political entities who make these choices. So science is available for us, but it is not telling us what these choices should be. And just maybe one thing for David. We've debated this 2-3 times before already. But let me put this to you. So you're a good advocate for doing research on solar radiation, and a lot of this in terms of how the Earth system would respond is conducted within computer models, and you showed some of those results. What concerns me, the various things that concern me about it, but one thing is by introducing deliberate intervention into the climate system, you are actually changing some of the geopolitical risks and challenges that we're presented with. And you cannot do model experiments as to how those geopolitical risks are going to emerge. So one would be, for example, if 2 years after you started spraying in the atmosphere, the Indian monsoon was 20% below average, immediately people are going to think, hey, these guys were spraying atmosphere with aerosols. We've now got a collapse of the Indian monsoon, cause and effect. Now, a question for Gabby, could your models then be able to tell us how likely was it that the Indian monsoon failed because of what David was doing in the stratosphere?
Just to be clear.
And as soon as this happens, you then open up an entire new discourse.
I am not doing anything in the stratosphere. But
it's rhetorical, David, it's rhetorical.
Yeah. But back off on that rhetoric. That's not fair. Yeah.
My point is that it opens up new fronts of geopolitical instability, because this question of attribution is going to become absolutely central. And unless Gabby can tell the Indian government with absolute certainty and confidence that it's got nothing to do with what David was doing, where do we go with that?
That's exactly my concern, that rainfall is too noisy, too unpredictable. It will take. My concern was more that I don't know if it would be the monsoon or that rainfall reduces somewhere, because it doesn't exactly respond like in the models. We have differences in size in the observed response in rainfall to that what the models do. We don't quite understand what it is. It could be even the data, that the data have problems, but we don't understand. The data are not robust enough, and rainfall varies, as we all know. I mean, it rains today and it doesn't tomorrow, and it will take quite a while to establish if it was actually geoengineering or if it was just bad luck in a drought, as we have faced many times before. So I can't see how that could be resolved, and it could create a lot of controversy. I agree.
David Keith, real quick response.
It certainly could. I think that's one thing that's wonderful now is there's some groups really thinking about that. So Janusz Pastor, who was formerly the chief for climate for Ban Ki-moon, so the person most in the middle of the UN system, is running an international effort to explore that. And I think there are actually lots of mechanisms in principle to manage conflicts like that. I mean, those conflicts are exactly the ones we've worried about for decades and brought up for decades. And it's important to say that the idea of some fractional impact on other states by a state's action is going on all the time now. So there are many thousands of North Americans who die from Chinese air pollution and some Europeans who die from American air pollution. We can calculate it with some numbers. I produced a quick paper estimating how many people died from VW's lie. We do a bunch of this fractional attribution all the time. There are already impacts from aerosols that we emit for air pollution that change the climate, and we can do fractional attribution for that. This is all already there. There are already impacts. We're making changes that are not a lot bigger, if geoengineering ever happened, compared to those changes that are already happening. So I think this isn't as far out of the norm of how we settle things in international negotiations as you might guess. There already are international liability regimes for many environmental harms with banks and payoffs.
So there's a lot of questions about trees. Could we not just plant a lot of trees instead of looking at geoengineered solutions? There's also questions about, is there problems with acid rain? And my 9-year-old twins would like to know, how dim would it get under your plan?
Well, that's the human choice. Depends how much you do. But if you're talking about the amount that I and people in some environmental groups are talking about, which would be doing it as one addition to all the other things we do at the level of a watt or two per square meter, then the answer is it would be completely invisible from the ground, and really completely invisible. So there'd be no dimming that you could see. And it wouldn't even make sunsets different in a way that was particularly noticeable. Sorry, the other questions were trees. So, in a deep sense, the long-term carbon problem, and Richard could do this probably a lot better, is caused by moving fossil carbon from the geosphere, from deep underground, to the active biosphere, where that carbon can then equilibrate between atmosphere, land, and ocean on various timescales we don't control. That's what drives the climate problem. Nothing you do about planting a tree can undo putting a ton of carbon into that system. It's just a fantasy. There are lots of short-term utilities. Trees are wonderful things, but a tree is not a negative emissions. If you wanted to make something like negative emissions, and it would still never be perfect, you need to somehow put that carbon back into the geosphere, where it stays for very long times. Trees are the trees don't just last forever; they die. And not only that, their forest fires depend on future climate change. So if you plant a whole lot of trees to protect yourself from climate, putting more carbon into forest stocks, you actually build yourself up a bigger burning pile, which can burn under a hotter climate. So there are a lot of complexities about risks. Trees are also dark. So trees in northern latitudes actually can be a wash for climate benefit because their carbon benefit is kind of offset by their albedo darkness. Short answer is focus on protecting ecosystems because you love them. Focus on protecting ecosystems for all sorts of other things we care about for ecosystems. Focus on planting trees because we love having trees, but don't think that trees are some substitute for dealing with carbon emissions. They're not.
Can you also talk about if there's any danger of sulfuric acid, like acid rain?
Yeah, the acid rain. Short answer is no. So that there's a lot of different risks, but that turns out to be pretty much a non-issue. if you did solar geoengineering with sulfates at the kind of level I'm talking about, you'd be talking about a few million tons a year globally. And we now put 50 million tons a year of sulfur in the lower atmosphere, or a little less now. This is the stuff that kills us and causes acid rain. Also, that's concentrated, and acid rain turns out to be nonlinear. So that really is not an issue. In fact, air pollution is a bigger issue, and here's a useful number. Our existing air pollution is already cooling the planet, so we're not seeing the full effect of our warming. If we stopped all industrial action now, the world would actually warm a little bit as we unmasked the cooling from aerosols. Actually, quite unclear how much, and not even 100% sure. But you can calculate the ratio of the the cooling effect of aerosols to the health impacts of aerosols, because they both cool the planet a little bit and they kill us. And if you put a kilogram of sulfur in the lower atmosphere compared to putting a kilogram of sulfur in the stratosphere, the kilogram of sulfur in the stratosphere has 1,000 times more warming impact per unit of health impact.
Dr.
On trees, I think the one issue is it actually is important to protect trees for the climate, because we do not want more trees cut down. But it's not just about trees, it's about land use in general, because grasslands are important for carbon, and agriculture is important for carbon.
Soil.
Soil is important for carbon. So all of those are part of the carbon cycle and part of what we need to look at with climate. But I think there is one thing that's important about what you're saying in terms of impermanence of forests as a solution. And if you look at countries' commitments under the Paris Agreement, what's called the nationally determined contributions, there's a very large number of countries, including Canada and the US, who are saying they're going to make their carbon reductions by planting trees. And that is a concern because of some of the things that you were talking about.
I think what we need is sort of different colors of currency. So not emitting, or in principle, something that recaptures and puts in deep storage, whatever risks and costs there are, that is the gold standard in terms of carbon accounting, understanding the limits of carbon accounting. Putting carbon temporarily in the trees and soils could be a terrific thing, but it's just can't count permanently because it depends on the way the farm or forest is managed decades in the future, and there's no way to guarantee the way that will happen a century in the future.
A question for Dr. Hume. Humanities can indeed be a guide to morality and ethics, but how should we respond when humanities are used for morality that drives hate? Should I read it again?
No,
I think it was also cut off. There was more to it, but...
Okay.
So what about when the ethics might be an ethic of hate?
Like we hate fossil fuel companies, or we hate immigrants, is that?
Perhaps.
I mean, okay, so different ways I could answer the question. I mean, at one level, humanities as an academic discipline is, again, like science and social science, is a form of inquiry into how the human world, the human imagination, our reflection on who we are and our place in the world works. And humanities then will identify, I guess, some of the ways in which humans cultivate what traditionally would be called the virtues, but also how and in what circumstances undesirable human traits are given salience or are given or are animated. So humanities is not, in that sense, again, it's a form of inquiry into how the world works. I suppose the question about hate, as soon as I think of hate and humanities, and by talking about religion, maybe the question is more about how certain religious modes of thinking and reasoning and action in the world might contribute to a more hateful society. And for sure, I mean, and again, we know historically how this operates, and in our contemporary world, we know how this can operate. So I think what the humanities can then do is to reflect on, well, how is it that religion can act both as a force for moral good, but also as a force for moral evil. Where do those instincts, where do those traits, those patterns actually emerge from? And good scholarship, good contributions to public debates will be able to temper those religious institutions that are oriented in directions that cultivate human tribalism, human greed, the will to power, and so on. Gabby was asking me before, I mentioned about the papal encyclical from 2005. Of course, many other religious traditions have made significant statements and contributions about how their own particular religious traditions and practices would engage with the questions of climate change and the types of moral responsibilities and duties that come out of those traditions, whether it's in Islam or in Buddhism, in my own church in the UK, the Church of England. So there are many examples of how religious institutions have mobilized their own resources in order to offer perspectives and actions that would deal with some of the risks of climate change. The papal example, though, is particularly interesting, partly because the Catholic Church, of course, is very centralized, so a papal encyclical carries much greater weight than in most other world religions. But also the very holistic narrative that the Pope developed in that encyclical, that he took science very seriously. He took environmental degradation and change very seriously, but he placed that into a much larger narrative, which ultimately was, of course, about a Catholic cosmology and a Catholic understanding of God, but also drew this very much back to the human experience of being in the world. And so to me, that was a much, there was a very good example of holistic thinking that was duly respectful to all of the different modes of human inquiry and reasoning that we have developed over many, many generations.
Mm-hmm.
Maybe go ahead.
Go ahead.
Maybe a question that invites participation from any of you comes from this questioner who asks, how do we balance a fast response to climate change with a robust exploration of values questions? So how do we split that hair, or how do we tame that two-headed beast, perhaps, if you want to think of it that way? Or, depending upon your understanding about the relationship between those two, and there are obviously dramatic differences among the panelists about their understanding of the relationship between science and values. But given how you understand that relationship, how would you suggest that we do both of those full speed ahead?
Okay, so I suppose the way that you asked the question, the sense is, well, we haven't got the luxury of...
Well, I'm channeling a questioner who's saying, yeah, we really don't have the luxury of time here.
So a couple of things I'd say to that. One is, well, it's not helped by putting artificial deadlines on when we have to act by. I'm rather resistant to the notion that we only have 5 or 10 years, after which it's too late. The idea of these cliff edge moments, it's never too late to do the right thing. Actually, if you want to look at climate change in a completely different way, which I think Sheila was drawing attention to through her experiences, it was too late 100 years ago for some communities in the world. So the idea of these artificial deadlines by which we have to act, we have to get to net zero in 5 years' time, isn't actually very helpful because it's never too late. So the other way of thinking about these sort of different temporalities is that humanities are not, they're not going to offer you a solution. There's no end point. This is a constant dimension of human experience and life. That's how we experience the world. We are moral, imaginative beings. And we need to give space for those to flourish. Yes, science and technology will come in and suggest we might do this, we might do that. But all along, we have to give space to these moments to reflect on the ethics of
solar climate engineering, as David was pointing out. And that takes us into a more political jurisdiction as well. What are the mechanisms? And this is another question I want to ask David. How do we provide these larger global forums to deliberate on some of these questions? Because actually it will influence every single person on the planet. So that is something that the humanities actually can contribute to, different forms of deliberation, that allows these ethical questions to be put in the foreground. So in a way, the humanities is not time limited. It has been with us since humans first began to have a degree of self-consciousness about who we are as moral agents in the world, and it will be there still 100 years into the future. Whatever happens to the climate, we will still be thinking about what is it to be a virtuous human being, even if the world is 4 degrees warmer. And there is still a role for that form of reflection in whatever world we live in. Otherwise, we stop being human.
So I would chime in on what Diana said before. We in the IPCC have just bent over backwards not to tell anyone what to do and never to say it's too late. The idea that the scientists said that we must do X is complete nonsense. The scientists said if you do not do X by time Y, you will face these consequences Z. And we don't predict, we project. If humans choose this path, then these are the responses. And then there are people who do use that and say, well, the scientists say that we have to stop by time something. But we, and some of us have even sort of, I mean, we're people. We have opinions, we have families, we have desires, I vote, but I sort of self-censor a little bit just to make sure that it's very clear that the science tells you what is and what can be, but that you're going to make decisions. So I do not believe that we in science are guilty of telling you what to do.
Yeah.
I wasn't making that accusation.
Let's go to Dr. Hegerl, and then Dr. Liverman, and then Dr. Hume.
The direct follow-up, I totally agree with what Diane and Richard just said. It is, for me as a scientist, it's really important that I have my values and I have my, as you've heard, I have ideas of what we should be doing, but my role as a scientist is to say what do the data tell me, what do my model tell me, and my role in the IPCC is to give out these alternatives. You can do this, or you can do that, and this will be the consequence. And it is really important that we are extremely careful not to bring our values in through the back door by making follow-up statement. Therefore, you have to do this now, which is driven by my values and not by my scientific results. On the other hand, I think we would be incomplete humans if we don't have our own values and our desires of what would happen next. And I haven't really found a good solution of what to do about that other than trying to keep those out of public discourse or saying clearly this is what I personally think, but you could come to a different conclusion. And I think many scientists go about it like this, but there are some colleagues who mix both up in a way that I don't find very helpful.
Oh, go ahead. I'm sorry.
Dr. Liverman, and then perhaps Dr. Hume.
Sorry.
So I interjected a moment ago saying it's the media, and of course the media is very differentiated, but I've been deeply disturbed by the 12 years and apocalypse narrative that is out there. People have come up to me, my neighbors have come up to me and asked me about it. I can see young people being really worried about it. And, we didn't say that. The science did not say that. Actually, the press release from IPCC hinted at it. But actually, the alternative narrative is, in the report, we say if you really want a good chance of staying under 1.5, you actually have to cut emissions 60%. That was the most sort of secure scenario that we generated. But the other thing is, we just picked, I said this before, it was an arbitrary point at 2030 on the way to 2050 in order to keep things under 1.5. And I also worry that the 12-year narrative means some people think we've got 12 years before we have to act, and we have to act now, and we have to act yesterday. So the way in which the media looked for the simple message from the report, and the way that has traveled, whether it's into the Green New Deal or Greta Thunberg's speech at the UN, I know it's motivating action, but I do worry that people didn't look at the choices we offered. They've picked one thing to focus on. So actually 60% by 2030 if you actually want to work that narrative.
Dr. Hume, any comments?
Well, no, I agree, and I think it's great that Richard and Diana and Gabby, said that. It's absolutely important for people to hear that.
Yeah.
Another question, I believe this is directed at Dr. Keith, but perhaps for anyone. Who owns space, and perhaps they also mean the stratosphere here, who has the authority to decide whether or how to deploy solar geoengineering?
As a matter of explicit law, there's very little. So for space, there's an outer space treaty, wouldn't be decisive here. For the stratosphere, the answer is countries own the overlying airspace, but their customary international law does impose a duty on states not to cause harm to other states. So no simple answer. I think that's being too academic. The point is, that's what we need to work out. And the reason that people like me are saying that we ought to be talking about this is it gives us a longer time to start thinking through the answers to those questions. So to me, the best way to come up with the answer to the questions about making those decisions is to debate it for a long time as democratically, albeit imperfectly, as we can, not to keep quiet about it forever and then suddenly figure that question out in a time of crisis. I'd like to chime in on the engineering question, I think, that you raised. I think, is engineering the science of just producing bad side effects? I mean, there's no objective way to say. On the one hand, all of us in this room and in the world today are fundamentally dependent on engineering and the continuous engineering processes to be alive. We didn't necessarily have to do that, but that's where we are now. You don't necessarily see it, but there's a kind of bulwark. The whole existence of big cities depends on the control of disease. We couldn't have as many people on the planet if we didn't synthesize nitrogen from the air at a rate as big as the entire natural nitrogen process, where we deliberately, and it was deliberately, engineered a planetary process for human ends. Do engineering interventions produce side effects? Of course, all the time, and people try and estimate them, but they never get it right. But there's a long way between that and a claim that any engineering attempt to solve a problem is always doomed to failure. Because in fact, the record of engineering solving relatively defined problems, and solving maybe is the wrong word, but substantially reducing them and making the world better, I think is really strong. That's partly why we live in a world that in all sorts of ways is made better by the products of rationality and engineering applied. But it itself, it needs to be our servant. It cannot and should not, and technocrats could not and should not, make the decisions about where we're going. So the point is, the fundamental decisions about where to push that engineering machine, what goals it should be seeking, are decisions that we as humans need to argue about and through our political processes to get to some outcome. But I think the idea that, I'm not saying it's clear enough, we are in a dynamically unstable situation, in a planet with this many people on it. It is not an option, short of mass death, to kind of step off to a world without engineering. We're committed for now. We could conceivably work our way down from that world to some really different world in centuries, but for now we are completely committed. The choices is what social choices we make with it. Do we keep endlessly ratcheting up consumption and at the same time trying to compensate for it? I would not vote for that. Or do we find ways to ramp down consumption, but also to find engineering ways to reduce the impacts of our consumption? That's what I would vote for. And they will be.
On that eloquent note, I want to thank all of our presenters, discussants. We are so honored you have been here and we have learned so much from you. Thank you very much.
Thank you. As an educator, I can't, as an educator at a liberal arts college, I cannot not take advantage of the opportunity to observe that this conversation we were having right now is really a debate that we should be having in the public sphere. I very much appreciate the scientists saying, that's not what we're doing. And I very much appreciate what Professor Hulme is saying about the importance of a certain kind of conversation. Notably, humanities departments across the country are being closed because they are regarded as frivolous. And here at Gustavus, that's something that we understand is not the case. And what I'm hearing here is an opportunity for us to really think together about how do we have questions about values and about science in conversation with each other. And that's what the Nobel Conference is all about. And I'm so pleased that we had this last really robust discussion, because I think it gave us something that that we'll all leave thinking about. I'm a little bit breathless because it's very close to my heart. And so please support your local everything departments, because we need them all. And yes, indeed, thanks to all of our speakers for their amazing presence here. We all have benefited enormously from that. And please come next year for Cancer in the Age of Biotechnology. And let me just tell you again, improved knowledge of how cancer progresses and of how patients' immune systems respond to cancer has allowed for the development of novel therapies that are more effective and targeted specifically to kill the cancer cells with fewer side effects. Many of these innovative treatments are based on antibodies, other complex biologically derived molecules, and genetically modified cells. The complexity of these drugs allows for their specificity, but also makes these drugs particularly expensive to develop, produce, and administer. And that's what we'll be talking about. I call it a version of the problem of, can God make a rock so heavy he can't lift it? This is, can we make drugs that perfectly solve the cancer problem, that perfectly cure, but are impossibly expensive. So that's in 1 year's time, and don't forget, you can buy your tickets here still. Thank you all very much. Safe travels on your way home, and try to do it with less carbon emissions.